Welcome to the Complete JavaScript course. In this course, we're going to learn how to build complex websites using JavaScript from a beginner to a professional level. And by the end of this course, we're going to build Amazon.com. So this is an interactive multi-page website where we can add products to our cart, create an order, and even track our order. Along the way, we're also going to build some smaller projects like a rock, paper, scissors game, a to-do list, and a calculator. Now, you don't need any previous coding or technical experience to follow along. This course will cover everything that you need to learn JavaScript. We're going to start from the very basics of JavaScript, and we're going to build our way up step by step. We're going to learn the major features of JavaScript and also how to use JavaScript together with other technologies like HTML and CSS. These are the topics we'll learn in part 1 of this course. In part 2, we'll learn skills that are useful for bigger and more complex projects, and we're going to start and finish the final Amazon project. You can find the different lessons of this course below the video here and here. And after each lesson, I'm going to give you a bunch of exercises that you can do on your own to practice the skills that we learned. In total, this course will have over 200 exercises. So with that said, let's get started. Before we begin, if something in this course is not working properly, make sure to check the first comment below the video for a list of solutions. If you can't find a solution in this list, you can reply to this comment. I'm going to be doing this course on Windows, but the steps are the same if you're using a Mac. We're going to start from the very basics of JavaScript and build our way up step by step. First of all, what is JavaScript? JavaScript is a technology that we use to create websites. A website is like YouTube.com or Amazon.com. It's how we access YouTube and Amazon on our computer. If we were using a phone, we usually use an app, but on our computer, we use a website. So there's actually 3 technologies that we use to create websites: HTML, CSS, and JavaScript. Each of these technologies has a specific purpose when creating a website. HTML creates the content of a website. It creates all the buttons, the text, and the images. CSS changes the appearance of the website. By adding CSS, we can make our website look nice. And finally, JavaScript makes our website interactive. So if we only have HTML and CSS, and we click one of these buttons, our website doesn't do anything. But once we add JavaScript, we can make our website do something when we click a button, such as add a product to our cart or create an order. So this course is focused on JavaScript. If you want to learn HTML and CSS in more detail, I have a full course just like this one that you can find in the video description. Let's get started with JavaScript. The first thing we need to do is to install a piece of software called a web browser. A web browser lets us view websites that we create in this course. The most popular web browser for web development is Google Chrome, so I recommend using that. If you don't have Google Chrome, you can open the default web browser on your computer. For Windows, it's Microsoft Edge, and for Mac, it's Safari. Type in google.com at the top and press enter. Search for Google Chrome. Click the result and follow the instructions to download and install. Once we've installed Chrome, we're ready to begin. We're going to start by learning what exactly is JavaScript and how does it work. The easiest way to understand JavaScript is we're basically giving instructions to a computer, and then the computer follows our instructions. I find the best way to learn this is to jump in and give it a try. So first, let's open Google Chrome. Next, we're going to click at the top here and type supersimple.dev/js-basics and press enter. And now we'll learn how to give our computer some instructions to follow. To do that, we're going to go to a blank area of the web page. We're going to right-click, click Inspect, and then click the Console tab. Now, if your console doesn't show up at the bottom like this, you can click these three dots here, and then select this icon. Okay, so inside the console, we can give some instructions for our computer. Let's learn our first instruction. We're going to type here, and we're going to type alert, open bracket, single quote, hello, single quote, close bracket, and semicolon. Make sure to type this out exactly as I have it here. In JavaScript, if you don't type things out correctly, it won't work. So this is an instruction to create a pop-up with the text hello inside. To get the computer to follow our instruction, we can just press enter. And as you can see, the computer does exactly what we tell it to do. It creates a pop-up with the text hello inside. Now let's press OK. And let's give another instruction to the computer. So we're going to type here again, and we're going to type alert again, open bracket, single quote, but this time we're going to type a different message in the pop-up. Good job, and single quote, close bracket, and semicolon. So this is an instruction to create a pop-up again, but this time with the text good job inside the pop-up. If we press enter, the computer does exactly what we tell it to do, and it creates a pop-up with the text good job inside. And that's basically the main idea behind JavaScript. We're giving instructions to a computer, and then the computer follows our instructions. So note that we can open and use this console on any website. We're just using supersimple.dev as an example. Let's press OK. And we're going to learn some terminology. The instructions we give to our computer, these instructions are called code. When we press enter and the computer follows our instructions, this is called running the code. Now, there are many different languages we can use to write code, called programming languages. It's similar to how we have many human languages that we can use to communicate. Some examples of programming languages are JavaScript, Python, and Java. So here, we're writing our code using the JavaScript programming language. So we call this JavaScript code. Now that we understand the basic terminology, let's look at some more examples of what we can do with JavaScript code. Another thing we can do is math. Let's go back to the console and type here, and we're going to type 2 plus 2. So this is an instruction or code that tells the computer to do some math, to calculate 2 plus 2. When we press enter, the computer follows our instruction or runs this code, calculates 2 plus 2, and gives us the result, which is 4. Let's do another example. We're going to type 10 minus 3 and press enter to run this code. Again, the computer does this math calculates the result, and gives us 7. So as you can see, JavaScript can do many different things, like create pop-ups and do math. Let's look at one more example of what JavaScript can do. We're going to go to the bottom and type out this code. Document dot body dot inner capital HTML equals single quote hello single quote and semicolon. Make sure to write this out exactly as I have it here, with the dots and the capital letters, because JavaScript is case sensitive. Let's press enter to run this code. What this code does is that it removes everything on the page and replaces it with the text hello. In this example, we use JavaScript to modify the web page. Modifying the web page is one of the most important features of JavaScript, and we're going to be using this feature throughout this course. And that's the basics of JavaScript. We're giving instructions to a computer. These instructions are called code, and then the computer follows our instructions. This is called running the code. And also, don't worry about memorizing all this code. You can find a copy of all the code that we write in this course in the video description. Now that we understand the basics of JavaScript, let's learn more about the JavaScript language itself. If we take a look at this code, alert and hello, you might be wondering what the brackets and the quote mean. All of these characters have a special meaning in the language. This is something called syntax. Syntax are the rules that we have to follow when using a programming language like JavaScript. This is sort of like in English, we also have rules that we follow called grammar. The difference is that in English, we don't have to follow the rules of grammar perfectly. People can still understand us. But in programming, we have to follow the rules of syntax exactly. Otherwise, the computer won't understand our code. For example, if we scroll down and we type this code, alert, open bracket, quote, hello, quote, close bracket, and semicolon, but this time we remove the first bracket and press enter, it will give us a syntax error. We're not following the rules of syntax, so the computer doesn't understand this code. Now, JavaScript has a lot of syntax rules, and we can't learn them all at once right now. Instead, we're going to learn the syntax rules one by one as we go through the course. For now, we'll just learn enough syntax to do the exercises at the end of this lesson. What we need to know is that if we scroll up, this part of the code tells the computer to create a pop-up. The text between these quotes is the text inside the pop-up. If we change this text, we can change the text inside the pop-up. Same thing for this code down here. If we change the text between the quotes, it will change the text that appears on the page. And that's all we need to know about JavaScript syntax for now. We'll learn exactly what the other characters like the brackets, quotes, and semicolon mean later on in this course. So in this lesson, we learned that JavaScript is basically giving instructions to a computer. We wrote our first few lines of JavaScript code. We learned how to run our code using the console in our web browser. And we learned about syntax, which are the rules that we have to follow when writing our code. Here are some exercises you can try on your own to practice what we learned in this lesson. You can find these solutions to these exercises in the video description. Now that we understand the basics of JavaScript, we're going to learn about each feature of the language. In this lesson, we're going to focus on numbers and math. First, we can close the console for now. So I've actually prepared a project that we can use for this lesson. To open this project, we're going to go to our browser, click up here, and type supersimple.dev/projects/Amazon and press enter. So this is actually the final project we're going to create in this course. This is an e-commerce website similar to Amazon where we can add products to our cart and then view our cart by clicking the top right. And on this page, we can see the products in our cart, modify our cart, and create an order. For this lesson, we're going to focus on this right section, which calculates the cost of our cart, including the cost of the products, shipping, and taxes. This section is a great way to learn numbers and math in JavaScript. First, let's open the console again so we can write JavaScript code. We're going to find a blank area of the web page, right-click, click Inspect, and then click the console. So we already saw some examples of math in the previous lesson. For example, we wrote the code 2 plus 2. If we press enter, the computer adds these two numbers and results in 4. We also did 10 minus 3. If we press enter, the computer subtracts these two numbers and gives us 7. In addition to adding and subtracting, we can also multiply and divide. To multiply, we're going to type 10 star 3 and press enter. So star is the character for multiplying. To divide, we're going to type 10/2 and press enter. So / is the character for dividing. Now let's learn the syntax rules for numbers and math. The syntax for math is pretty straightforward in JavaScript. We just write it out like normal math. We can also do math with more than two numbers. For example, we can add 2 plus 2 and then plus another 2. If we press enter, the computer will add these three numbers together and result in 6. And finally, JavaScript can handle decimal numbers like 2.2 plus 2.2. If we press enter, it will calculate these decimal numbers and result in 4.4. Now let's do some practical examples. We're going to calculate the numbers here in our final project. But first, let's set up our cart so we have the same products in our cart. So make sure in your cart you have 2 socks with free shipping and you have 1 basketball with $4.99 of shipping and nothing else in your cart. If you need to, you can modify your cart by clicking Update or Delete, or by going to the home page by clicking in the top left and adding any products that you're missing. Once you have the same products as me in your cart and you have the same numbers on the right, we're ready to begin. Let's start by calculating this number up here. This is the cost of the products before shipping and taxes. To calculate this number using JavaScript, we're just going to add the cost of the products. So in our console, we're going to add the cost of the socks, which is $10.90. We have 2 of them, so we're going to multiply this by 2, and then we're going to add the cost of the basketball. So plus $20.95. If we press enter, the computer will do this math calculation and give us this number. And if we scroll to the top of our project, you'll see that the number that we got matches what we have on the page. So that's how we use JavaScript to calculate this number here. Let's do another example. We're going to calculate this third number, which is the cost of the products plus shipping. Feel free to pause the video if you want to try it yourself first. Otherwise, we'll do it together. Let's go back to our console, and we're going to add the cost of the products again, which is $10.90 times 2 plus $20.95. But this time, we're going to add the cost of shipping, which is $4.99. So 4.99, and press enter. The computer will do this calculation and give us this number, which matches what we see in the final project. Next, we're going to learn a very important feature of math called the order of operations. Adding, subtracting, multiplying, and dividing, these are called operations, and the characters in the middle are called operators. Now, there's a certain order that we do these operations. For example, if we go back to our console and type the calculation 1 plus 1 times 3 and press enter, notice that it multiplies 1 times 3 first, which equals 3, and then adds 1, which equals 4. Notice that it does not add 1 plus 1 first, which equals 2, and then 2 times 3 equals 6. The way math normally works is that multiply and divide are done first. Add and subtract are done after. This is called the order of operations, and JavaScript follows the same rules. Multiply and divide are done first. Add and subtract are done after. The order of operations is also called operator precedence in JavaScript. One thing to note is that multiply and divide have the same priority. So if we have both in a calculation, it will calculate from left to right. Add and subtract also have the same priority. If we have both in a calculation, it will also calculate from left to right. Another feature of the order of operations is that we can use brackets to control which part of the calculation gets done first. For example, let's type out this calculation again. 1 plus 1 times 3. But this time, we're going to add an open bracket and a close bracket around 1 plus 1. If we press enter, now the calculation inside the brackets will be done first. So it will add 1 plus 1 equals 2, and then 2 times 3 equals 6. So when we use brackets, JavaScript will always do the calculation inside the brackets first, and then do the rest of the calculation. Brackets have the highest priority in the order of operations. Now let's learn the syntax rules for brackets. So we just have to have a matching open bracket and close bracket. So something like this doesn't work because we have two open brackets and no close bracket. We also need to have a complete calculation in the brackets. So this also doesn't work because 1 plus 1 multiply is not a complete calculation. Now let's do some practical examples using the order of operations. First, we're going to do some more setup in the final project. So we're actually going to remove all the products in our cart. And then once our cart is empty, we'll go to the home page by clicking the top left. And this time, we're going to add some new products. So we'll add 1 basketball and 2 t-shirts. Now let's go back to our cart by clicking the top right. We'll scroll down and we're going to calculate the numbers in this section again. Let's calculate this number at the top, which is the cost of the products. We'll go back to our console and add the cost of the basketball, which is $20.95, plus the cost of the t-shirts, which is $7.99. And we have 2 of them. So we'll multiply this by 2. If we press enter, this will give us the number that we see in the final project here. Notice that in this calculation, we're taking advantage of the order of operations. Even though multiply is written last, we still multiply these 2 numbers first. So we calculate the cost of 2 t-shirts first, and then we add the cost of the basketball after. Okay, now let's try something a little more difficult. We're going to learn how to calculate this 10% tax here. So how do we calculate 10% of something? Unfortunately, we can't just multiply by 10% in JavaScript. Instead, we have to calculate the percent manually. So how do we do that? 1% is actually equal to 1 divided by 100. That's what percent means. So 10% is equal to 10 divided by 100, which equals 0.1. So to calculate 10% manually, we just multiply this number by 0.1. So we'll type 36.93 multiplied by 10% or 0.1. If we press enter, it will give us a number that is close to what we have in the final project. It's the same amount of money, but our number is more accurate than we need. So later in this lesson, we'll learn how to round this number down to exactly what we have on the web page. For now, let's do some more practice with the order of operations. Let's calculate the tax again, except instead of using the final number 36.93, let's calculate this number individually, like here. So at the bottom, we're going to add the cost of the basketball, 20.95, plus the cost of the t-shirts, 7.99 times 2, and then multiply this by the tax percent times 0.1 and press enter. Unfortunately, this number doesn't match what we got up here. And that's because if we look at this calculation, according to the order of operations, multiply is done first. So it will multiply these 3 numbers first and then add 20.95 after. However, this is not what we want. We actually want to calculate this number first. This is the cost of the products. So how do we get the computer to calculate this first and then multiply by the tax percent 0.1? To do this, we can use brackets to control which part of the calculation gets done first. So let's create this calculation again. 20.95 plus 7.99 times 2. But this time, we're going to add brackets around this part of the calculation to make sure that this gets calculated first. And then at the end, we'll multiply it by the tax percent 0.1. And now if we press enter, we will get the same number that we had before. So that's how we use math and the order of operations to calculate the numbers in this section of the final project. So don't worry, you don't have to be good at math to learn JavaScript. This is just to show you how math works in JavaScript. In the rest of this lesson, we're going to learn some more details about numbers and math. The first detail we're going to learn is a weird behavior of math in JavaScript. First, we'll need to learn some terminology. In programming, whole numbers like 2, 3, and 4 are called integers. Decimal numbers like 2.2 and 2.5 are called floating point numbers, or floats. And unfortunately, computers have a problem working with floats. For example, if we go back to our console and type the calculation 0.1 plus 0.2 and press enter, it will give us this weird number here that's close to 0.3 but a little bit inaccurate. So this problem is not specific to JavaScript. Many programming languages also have this problem. The reason this happens is because of how computers store numbers. I'll give a simplified explanation. Computers can only store zeros and ones, while humans can count from 0 to 9. So there's sort of a mismatch between our number systems. For integers, this is not a problem. The computer can just use a bunch of zeros and ones to store it. However, for decimal numbers or floats, sometimes the computer can't store the number properly. For example, here's how the computer tries to store 0.2 using only zeros and ones. At the top is what the computer stores. At the bottom is what this is equal to in human numbers. We can see that the computer gets closer and closer to 0.2, but never actually reaches it. And this is why we get these inaccuracies when calculating with floats, because computers can't store some floats properly. Note that this doesn't happen with all floats. For example, computers can store 0.25 without any problems. So these inaccuracies only happen with some floats, but not all of them. However, when calculating money, we definitely want to avoid any inaccuracies. So let's learn how to do that. First, we're going to set up our cart again. So make sure in your cart you have one basketball with free shipping, and this time you have one t-shirt. So we're going to click Update, change this to 1, and click Save. And this t-shirt also has free shipping. Now let's scroll up, and we're going to calculate this number at the top again, which is the cost of the products. Let's go into our console, and we're going to add the cost of the basketball, $20.95, plus the cost of the t-shirt, which is $7.99. If we press enter, calculating with these floats causes the inaccuracies that we saw earlier. So how do we avoid this problem? The best practice when calculating money is to calculate in cents instead of dollars. So instead of $20.95, we're going to calculate 2,095 cents plus 7.99 cents. Notice we're not using floats anymore, so we avoid the inaccuracies. But now this number is in cents, so we need to convert back to dollars. To do that, we'll surround this calculation with brackets to make sure we calculate this first, and then at the end, we'll divide by 100 to convert back to dollars, because there are 100 cents in each dollar. If we press enter and scroll up, that's how we get the exact number that we see on the page. So remember, in programming, calculations with floats are sometimes inaccurate, and when working with money, the best practice is to do the calculation in cents and then convert back to dollars at the end. The next detail we're going to learn is how to round a number in JavaScript. Rounding just means taking a number and moving it to the nearest integer. To round a number, we can use this code. Capital M math dot round. Open bracket, close bracket. So make sure you use a capital M because JavaScript is case sensitive. Now between the brackets, we can put a number that we want to round, like 2.2. If we press enter, it will round this number down to 2. If we do capital M math dot round, open bracket, close bracket, and between the brackets, we put 2.8 and press enter, it will round 2.8 up to 3. Now let's do a practical example with math.round. We're going to calculate the tax again, but this time we're going to round the result to exactly this number on the page. So first, let's calculate the tax. We'll go into our console and add the cost of the products in cents. So 2,095 cents for the basketball, and plus the cost of the t-shirt, which is 7.99 cents. And we'll surround this in brackets to make sure we calculate this first. And then we're going to multiply this by the tax percent, or 0.1. And finally, we'll convert this back to dollars. So let's surround this in brackets as well to make sure we calculate this first. And at the end, we'll divide by 100 to convert back to dollars. So notice here, we can have brackets inside brackets. In this situation, JavaScript will calculate the inner brackets first, and then the outer brackets, and then everything else. If we press enter, this gives us 2.894, which is close to the number on the page. It's the same amount of money, but our number is more accurate than we need. So now let's learn how to use math.round to round this number to exactly 2.89. First, let's create a copy of this calculation. So we'll select it, right-click, copy, and down here, right-click and paste. So one thing we might try to do is to round this entire calculation. However, this will round 2.894 to 3 because it rounds to the nearest integer. Instead, what we want to round is this number here. So remember that this number is the result in cents, which is 289.4 cents. If we round this number, it will round down to 289 cents, which is exactly $2.89. So to round this calculation, at the front, we'll type capital M math dot round. So we already have brackets around this, so we don't need extra brackets. So this will round to 289 cents. And finally, we'll convert this back to dollars at the end by dividing by 100. If we press enter, that's how we round this calculation to get the exact number on the page. So to summarize, we first calculate the result in cents, and then we round this to the nearest cent, and then at the end, we convert back to dollars. Again, don't worry, you don't have to be good at math to learn JavaScript. These examples are just for learning. Almost all the math we do in JavaScript is more simple than this. I'll give you some exercises at the end of this lesson to help you get more practice. The last thing we're going to learn in this lesson is how to use Google when you're learning to code. So far, I've been giving you different pieces of code, like alert and math.round. You might be wondering, where do I find this code? These pieces of code are features of JavaScript, and I find this code by searching on Google. So we're going to learn how to use Google to learn new features of JavaScript on our own. Let's go to our browser and create a new tab at the top. And we'll click here and type google.com and press enter. And we'll search in Google. So the trick to searching in Google is to search for what we are trying to do. For example, if we want to round a number, we would search for JavaScript, how to round a number. If we press enter, sometimes you might get the code right away in the first result, and sometimes you might have to go into the other results to find the code that you need. In my example, I see the code math.round in the first result, so I can click into this result, read about what this code does, and also see some examples of how to use it. One thing to keep in mind is that when you're searching in Google, you might not understand all the code that you get in your results. For example, here, there's a lot of code that we haven't learned yet. And actually, that's okay. We just need to look for the pieces of code that look familiar to us, like this part of the code. We can then use this part of the code in our own code. We don't have to understand every bit of code that we get from Google. And don't worry, as we move through this course, we will understand more and more of this code that we get from Google results. These days, we also have some artificial intelligence or AI tools that can help us search for code. I'll provide links to some of these tools in the video description. And that's the end of this lesson. In this lesson, we learned how to work with numbers and math. We learned the order of operations and brackets. We calculated the numbers in the final Amazon project. We learned that calculations using floats can be inaccurate and how to avoid this problem when working with money. We learned how to round numbers using math.round, and we learned how to search for code on our own. Here are some exercises to help you practice numbers and math. In the previous lesson, we learned how to work with numbers and math. In this lesson, we're going to learn how to work with text, and we're going to create the text in this section of the final project. First, make sure you have the final project open and you're on the checkout page. Also make sure you have the console open on this page. If not, you can go to a blank area, right-click, click Inspect, and then click the console. Now, we're going to learn a feature of JavaScript called strings. A string represents text. Let's go to our console and create our first string. We're going to type single quote, hello, and single quote, and press enter. This is a string, and it represents the text hello. And we've actually seen this code before. In the first lesson, the first piece of code that we learned was alert, open bracket, single quote, hello, single quote, close bracket, and semicolon. This code creates a pop-up on the page. If we press enter, it creates a pop-up. Now inside these brackets, we actually created a string. This string is the text that appears in the pop-up. So as you can see, a string represents text. Let's press OK. And now let's learn the syntax rules for strings. To create a string, we just write some text like hello, and then surround this text with single quotes, one at the beginning and one at the end. We can also add strings together. For example, let's type the string sum plus the string text and press enter. When we add two strings, it combines the strings together into a bigger string. And this makes sense. We're adding two pieces of text together. We can also add more than two strings at a time. For example, we can type the string sum plus the string more plus the string text. If we press enter, the computer will combine all three strings into one big string. By the way, this is called concatenation when we combine strings together. Now, in the previous lesson, we learned about numbers. Numbers and strings are two different types of values in JavaScript. They represent different things. And we can actually check what type of value something is using this code. Type of, and then space, and then a value, like the number 2. If we press enter, type of will tell us that 2 is a number. If we do type of quote, hello, quote, and press enter, it will tell us that hello is a string. Now, what if we added a string and a number together? For example, let's type the string hello plus the number 3 and press enter. So when we add a string and a number, JavaScript will automatically convert this number into a string. So this gets converted into the string hello plus the string 3. And then it combines them together into the string hello 3. This feature is called type coercion or automatic type conversion. Okay, now that we understand the basics of strings, let's do some practical examples. We're going to use strings and numbers to create the text in this section of the project. First, make sure that in your cart you have one basketball with free shipping, and you have one t-shirt, also with free shipping, and you have no other products. Let's scroll up, and we'll start by creating this text in the top right. So this is the cost of the products, but this time we're going to have a $sign. So instead of just a number, this will be text. So one thing we can do to create this text is just type out the string directly, like quote $28.94 and quote. However, let's actually calculate this number using math. Remember, the advantage of JavaScript is that it's able to do calculations. So instead of typing out 28.94, we're just going to create the string $sign plus, and we're going to calculate this number using math. So we're going to add the cost of the basketball, which is $20.95, plus the cost of the t-shirt, which is $7.99. If we press enter, unfortunately, this doesn't look right. Instead of doing math and adding these two numbers together, it just sort of put the numbers one after another into the string. So why is this happening? JavaScript adds from left to right. So the first step is to add these two values. And as we learned, if we add a string and a number, JavaScript will automatically convert this number into a string. So the result of this calculation will be the string $20.95 and quote. The next step is to add 7.99. So it will add 7.99. And now we're adding again a string and a number. So JavaScript will automatically convert this number into a string and combine them together. That's why it puts 7.99 at the end of this string instead of doing math. So what we actually want to do here is to add these two numbers first and then combine the total with the string. So how do we do this? The solution is that strings also follow the order of operations, just like numbers. And remember, in the order of operations, we can use brackets to control which part of a calculation gets done first. So let's type this calculation out again. The string $sign plus 20.95 plus 7.99. But this time, we're going to add an open bracket and a close bracket around this calculation. This tells the computer to calculate this number first using math, and then combine this result with the string after. If we press enter, now this is doing math, and it solves our original problem. Unfortunately, now we have another problem. This math is inaccurate. So remember from the previous lesson, doing calculations with floats can sometimes cause inaccuracies. And the best practice when calculating money is always calculate in cents and then convert back to dollars at the end. So at the bottom here, we're going to add the string dollar plus open bracket, and instead of $20.95, we're going to add 2,095 cents plus 7.99 cents and close bracket. And then at the end, we're going to convert this number back to dollars by dividing by 100. If we press enter, this will give us the text that we see in the final project. Again, strings follow the same order of operations as numbers. Brackets are always calculated first, multiply and divide are done next, and add and subtract are done after. So adding this result to the string is the last step. Now let's do a more complicated example. Let's use strings and numbers to create this entire line of text, not just the dollar text. To create this, we're going to go from left to right. Let's go back in our console, and we're going to start with the string items, open bracket, and here we could just type 2 and close bracket, but let's actually calculate this number as well using math. So this number is the quantity or the number of products in our cart. Let's go back to our console. We're going to end the string here, and we're going to add, and we're going to calculate the quantity. So we have 1 basketball plus 1 t-shirt. Again, we run into the same problem as before. This gets calculated first and results in a string, and then it would just combine the 1 at the end of the string instead of doing math. To solve this, we're going to use brackets again. So around the 1 plus 1, we're going to add open bracket and close bracket. This tells the computer to add the numbers first and then combine it with a string. All right, let's keep going from left to right. We're going to add the rest of the string, quote, close bracket, colon, and let's just use a space to represent the space between these two. So we'll type a space, $, and then we're going to calculate this number again and add it to the string. So we'll end the string and then plus, and we already did this calculation up here. So we can select this and then right click, copy, and here right click and paste and press enter. And that's how we create this first line of text using strings and numbers. We break up the string into parts, calculate the numbers, and then add the parts back together. All right, now let's take these strings that we created and do something with them. Let's create a pop-up and display this first line of text inside the pop-up. We'll go back to our console and type the code for creating a pop-up, alert, open bracket, close bracket, semicolon, and then inside the pop-up, we're going to display this string. So let's just make a copy of this code. We'll select it, right click, copy, and between the brackets, right click and paste. If we press enter, the computer displays a pop-up with the first line of text of the final project inside. So that's how we use strings to create the text in the final project. And once we create the strings, we can use them in other JavaScript code. In the rest of this lesson, we're going to learn more details about strings. In JavaScript, there are actually 3 ways to create a string. The first way is to use single quotes, which we already learned. For example, we can type single quote, hello, and single quote, and press enter. The second way to create a string is to use double quotes. For example, double quote, hello, and double quote, and press enter. This creates the exact same string as single quotes. So which one should we use to create a string? Single quotes or double quotes? In JavaScript, I recommend using single quotes by default. They're a little easier to read and type. There is one situation where double quotes might be useful, and that is if we have a single quote inside the string. For example, if we type the string I'm learning JavaScript and single quote and press enter, this doesn't work because there's a single quote inside the string, and this single quote will end the string early. To solve this, we can create the string using double quotes. For example, double quote, I'm learning JavaScript, and double quote, and press enter. So now this works. Because we created the string using double quotes, the single quote no longer has a special meaning, and it will no longer end the string early. So this is a situation where double quotes might be useful. Otherwise, we use single quotes by default. Now, there's actually another solution to this problem, other than using double quotes, and that's by using an escape character. So a character is one letter, number, or symbol in a piece of text. For example, the text hello has 5 characters, H, E, L, L, O. A character can be a letter, a number, or also a symbol. These are all considered characters. Now, in addition to these characters, we have a special set of characters we can also use in a string called escape characters. An escape character looks like this: a backslash and then another character, like single quote. This combination actually counts as one character in a string. This character creates a single quote that is just text. It doesn't have a special meaning, and it doesn't start or end strings. For example, we can create this string with single quotes again. So single quote I, and this time we'll use the escape character backslash single quote, and then M learning JavaScript, and single quote, and press enter. And now this works because the escape character backslash single quote creates a single quote that is just text. It doesn't start or end the string. Another escape character that's useful to know is backslash double quote. This creates a double quote that is just text. It doesn't start or end a string. The last escape character we'll learn in this lesson is backslash n. This is called the new line character. This escape character doesn't create the letter n anymore. It creates a new line of text. For example, let's create a pop-up using alert, open bracket, close bracket, and semicolon, and then inside the brackets, we're going to create a string sum and then \n text and single quote. If we press enter, you'll notice that this escape character created a new line of text in the pop-up. And that's why we call this the new line character. So that's how escape characters work. They're a set of special characters that start with \, and we can use them in a string. Now let's press OK. And we're going to learn the third way of creating a string in JavaScript, which is using backticks. For example, let's type in our console, and we'll type backtick, hello, and backtick, and press enter. This creates the same string as single quotes and double quotes. Strings created with backticks actually have a name. We call these template strings, and they have a name because they have some special features. The first special feature of template strings is called interpolation. Interpolation lets us insert a value directly into a string. For example, let's say we want to create the first line of text in our project. Earlier in this lesson, we created this text with concatenation, which means we broke it up into parts and added them back together. Interpolation gives us a much easier way to do this. We'll go to our console and we'll create this text using a template string because interpolation is only a feature of template strings. So we'll type backtick items, open bracket, close bracket, and backtick. And now between these brackets, we want to insert the quantity or the number of products in our cart. To insert this with interpolation, we're going to type $, open curly bracket, close curly bracket. So this combination of characters allows us to insert values directly into the string. Between these curly brackets, we can calculate the quantity, which is 1 basketball plus 1 t-shirt. This will add 1 plus 1, which equals 2, and then insert it directly into the string. Let's keep going and create the rest of this line. So we're going to type at the end a colon, space, and $, and now we're going to insert another value into the string, which is the cost of the products. To insert another value, we're going to type $, open curly bracket, close curly bracket again. And between the curly brackets, we're going to calculate the cost of the products, which is 2,095 cents plus 7.99 cents, and we'll surround this in brackets to make sure we calculate this first, and at the end we're going to convert back to dollars by dividing by 100. If we press enter, this creates the first line of text again in our final project. If we compare this code, which uses interpolation, to our previous code, which uses concatenation, you can see that interpolation is a much cleaner way of inserting values into a string. So interpolation is the recommended solution. Next, template strings have another special feature called multi-line strings. Let's go to our console, and we're going to type a backtick sum and then press enter, and text and backtick. Notice that this string is on multiple lines, so we call this a multi-line string, and this feature is only available for template strings. If we press enter, you can see that the new line in the string just creates the new line escape character that we learned earlier. So that's the multi-line string feature of template strings. We're going to use multi-line strings a lot later in this course. But for now, I just wanted to introduce you to this feature. Now you might be wondering again, what should we use to create a string? Single quotes or template strings? Even though template strings have more features, I find that most JavaScript code still uses single quotes by default. So my personal recommendation is to use single quotes by default. And if we need to insert a value into the string or type the string on multiple lines, then use template strings. And that's the end of this lesson. In this lesson, we learned about strings. A string represents text. We learned how to use strings and numbers to create the text in our final project. We learned 3 different ways of creating a string: single quotes, double quotes, and backticks or template strings. We learned about escape characters, and we learned 2 useful features of template strings: interpolation and multi-line strings. Here's some exercises to help you practice working with strings. So far in this course, we've learned some basic features of JavaScript, like numbers and strings. In this lesson, we're going to learn how to use HTML, CSS, and JavaScript together. Because as I mentioned at the beginning of this course, we use all 3 technologies to build a full website. HTML creates the content of a website, like the buttons and the text. CSS changes the appearance of the website. And JavaScript makes the website interactive. The first thing we're going to do is review the basics of HTML and CSS that we will need for the rest of this course. Now, in order to write HTML and CSS code, we'll need to install another piece of software called a code editor. A code editor helps us write and organize our code. The most popular code editor for web development is called VS Code, or Visual Studio Code. To install VS Code, you can go to google.com in your browser, search for VS Code, click the result, and follow the instructions to download and install. Once we've installed VS Code, we're ready to review the basics of HTML and CSS. We'll start with HTML. HTML stands for Hypertext Markup Language. And just like JavaScript, HTML is also giving instructions to a computer. Now, unlike JavaScript, we can't use the console to write and run HTML code. Instead, we write HTML code inside a file using our code editor. Let's do that right now. We'll start by going to our desktop. So I'm going to close my browser to go to my desktop. And then we're going to create a new folder. So we can right-click, New Folder. This folder is going to contain all the code that we write in this course. Let's name this folder JavaScript-course. Next, we're going to open this folder in our code editor. So let's open VS Code. And then we'll click File, Open Folder, and find the folder that we just created. For me, it's on the desktop, and it's this folder right here. So we're going to select the folder, and then click Select Folder. Now we can close this startup message, and we're going to create an HTML file. We're going to click this icon to create a new file, and we're going to name this file website.html and press enter. Ending the file name with .html tells the computer that this file contains HTML code rather than just text. Now let's review some basic HTML code. We're going to type the code less than, button, greater than. And we also need to type less than / button greater than, but our code editor might autocomplete this for us. So this code tells the computer to create a button. And inside the button, we're going to have the text hello. Now let's save this file by clicking File, Save, or by typing Control S on Windows or Command S on Mac. Now to run this HTML code, we're going to open this file in our browser. Let's go back to our desktop. We're going to open the folder that we created. Find the HTML file, select it, and then right-click, Open with Google Chrome. As you can see, we have a website, and we created a button with the text hello inside. And if we look back at our code, that's exactly what we told the computer to do. So just like JavaScript, HTML is also giving instructions to a computer. Let's review some more HTML code. First, I'm just going to rearrange my windows here so that it's easy to see the website side by side. Next, we're going to click the end of the first line and press enter to create a new line, and we're going to type the code less than p greater than. And we also need to type less than / p greater than. So this code creates a paragraph. And inside the paragraph, we're going to put some text. For example, paragraph of text. Now let's save our file by typing Control S on Windows or Command S on Mac. And to update our website to the new code, we're going to go to our website and click refresh, or type Control R on Windows or Command R on Mac. And now you can see that the computer created a paragraph of text, just like we told it to do. And that's the basics of HTML. The computer reads our code and then follows our instructions one by one. First, it creates a button, and then it creates a paragraph of text. Now let's review the syntax rules for HTML. Each of these things that we're displaying on a web page, these are called HTML elements. So a button is a type of HTML element, and a paragraph is another type of HTML element. To create an element, we start with a less than symbol, and then the element name, like a button, and then the greater than symbol. So this whole thing is called an HTML tag. This tells a computer to create a button element. Every HTML tag needs a matching tag. The matching tag follows the same syntax, except it has a slash in front of the element name. So this is called the opening tag, and this is called the closing tag. You can think of the opening tag as the start of the button, and the closing tag as the end of the button. And in between, we have the contents inside the button. In this case, it's the text hello. In addition to text, we can also have elements inside an element. For example, we can go to our paragraph element, and we can add a button inside. So less than, button, greater than, And we also need less than / button greater than. And then inside the button, we'll also have the text hello. If we save this file and refresh the page, now our paragraph element has a button element inside. By the way, this is called nesting, when we have an element inside another element. The last syntax rule we have to review is that in HTML, if we have multiple spaces, for example, if we go here and type multiple spaces are combined into one space on the web page. So if we save this code and refresh, you'll notice that all of the spaces that we added only show up as one space on the web page. In addition, in HTML, new lines also count as spaces. So if we go back to our code and we type here and press enter to create a new line, and then save and refresh, notice that the new line doesn't appear on the web page. And that's because this new line here is the same as spaces in HTML. So all of these get combined into one space on the web page. At first, this might seem a little weird, but this feature gives us a lot of flexibility when organizing our HTML code. For example, we can go into our code and add a new line here to separate these two elements and make our code easier to read. Another thing we usually do to make our code easier to read is to put the contents of an element on its own line. For example, we're going to type here and press enter, and here and press enter again to put the contents of the button on its own line. Now it's a lot easier to see where this button starts and where it ends. We can do the same thing with the paragraph. We can type here and press enter, and type here as well and press enter, and then remove some of the extra spaces to put the content of the paragraph on its own line. And now if we save our file and refresh, you'll notice that none of the new lines that we added appear on the web page. By the way, a web page is a single page, like the home page or the cart page. Together, we call this a website. So that's the basics of HTML and HTML syntax. Now let's review CSS. CSS stands for Cascading Style Sheets, and CSS changes the appearance of our website. Let's review some CSS code. We're going to write our CSS code inside our HTML file. First, let's type here and create some new lines at the top. And then at the top, we're going to create a special HTML element called the style element. So let's type less than style greater than. And we also need the closing tag less than / style greater than. So the style element is unique because it doesn't appear visibly on the page. Instead, the purpose of the style element is that it lets us write CSS code inside. So inside here, let's press enter to create a new line, and we're going to type button, open curly bracket, close curly bracket. And then inside the curly brackets, we're also going to press enter to create a new line. So this is CSS code, and this code tells the computer to change the appearance of all buttons on the page. And then inside these curly brackets, we can tell the computer how to change the appearance. For example, we can type background dash color colon red and semicolon. If we save and refresh, you can see that this CSS code changes the appearance of all buttons on the page and changes their background color to red. Let's do another example. We're going to go back to our CSS code. I'm going to type here and press enter to create a new line. And we're going to add color :white and semicolon. Let's save and refresh. And this CSS code changes the text color of all buttons on the page to white. Let's do one more example. We're going to type the code border: none and semicolon. Let's save this and refresh. And this CSS code removes the border for all buttons on the page. And that's how CSS works. We tell the computer which elements we want to change, and then how to change the appearance of these elements. Now let's review the syntax rules for CSS. This part of the CSS code is called the CSS selector. It tells the computer which elements we want to change. In other words, it selects which elements to change. Inside the curly brackets, we have some CSS styles. This tells the computer how to change the appearance. For each style, the left side is called the CSS property. This tells the computer what we're changing. The right side is called the CSS value. This tells the computer what we're changing the property to. For example, this style changes the background color to red. We use a colon to separate the property and the value, and a semicolon at the end to tell the computer that this is the end of a style. So that's the basic syntax of CSS. We tell the computer which elements we want to change, and then how to change the appearance of these elements. The next thing we're going to review is HTML attributes. Right now, this CSS selector changes the appearance of all buttons on the page. However, what if we only want to change the appearance of this one button, and we want to style the other button differently? How do we do that? We're going to review a feature of HTML called attributes. Attributes change the behavior of an element. For example, we're going to go to the opening tag of the first button, and then here we're going to add an HTML attribute by typing space title equals double quotes. And then in between the double quotes, we're going to type tooltip. So this is an HTML attribute, and this attribute adds a tooltip to this button. If you're wondering what a tooltip is, if we hover over some code in our code editor, it'll show us this sort of pop-up with more information. This is called a tooltip when we hover over something and this shows up. So if we save our file and refresh the web page, and now we hover over our button, we can see that the HTML attribute added a tooltip to our button. And then inside the double quotes is the text inside the tooltip. For example, we can actually change this to good job. And if we save and refresh and hover over our button, the text between the double quotes is what shows up in our tooltip. So that's an example of an HTML attribute. Now let's review the syntax rules for attributes. We always put attributes on the opening tag, and we add a space between the element name and the attribute to separate them. On the left side is the attribute name. This tells the computer what we're changing about this element. On the right side is the attribute value. This tells the computer what we're changing this attribute to. For example, here we're changing the tooltip of this element to good job. We separate the name and value with an equal sign and make sure there are no spaces around the equal sign. and we surround the value with double quotes. Now let's go back to the original problem. How do we style these buttons differently? We can do this using a very important attribute called the class attribute. Let's review that right now. We're going to go back to our button, and then here, we're going to type space class equals double quotes. And then inside the double quotes, we're going to type red dash button. So the class attribute sort of adds a label to an element. So here, we labeled this button as a red button. And now that we labeled this element, we can select it in CSS. To do that, we're going to go to our CSS code. We're going to remove the button selector and replace it with dot red dash button. When we start the selector with a dot, this means that now we're looking for a class. So here, we're going to look for all elements with the class red dash button, which is only this element. If we save and refresh, now only the elements with the class red button gets these styles. We can also add the same class to multiple elements. For example, we can go to our other button and add the class equals red dash button. If we save and refresh, now these styles get applied to both buttons again because they both have the class red dash button. If we want to style this button differently, we just give it a different class. For example, we can change this to yellow dash button. And then in our CSS, we can add another selector. So we can type dot. This means we're going to select a class, and we're going to select the yellow dash button class. Open curly bracket, close curly bracket. And then inside here, we can add some styles for the yellow button. For example, background dash color colon yellow and semicolon. Now let's save and refresh. And that's how we use the class attribute in HTML to modify specific elements. The final thing we need to review is something called the HTML structure. Let's go back to our website. We're going to find a blank area and then right click and then click inspect. So we already learned about the console tab. Here we can write and run JavaScript code. Now we're going to go to the Elements tab, which is for HTML and CSS. So in the Elements tab, we can see all the HTML on the page, as well as all the CSS on the page. And we can play around with the CSS if we want. Now, if we go back to the HTML, you'll notice that our web page has some elements that we didn't add before. The HTML element, the head element, and the body element. So this is the structure that we're supposed to follow when writing HTML. In our code, we didn't follow this structure, so the browser actually adds it for us automatically. However, it's still best practice to follow this structure in our code because it gives us access to some more features of HTML. Let's review the HTML structure and add it to our code. We're going to type up here, and we're going to create some new lines. And now, every HTML file is going to start with less than, exclamation, doc type in capitals, and then space, HTML, and greater than. This is not an HTML element. It's a special line of code that tells the browser to use a modern version of HTML. If we don't have this, the browser might fall back to an older version of HTML that has less features. Next, we're going to create an HTML element. So less than HTML and greater than. The HTML element represents the entire web page. So everything on the web page should go inside this element. And then inside the HTML element, we're also going to split it up into two sections: the head element and the body element. So the body element is supposed to contain everything that is visible on the page. In our example, that would be the buttons and the paragraph. So let's actually select this code, and we're going to right-click and cut, and then inside the body, we're going to right-click and paste. The head element contains information about the page. In general, everything that is not visible on the page goes inside the head. In our example, that would be the style element. So let's select this as well. We're going to right-click and cut, and then inside the head, we're going to right-click and paste. And at the bottom, let's just clean up by removing all of the extra new lines. So this is the structure that we're supposed to follow in all of our HTML files. As you can see, this structure uses a lot of nesting, or elements inside elements, to organize our code. Okay, so what are the benefits of following this structure? One benefit is that there are other elements that we can use inside the head. For example, let's type here, press enter, and we're going to add the title element. So the title element sets the text in the tabs. Inside, we can type HTML CSS review. If we save and refresh, the title will show up in the tab. So this is an example of an element that we can now add in the head. Another benefit that we get from this structure is the ability to automatically refresh our web page when we change our code. So far, every time we change our code, we have to save and then manually refresh the web page. We can actually automate this by following the structure and then installing a VS Code extension. So let's click the extension area, and we're going to search for the extension Live Server and click Install. Once we have that installed, we're going to change a setting. Let's open the settings by clicking this icon in the bottom left and then click Settings. At the top, we're going to search for Live Server. And we're going to look for a setting called Live Server Custom Browser. And we're going to change this to Chrome. Now, if Google Chrome is already your default web browser, you don't need to do this step, but it's nice to know. Now let's close the settings and go back to our code. Next, instead of opening this file directly in the browser like before, we're going to use Live Server to open this file. To do that, we're going to right-click this file in our code editor and then click Open with Live Server. If we open a file with Live Server, this web page will automatically refresh when we change our code. For example, we can go here and change the background color to green. If we save, Live Server will automatically refresh the web page, so we don't have to do that back and forth anymore. Let's just change it back to red so that the class name makes sense, and save. And we can also close the previous tab. So this is the HTML structure. It gives us access to more features of HTML. And this is all we need to review about HTML and CSS for now. If you want to learn more, you can check out my HTML and CSS full course in the video description. Before we add JavaScript to our website, we're going to review some VS Code setup. So you'll notice that many of these lines have spaces at the front. These spaces are called indents, and indents make our code easier to read. For example, we can easily tell that this code is inside the brackets because it has an extra indent in the front. If we didn't have indents, here's what the code would look like. It's a lot harder to read. To add an indent, we can type at the beginning of the line and press Tab. To remove an indent, we can press Shift-Tab or just use backspace. Now, by default, VS Code uses 4 spaces per indent. However, in HTML, CSS, and JavaScript, we usually use 2 spaces per indent. So we're going to update this setting. Let's go to our settings by clicking this icon in the bottom left, and then click Settings. And at the top, we're going to search for Tab. And we're going to change the tab size from 4 to 2. Now let's close the settings. And we're also going to change the indents for this file. We're going to go down here and click Select Indent. And we're going to choose Indent using spaces, and then click 2. And now if we type at the start of a line and press Tab, it will only add 2 spaces per indent. So let's reformat our code to use 2 spaces per indent instead of 4. First, we're going to remove all the indents in our code. A shortcut for this is to select all of these lines and press Shift-Tab to remove 1 indent for each line. So we're going to keep pressing Shift-Tab until we remove all the indents. Next, we're going to add the indents back using a similar shortcut. We're going to select the head element and press Tab to add 1 indent for each line, and then select everything inside the head and press Tab to add another indent, and then select everything inside style and press Tab, and then inside each of these brackets, we're going to select the lines, press Tab, and then here, press Tab. We'll do the same thing for the body element. We'll select all these lines and press Tab. We'll select everything inside the body, press Tab, and then inside each of these elements, we're going to press Tab and press Tab. Now, if we save, our website will look the same because all we did was adjust the indents. So there's one other setting in VS Code that we're going to set up, which is line wrapping. If you look at this line of code, you can see that it's really long, and we need to scroll horizontally to see the rest of the line. Instead, we're going to make this line wrap around if it gets too long. Let's go back into our settings by clicking here, and then click the settings. And then up here, we're going to search for wrap. And we're going to look for editor word wrap. And we're going to turn this on. Now, if we close our settings and go back to our code, this line, which is really long, will wrap around to the next line instead of us having to horizontally scroll. So that's the VS Code setup that we need. 2 spaces per indent and line wrapping. Finally, we're going to add JavaScript to this website. So we learned that we can use the console to write and run JavaScript. Well, there's actually another way to run JavaScript, which is inside an HTML file. Let's learn how to do that. So we learned that HTML has a special element that runs CSS code called the style element. Well, HTML has another special element that runs JavaScript code. And this element is called the script element. So inside our body, at the bottom of the body, we're going to add less than script greater than and the closing tag less than / script greater than. And inside the script element, we can put some JavaScript code. We're going to add the code alert, open bracket, quote, hello, quote, close bracket, and semicolon. If we save, Live Server will refresh the page, and now you notice that the computer now runs our JavaScript code, just like it did in the console. It creates a pop-up with the text hello inside. And we usually put the script element at the bottom of the body because we want the web page to be created first, and then we use JavaScript to make it interactive. For the rest of this course, we're going to run our JavaScript code using an HTML file. The console that we used in the previous lessons is more of a way to try out JavaScript code. We wouldn't use the console for a real website. In addition to the script element, we have another way to run JavaScript code inside HTML, and that's by using an attribute. Let's go back to our first button, and here we're going to add another attribute. So let's type space, and this time we're going to add the onClick attribute equals double quotes. So this attribute will run JavaScript code whenever we click this button. That's what onClick means. Between the double quotes, we can write some JavaScript. For example, let's press enter, enter, and then here we're going to type alert, open bracket, quote, good job, quote, close bracket, and semicolon. Now, if we save, Live Server will refresh the page and run this line of JavaScript code. Let's press OK. And now if we click this button, it will run this line of JavaScript code and create a pop-up with the text, good job inside. So those are two places where we can run JavaScript code, the script element and the onClick attribute. The code in the script element runs first when the page is loaded. The code in the onClick attribute runs after when we click the button on the page. And that's how we use HTML, CSS, and JavaScript together on a website. Notice that everything starts from HTML. HTML first creates the website, and then inside the HTML, we can run CSS code to change the appearance, and we can run JavaScript code to make the website interactive. Now let's learn some new features of JavaScript that we haven't seen yet in this course. The next feature we're going to learn is called comments. Comments are pieces of code that the computer ignores. So let's create our first comment. We're going to go down to the script element here and type //. So this is a comment. Anything after the double slash will be ignored by the computer. So we can type anything we want, like this is a comment. If we save, it ignores this line and creates the pop-up in the next line. Now let's close this pop-up and learn why we use comments. Comments are useful for providing more information for people reading our code. For example, we can create a comment above this code, like this code creates a pop-up. This comment helps others and ourselves understand what this code does. So that's one way we use comments. Another way we use comments is if we don't want to run some code anymore, but we also don't want to delete it. For example, this code creates a pop-up every time we refresh the page, and this can be annoying. So I want to stop running this code, but I also don't want to delete it, because you might want to review this code later. So what we can do here is to add a double slash in front of this line to turn this code into a comment. Now, if we save, the computer will ignore this line of code and not create the pop-up. This is called commenting out the code. It's useful if we don't want to run some code anymore, but we also don't want to delete it for informational purposes. So JavaScript has another syntax for writing comments, and that syntax is slash star and star slash. Here, anything between the stars is a comment. This is called a multi-line comment because between the stars, we can write a comment on multiple lines. For example, we can type multi, enter, line, enter, comment. On the other hand, double slash is known as a single line comment. Now, just like JavaScript, HTML and CSS also have comments, but they use a different syntax. If we scroll up to our HTML, here we can type less than exclamation dash dash. And we also need dash dash greater than. So anything between these double dashes is a comment. For example, this is a comment. In CSS, to create a comment, we can type slash star star slash. So it's the same multi-line comment as JavaScript. Between the stars, we can add a comment. So this is a comment. If we save our file, nothing changes on our web page because comments are ignored by the computer. The last feature of JavaScript we're going to learn is called console.log. Let's go back to our code. And at the bottom in the script element, we're going to type the code 2 plus 2. So we learned that this code in JavaScript does some math. However, if we save this file, where is the result of this math? So we might think that the result will show up in the console, but if we right-click, click Inspect, and then click the console, you'll notice that the result doesn't show up here either. And that's because before we were running 2 plus 2 inside the console. So the result shows up in the console. But now we're not running this code in the console anymore. We're running this code on the web page. So how do we see this result? The solution is we're going to redirect this result back to the console. To do that, we're going to use this piece of code. Console.log, open bracket, close bracket, and semicolon. Console.log will display whatever's between the brackets back in the console. So if we move this code between the brackets, so we select this and then right-click, cut, and then between the brackets, right-click, paste, and save, the result of this code is displayed back in the console. And console.log works for any code that we learned so far. For example, we can use strings. So let's create a new line and type console.log, open bracket, close bracket, semicolon, and then between the brackets, let's type some strings. Quote, some, quote, plus, quote, text, quote, and save this file. Again, it will display the result of whatever's between the brackets back in the console. So that's how we see the result of JavaScript code that is running in a file. We use console.log. And that's the end of this lesson. In this lesson, we reviewed the basics of HTML and CSS. We set up our code editor VS Code. We learned how to load JavaScript inside an HTML file using the script element and the onClick attribute. We learned how to create comments, and we learned how to use console.log. Thanks for watching this course so far. If you find this content valuable, you can support this channel by liking the video, clicking subscribe below the video, and recommending this course to your friends. Thanks again, and let's continue with the course. In this lesson, we're going to learn the next feature of JavaScript called variables. And we're going to use variables to build a simple version of the cart quantity feature of the final project. First, let's create a new HTML file just for learning variables. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. And we're going to name this file 05-variables.html and press enter. So the 05 just means that this file is for lesson 5. Let's also add the lesson number to website.html. We'll select this file and then right-click, rename, and then at the front, we'll add 04- and press enter. Next, we're going to copy all the code in website.html to variables.html. So let's click in this file, and we're going to select all of this code by typing Control-A on Windows or Command-A on Mac. And then we're going to right-click, copy, and then inside variables.html, right-click, and paste. Let's click this icon to hide our files for now, and we'll prepare this file for this lesson. So let's scroll up to the top, and first we're going to change the title to variables. Next, we're going to delete all the CSS because we're going to start over. And we're going to delete all the HTML except for the script element. And let's delete all the JavaScript from the previous lesson. And finally, let's save. And we'll open this file in our browser by right-clicking and then open with Live Server. And now we can close the previous tab and the previous code for now. Now we're ready to learn variables. First of all, what is a variable? A variable is like a container. We can save a value like a number or a string inside a variable, and then use it later. Let's do an example and create our first variable. Inside the script element, we're going to type the code let and space. The word let creates a new variable. And now we're going to choose a name for our new variable. Let's name this variable1. So this creates a variable or a container named variable1. And now we can save a value inside this variable. To do that, we're going to type space equals space, and then a value, like a number or a string. So let's save the number 3 inside, and we'll type a semicolon at the end. So here, we used the let to create a new variable. We named this variable variable1, and we saved the value 3 inside this variable. Now that we saved this value, we can use it later. For example, let's type a new line and type the code console.log. Open bracket, close bracket, and semicolon. Remember from the previous lesson that this code displays whatever's inside the brackets in the console. So far, we put a value inside, like the number 2. If we save, and then go to our website and open the console, so right-click, inspect, and then click the console, we can see that the number 2 was displayed in the console. So now let's try replacing this value with the variable that we created above. So instead of 2, we're going to console.log variable1. If we save, notice that it now displays 3. So it's displaying whatever value is saved inside the variable. As you can see, we can save a value inside a variable and then use that variable later on. Let's do another example. We're going to create another variable. So we're going to create some new lines, and we'll type let. And this time, let's name this variable calculation. And we're going to type space equals space to save a value inside this new variable. And this time, instead of just a number, we're going to save a calculation. 2 plus 2 and semicolon. So this will calculate 2 plus 2 and then save the result, which is 4, into the variable. If we console.log open bracket calculation and semicolon and save, it will show us that the value 4 is saved inside calculation. Now let's try this code. We're going to type a new line and then console.log open bracket and calculation again and plus 2 and semicolon. So here we're using a variable inside a calculation. What this does is that it takes whatever value is saved inside the variable. Right now it is 4, and then substitutes that value into the calculation. So this will be 4 plus 2, which equals 6. If we save, we can see that in the console, it displayed 6. So we can use a variable wherever we use a value. And JavaScript will substitute whatever is inside the variable into the code. Let's do another example. We're going to type some new lines and create a new variable again using let, and we're going to name this variable result. And we're going to make it equal to calculation plus 2 and semicolon. So this does the same thing as the code before. It will take whatever value is inside calculation, which is 4, and substitute it into this code. So we get 4 plus 2 equals 6. But this time, we have an extra step. We're going to save this result, which is 6, into another variable. So if we console.log result and save, we can see that 6 was saved into the result variable. Again, we can use a variable wherever we use a value. Now, in addition to numbers, we can save any type of value in a variable, including strings. For example, let's create a new variable using let, and let's name this message. And we're going to save inside this variable a string this time. So quote, hello, quote, and semicolon. Again, we're going to console.log this variable. So console.log and message, and a semicolon at the end. If we save, it will show us that the string hello is saved inside this variable. Okay, now that we learned how variables work, let's learn the syntax rules for variables. The word let creates a new variable, and then we give the variable a name. So we can name variables almost anything we want, except for a few restrictions. Number 1, we can't use special words like let as a variable name. That's because let already has a special meaning in JavaScript. It creates a variable. So let is a reserved word. However, we can use let1 or let2 as variable names. We just can't use let. Number 2, we can't start a variable name with a number. If we start with a number, JavaScript will think this is a number instead of a variable name. However, we can use numbers in the middle or the end. Lastly, we can't use most special characters, like these or a space in a variable name. However, there are 2 special characters we can use, $ and underscore. So those are the rules for naming variables. And then to save something inside a variable, we just use the equal sign, and then the value we want to save. And that's it. After we create a variable, we can start using it in the rest of our code. Now there's one last part of the syntax that we haven't learned, which is the semicolon. We've seen semicolons in many places already. In JavaScript, a semicolon means this is the end of an instruction. It's similar to a period in English. In English, a period means this is the end of a sentence. So here, this semicolon tells JavaScript that this is the end of an instruction. And now after this, we can add another instruction, like console.log, open bracket, and then the string semicolon, and a semicolon at the end. If we save, it will run these 2 instructions one after another without any problems. So if we didn't have the semicolon here, and we save, it wouldn't work because JavaScript thinks that this entire line is one instruction. So we need semicolons to separate different instructions in JavaScript. If we save, everything goes back to normal. So JavaScript is a little special because it has a feature called semicolon insertion. That means it will try to insert the last semicolon in a line of code automatically. For example, if we removed the last semicolon, and save, this code will work without that semicolon. And that's because JavaScript inserts the last semicolon automatically. However, a lot of companies still prefer to use semicolons in their JavaScript code because semicolon insertion can sometimes put the semicolon in the wrong place. For this reason, we're also going to use semicolons in this course to help you get used to JavaScript code with semicolons. Next, we're going to learn how to change the value that is saved inside a variable. For example, here we save the number 3 inside variable 1. Now we're going to change the value saved inside variable 1. To do that, we're going to go to the bottom and create some new lines. And we're going to type the variable name again. So variable 1. And now to change the value saved inside, we're just going to type the equal sign and then a different value like 5 and semicolon. And now if we console.log this variable, console.log variable 1 and semicolon and save, it will show us that 5 is now saved inside variable 1. Notice also that if we scroll up to the top, the first console.log still displays the value 3. And that's because at this point in the code, variable 1 still contained 3. We didn't update the variable yet. So when we first saved a value inside this variable, this is called assigning a value to a variable. Then when we change the value inside this variable, this is called reassigning a value to a variable. Now let's learn the syntax rules for reassigning a value. Notice that we don't use the word let when reassigning. That's because let creates a new variable. So if we try to use let again, it would try to create a new variable named variable 1. However, variable 1 already exists, and we can't create two variables with the same name. So this would cause an error. Instead, to reassign a variable, we just type out the variable name and make it equal to something else. So that's the syntax for reassigning a variable. Now we're going to do one last example before working on the project. Let's go to the end of our code. We're going to type some new lines. And this time, we're going to reassign variable 1 again. So we can reassign a variable as many times as we want. So let's type variable 1 and then equals, and we're going to type variable 1 plus 1 and semicolon. So we learned earlier that we can use a variable inside a calculation, and it will substitute whatever value is inside the variable. Here, we're also using a variable inside the calculation, but we're using this variable itself. So it's essentially taking this variable, increasing it by 1, and then saving it back. If we console.log this variable, variable 1, and save, variable 1 now contains 6. So it took the previous value in variable 1, which was 5, added 1, and then saved it back. So this is how we increase the value of a variable by a certain number. Okay, now that we know how to create and reassign variables, we're ready to work on a project. So I actually prepared a project that we can do for this lesson. And we can see this project by going to our browser, clicking at the top, and typing supersimple.dev/projects/ cart/variables and press enter. So we're going to work on the cart quantity feature of the final project. So in the final project, we have a number in the top right corner that shows how many products are in our cart. When we click the Add to Cart button, this quantity will increase. So what you see here is a simple version of the cart quantity feature that we can create right now. Let's go over how it works. First, make sure you have the console open on this page. Now, when we click the Show Quantity button, it will show us that there are 0 products in our cart. If we click the Add to Cart button, it will increase the quantity by 1 and display it in the console. If we click Add to Cart again, it will increase the quantity by 1 again. Now in the final project, we can also add more than 1 product at a time using this dropdown. For now, we're going to build a simpler version of that. We're going to use the +2 and +3 buttons to add multiple products. So when we click the +2 button, it will increase the quantity by 2 and display it in the console. And when we click the +3 button, it will increase the quantity by 3. And finally, when we click the Reset Cart button, it will reset the quantity back to 0 and display this message in the console. So now that we understand how this project works, let's build this step by step. First, let's create a new HTML file just for this project. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. Let's name this file 05-cart-quantity.html and press enter. Next, let's open variables.html, and we're going to copy all the code here into our new file. Let's type Ctrl-A on Windows or Command-A on Mac to select all this code, and then right-click, copy, and then in our new file, right-click and paste. Let's close this for now. And in the new file, we're going to change the title to cart quantity. And let's remove all of our JavaScript code, but keep the script element because we're going to write new JavaScript code. Now we're ready to begin. Let's start by creating these buttons. Let's go to the body element. I'm going to create a new line. And here, as we learned in the previous lesson, we can create a button using this HTML code. Less than, button, greater than, and the closing tag less than / button greater than. Inside this button, we're going to have the text show quantity. And let's save. Now let's open this file in Live Server by right-clicking and then open with Live Server. And we can see that we created the first button. Now let's create the other buttons here. Feel free to pause the video if you want to try it yourself. We're going to go back to our HTML and create another button. Inside this one, we're going to have the text add to cart. Let's create another button. This one is going to have the text +2, and we'll create another button. This one is going to be +3, and finally, we'll create the last button. And this one is reset cart. And now let's save. And if we go back to our tab, we've created all the buttons. Now let's make this web page interactive with JavaScript. First of all, we need somewhere to save the cart quantity. So as we learned in this lesson, variables are the perfect solution for this. Variables let us save a value. So let's go into the script element, and we're going to create a variable by typing let. And this variable is going to save the cart quantity. So let's just name it cart, capital Q, quantity. So the cart quantity will start out at 0. So we're going to type equals 0 and semicolon. Next, when we click the Show Quantity button, we want to display the quantity in the console. To do this, we learned a special HTML attribute in the previous lesson called the onClick attribute. So we're going to type in this opening tag here, space onClick equals and double quotes. So the onClick attribute runs some JavaScript when we click this button. And between the double quotes, we can write JavaScript code. So let's press enter, enter. And now when we click this button, we want to display the cart quantity in the console. So let's type console.log, open bracket, close bracket, semicolon. And then between the brackets, we're going to display a message. Now, if we go back to supersimple.dev and we click Show Quantity, we want to display this message in the console. So in our code, between the brackets, we're going to type the string quote cart quantity colon 0. Now let's save and go back to our tab to try it out. So we're going to open the console first by right-clicking and then click Inspect and then click the console. And now when we press the Show Quantity button, it should display that message in the console. Okay, so we just made our project interactive. However, we obviously don't want to display 0 every time. We want to display the value inside cart quantity. So we'll need to insert this value inside this string. Remember from the strings lesson, when we want to insert a value into a string, we're going to use a template string. So let's switch the single quotes to backticks to create a template string. And now instead of 0, we're going to insert a value using $, open curly bracket, and close curly bracket. And in between these brackets, we're going to insert this variable, cart, capital Q, quantity. Remember that JavaScript is case sensitive, so make sure you type the variable name exactly the same. Now let's save and click Show Quantity again. And now it displays the value inside cart quantity in the console. So notice that variables also work with string interpolation. Again, we can use a variable wherever we use a value, and it will just substitute whatever value is saved inside this variable into the code. Now let's make the rest of the buttons interactive. So when we click the Add to Cart button, we're going to add 1 to this cart quantity and display it in the console. So again, we're going to type here and type space on click equals double quotes. And between the double quotes, we're going to add JavaScript. Let's also add some new lines here to make our code easier to read. Okay, so in the onClick attribute, we're going to do two things. The first one is increase the cart quantity by 1. We can do that by reassigning the cart quantity variable. So we're going to type just the variable name, cart quantity, and we're going to make it equal to itself plus 1 and semicolon. Next, we're going to display the updated quantity in the console. So let's press enter, and we're going to display this message again. So we can actually just copy this code. So we'll select it and then right click and copy. And then here, right click and paste. Now if we save and click the add to cart button, we'll see that it increased the quantity by 1 and displayed the updated quantity in the console. Let's press it again to make sure it works. So it increases it by 1 again and then displays it in the console. So that's basically how the cart quantity feature works in the final project. First, we need a variable to save the quantity, and then when we click a button, we're going to update the quantity. So now, let's make the rest of these buttons interactive. Feel free to pause the video if you want to try it yourself. For the +2 button, we're going to add the onClick attribute again. OnClick equals double quotes. And inside, we're going to increase the cart quantity by 2. So cart quantity, and then we'll just make it equal to itself plus 2 and semicolon. And again, we're going to display the updated quantity in the console. So we can create a new line and just copy this code. So select it, right click, copy, and here, right click and paste. Let's save and click +2 a few times. And we can see that it adds 2 to the cart quantity and displays it in the console. For the +3 button, we'll do the same. Let's type an onClick attribute. OnClick equals double quotes. And here, we're going to increase the cart quantity by 3. So cart quantity equals itself plus 3 and semicolon. And we're going to display this in the console again. So we'll select this, right click, copy, and here, right click and paste. Let's save again and try it out to make sure it works. So +3, +3. And finally, let's do the reset cart button. So we'll add the onClick attribute again. OnClick equals double quotes. And inside the double quotes, we're going to do something a little different this time. Instead of increasing the cart quantity, we'll set it back to 0. To do this, we can just reassign the cart quantity variable. So cart quantity, and just make it equal to 0 and semicolon. Now, if we go back to supersimple.dev and try out this reset cart button, you'll notice that it displays 2 messages. The first message is cart was reset. So we're going to display that message in our code first. Console.log and the string cart was reset. And the second message is the same message as the other buttons. So we can just select this and then right click, copy, and then here, right click and paste. And now let's save and go back to our tab and give this a try. So the cart quantity starts at 0. When we press add to cart, increases by 1. This increases by 2. This increases by 3. And when we click reset cart, it'll display cart was reset and reset the cart quantity back to 0. And that's it. We just created a simple version of the cart quantity feature of our final project, using everything that we learned in this course so far. Now we're going to learn some shortcuts for reassigning variables. So if we look at this line of code, here, we're increasing the value of this variable by 2 and then saving it back. Well, there's actually a shortcut for this, and that shortcut is cart quantity plus equals 2 and semicolon. So this does the same thing as the line above, but it's just shorter. The plus means we're going to add 2 to cart quantity, and equals means we're going to save that result back to cart quantity. So we can actually delete this line, and the code will work the same way. If we save and try it out, it will still add a 2 and then save it back in cart quantity. Let's scroll up and practice by using this shortcut for cart quantity plus 1. So instead of this line, we can type cart quantity plus equals 1 and semicolon. So it turns out that in programming, plus equals 1 is so common that we have an even shorter shortcut for plus equals 1. And that shortcut is cart quantity plus plus and a semicolon. So this is the same thing as plus equals 1. And all 3 lines do the same thing. So we can remove these lines, and the code will work the same because it's just a shortcut. If we save, so if we click add to cart, it will add 1 every time. So those are some shortcuts for reassigning variables. We also have these shortcuts for the other operators, like minus equals, multiply equals, divide equals, and minus minus. I'll leave some exercises for these other shortcuts at the end of this lesson. Next, we're going to learn some best practices for naming variables. So if we scroll down, notice that our variable cart quantity has 2 words in it, cart and quantity. We learned earlier that we can't have spaces in a variable name. So if we want to have multiple words, we have to combine them together, like this. Now you might be wondering why we wrote it this way, with a lowercase c and a capital Q. This is actually a naming convention called camel case. In camel case, we combine the words together and capitalize every word except the first word. So for cart quantity, we capitalize quantity, but we keep cart lowercase because it's the first word. Camel case is actually the standard naming convention for JavaScript. All of our variable names should use camel case. Now in programming, there are other naming conventions that exist. Another one is called Pascal case. Pascal case is the same as camel case, except we capitalize the first word. So for cart quantity, Pascal case would be capital cart and capital quantity. In JavaScript, there is one feature where we use Pascal case, which we'll learn later in this course. For everything else, we use camel case. Another naming convention is kebab case. Here, we keep the words lowercase and combine them with a dash, like cart dash quantity. Kebab case doesn't work in JavaScript because the dash is already a minus symbol. However, we use kebab case in HTML and CSS, and also in our file names, as you can see here. And finally, we have snake case, where we keep the words lowercase and combine them with underscores. Snake case is used in other languages, but is not really used in JavaScript. So those are the common naming conventions that we use in programming. Now, one more thing I want to note is that when we name our variables, try to pick a name that is not too short or too long. For example, instead of cart quantity, we could have named this variable C. But this name is too short. It's hard to understand what C means. We could also use a name like this: quantity of products in the cart. But this name is too long. It's hard to read this in the code. So try to have a balance between a name that is understandable but not too long, like cart quantity. The last thing we're going to learn in this lesson is there are 3 ways to create variables in JavaScript. Let's go back to our variables.html file, and we're going to learn those 3 ways. So the first way is to use let, which we already learned. The second way to create a variable is to use the word const. So at the bottom, we can type const space and then a variable name, like variable2, and make it equal to 3. So const creates a variable just like let, except we can't change its value later. This value stays constant. That's why it's called const. If we try to change its value, like variable2 equals 5, and then we save this and we open this file in the browser by right-clicking and then open with live server. And then open the console. So right-click, inspect, and then click the console. It will give us an error when we try to change this variable. So this doesn't work. Let's remove this line and save. So why would we ever use const instead of let? Well, const makes our code safer and easier to understand. When we create a variable with const, we know for sure that this variable will always contain 3. For let, however, if we create a variable, it's hard to know what value is inside this variable, because later on we can change this value in our code. So in order to keep our code safer, it's actually a best practice to use const by default, and only use let when we know that we need to change the variable. So here, it's actually best practice to use const to create this calculation variable, because we're not changing it later. Same thing for the result variable and the message variable. Now for variable 1, we have to use let because we're changing it later in this code. So that's const. It creates a variable that can't be changed later. Finally, the third way of creating a variable is to use another word, var. So at the bottom, we can type var space and then a variable name, like variable3, and make it equal to 3. So var creates a variable just like let, and this variable can be changed later. Var is actually the original way to create variables in JavaScript. Var means variable. However, var has some issues that we'll learn later in this course. And because of these issues, we don't use var in new JavaScript code. You might see var in older JavaScript code, so it's still useful to know. So those are three ways to create variables in JavaScript: let, const, and var. We use const by default, and if we have to change a variable, then use let. So one more thing we're going to learn is that we can use type of with variables. So remember that type of tells us what type a value is. For example, if we wrote console.log type of 3 and save, type of will tell us that 3 is a number. Well, we can actually use type of with a variable. So if we change this to variable 2 and save, type of will tell us the type of value inside the variable, which is a number. And that's what we see in the console. Now let's check the type of this variable, message. So message contains a string. And if we do console.log type of message and save, this will tell us that the value inside the message variable is a string. So we can use type of to check the type of value that is saved inside a variable. And that's the end of this lesson. In this lesson, we learned about variables, which are a way to save values and use them later. We learned how to reassign a variable. We created the cart quantity feature of the final project. We learned some shortcuts for reassigning a variable. We learned some naming conventions and best practices for variable names. And we learned three ways to create a variable: let, const, and var. Here's some exercises to help you practice using variables. In this lesson, we're going to learn two more features of JavaScript called booleans and if statements. And we're going to use these features to build this rock, paper, scissors project. Let's start by creating a new HTML file for this lesson. We're going to go to our code editor and click this icon to show our files, and then click this icon to create a new file. We're going to name this file 06-booleans.html and press enter. Let's open variables.html, and we're going to copy all this code into our new file. Let's select the code using Control-A on Windows or Command-A on Mac, and then right-click, copy, and in here, right-click and paste. Let's close this for now and prepare this file for this lesson. So we'll scroll to the top and change this to booleans, and then remove all the JavaScript code, but keep the script element. Now let's save and open this file in Live Server by right-clicking and then open with Live Server. And we can close the previous tabs as well as the previous code for now. We'll start by learning what are booleans. So far in this course, we learned two types of values in JavaScript: numbers and strings. Booleans are another type of value in JavaScript. But Booleans are special because there are only two Boolean values, true and false. Let's click in the script element and type true. Press enter and type false. So these are the only two Boolean values that exist, true and false. So what's the purpose of Boolean values? A Boolean value represents whether something is true or false. For example, in JavaScript, we can compare two numbers. Let's create some new lines and type the code 3 less than 5. So this code checks whether the number 3 is less than 5. And of course, this is true. So if we console.log this code, console.log, and save, and then go to our website and open the console, right-click, inspect, and console, it will show us that the result of this code is the Boolean value true. Let's try another example. Let's delete this less than symbol and replace it with a greater than symbol. So now this code checks whether 3 is greater than 5. And we know that 3 is not greater than 5. So if we save, the computer will tell us that the result of this comparison is the Boolean value false. So as you can see, a Boolean value represents whether something is true or false. Now let's learn the syntax rules for Booleans. To create a Boolean, we just type true or false. Note that we don't surround these with quotes like this. If we surround them with quotes, this is now a string, not a Boolean. We can use type of to check this. So at the front, we can type console.log type of true. If we save, this will tell us that this is a string. Now, if we remove the quotes and save, this will tell us that this is now a Boolean. So when creating a Boolean, don't put quotes around true or false. Let's save. Now, one way to create a Boolean is to compare two numbers. For example, 3 greater than 5. So this greater than symbol is called a comparison operator. And there are many other comparison operators we can use. We saw less than earlier, and we also have greater than or equal to, less than or equal to, triple equals, which checks if two values are equal to each other, and exclamation double equals, which checks if two values are not equal to each other. Now, JavaScript is a little special because it has two ways to check if two values are equal, triple equals and double equals. The difference is that double equals tries to convert both values into the same type. For example, in our code, let's create some new lines and console.log, and let's check if the number 5 is equal to the string 5.00. If we save, it will tell us that these two values are equal to each other, even though one of them is a number and the other is a string. And that's because the double equals converts both values into the same type. So it converts both of these into the number 5 and then compares them. So that's why they are equal. However, this is not a good idea because this value is a number and this value is a string. It's a piece of text. So they shouldn't really be equal to each other. That's why in JavaScript, we always use the triple equals to check if two values are the same, so that we avoid the conversion behavior of double equals. So if we save, now it will tell us that these two values are not equal to each other, because one value is a number and the other value is a string. So this rule also applies to not equal to. In JavaScript, we always use exclamation double equals instead of exclamation equals to avoid the conversion behavior. All right, so those are comparison operators. In the order of operations, comparison operators have a lower priority than math. So if we did something like 5 and then minus 5, this would calculate 5 minus 5 first, which is 0, and then compare the two numbers. So 3 is now greater than 0. So if we save, the first comparison will now be true. So comparison operators have a lower priority than math operators. Now that we know what Boolean values are, we're going to combine them with a really useful feature called if statements. An if statement lets us write multiple groups of code and then decide which code to run. Let's do an example and create our first if statement. We're going to go to the bottom and create some new lines and type if and open bracket, close bracket, and open curly bracket, closed curly bracket. Between these round brackets, we're going to put a Boolean value like true. And in between the curly brackets, we're going to put some code to run. For example, console.log hello. So the way that an if statement works is that if this Boolean value is true, then we're going to run the code in the curly brackets. If this Boolean value is false, then we're not going to run the code. If we save, the value between the brackets is true, so we're going to run this code and display hello. Now if we change this to false and save, it will not run this code. So an if statement lets us decide whether or not to run some code based on this Boolean value. Now, if statements have another useful feature called else. Let's go to the end of this if statement and type else, open curly bracket, close curly bracket. And then inside these curly brackets, we're going to put some different code like console.log else. The way else works is if this Boolean value is true, the computer will run this code. Otherwise, we will run the code inside else. Let's give it a try. We'll change this Boolean value to true and save. And because it is true, it will run this code and display hello. Now, if this Boolean value is false and save, because it is false, it will not run this code, and it will run the code inside else and display else. So using if and else, we can write two groups of code and then decide which code to run. Now let's do a practical example. We're going to write some code to check if someone is old enough to drive. Let's go to the bottom and create some new lines. And we're going to type if, brackets, and curly brackets. And inside here, we're going to compare two numbers. The first number is a person's age. Let's pretend we have a person who is 30 years old. So we're going to type 30. Then we're going to check if this age is greater than or equal to the legal driving age. Let's pretend the legal driving age is 16. Notice that between the brackets, we don't have to just put a Boolean value. We can put any code that results in a Boolean value. So this comparison results in the Boolean value true. That means the computer will run the code between the curly brackets. So in here, let's type console.log you can drive. Now, if this is not true, let's run some different code. At the bottom, we'll type else and curly brackets, and then inside these brackets, we'll type console.log you cannot drive. Now let's save, and it will tell me that this person who is 30 years old can drive. If we go back and change this to a person that is 15 years old and save, this comparison will result in false. So it will display you cannot drive. So that's how we use if statements. We can write multiple groups of code for different situations and then decide which code to run. Now let's learn the syntax rules for if statements. To create an if statement, we type if, and then round brackets with a Boolean value inside. This is called the condition. If this condition is true, we will run the code inside the curly brackets. We can also add an else statement. This code will run if the condition is false. The else statement is optional. We don't have to have one. So these curly brackets and the code inside, these are called branches because it's like a tree branch. The code is splitting off into two directions, and we either run this code or we run this code. One more thing to know is in a branch, if we only have one line of code, the curly brackets are actually optional. So we can delete these and the code will still work. However, if we have more than one line of code in this branch, for example, if we add another line, console.log congrats, now this branch has two lines of code, so the curly brackets are mandatory. So we have to add them back. Now we're going to learn another feature of if statements, which is we can have more than one condition. For example, we're going to go to the end of this if branch and type else if, and then brackets and curly brackets. Else if lets us add another branch to our if statement. Between these round brackets, we can add another condition. For example, if a person is almost old enough to drive, let's display a different message. So inside this condition, let's check if this person's age, which is 15, is greater than or equal to 14. So we're checking if they are almost old enough to drive. And now inside the curly brackets, we're going to display a different message. Console.log almost there. So the way this works is that the if statement checks the conditions one by one. First, it checks if this is true. If it is, it will run this branch. Then it checks if this is true. If it is, it will run this branch. And if none of the conditions are true, it will run the else branch. So here, this condition is false, so we're not going to run this code. But now the second condition is true, so we're going to run this code. If we save, we display almost there in the console. So using else if branches, We can add as many conditions as we want to an if statement. The next thing we're going to learn is that we can combine if statements with variables from the previous lesson. For example, here we wrote the person's age 2 times. So we can actually save this age in a variable and then reuse that value. So above the if statement, let's create a variable using const, and let's name this variable age, and we'll make it equal to 15. Remember, the best practice for creating a variable is to use const by default, and only use let if we're going to change this value later. And now that we saved this number in a variable, we can use the variable inside the if statement. So we'll replace 15 with age, and here as well with age. So this will take whatever value is inside the variable and substitute it into the code. If we save, the if statement works the same way as before, and we run this line. Okay, now we're ready to use booleans and if statements to do a project. We're going to build a rock, paper, scissors game. First, let's take a look at the project. We're going to go to our browser, and at the top, create a new tab, and we're going to type here supersimple.dev/projects/booleans and press enter. Here we can see a simple version of a rock, paper, scissors game. And if we click this link, it will take us to the final version of this game. So in this game, we can pick a move, and then the computer will pick a random move, and it will show us the result. And we also have a score of how many times we won, lost, and tied. So we're going to build this as we go through the course. But for now, let's go back, and we're going to start by building this simple version of the game. So how this simple version works is we click one of these buttons to pick a move. So let's pick rock. Then the computer will randomly pick a move. In this case, it's paper, but for you, it might be different. And it will compare the two moves and display the results in this pop-up. So the rules of rock, paper, scissors are rock beats scissors, paper beats rock, and scissors beats paper. Let's press OK, and we'll get started on this project. First, we'll create a new HTML file just for this project. Let's go to our code editor and click here and create a new file. And we're going to name this file 06-rock-paper-scissors.html and press enter. Next, let's copy all the code from booleans.html into this new file. So we'll open this again, and then Control A or Command A to select all the code, and then right click, copy, and in here, right click and paste. Let's close this and prepare this file. So we'll change this to rock, paper, scissors, and remove all of the JavaScript code that we had before. Finally, let's save and open this file in the browser by right-clicking and then open with Live Server. Let's take a look at the project again. So we're going to start by creating the text first, because this text is in the final version of the project. So in our HTML, we're going to create a paragraph element for this text. So less than, P greater than, and the closing tag less than /p greater than. Inside our paragraph, we're going to have the text rock, paper, scissors. Next, let's create the buttons. So we'll go to our HTML and create a button. And inside this first button, we'll have the text rock. Let's create another button. This one will be paper. And we'll create the last button. This one will be scissors. Now let's save and check our new tab. And now we created all the elements that we need. Next, let's make these elements interactive with JavaScript. So when writing JavaScript, a good strategy is to think about what steps we need to do and then convert those steps into code. So here, when we click a button, the first step is the computer will randomly select a move, and then we're going to compare the moves to get the result. And finally, we'll display the result in a pop-up. By the way, this is called an algorithm. An algorithm is a set of steps to complete a task or to solve a problem. Now that we know what steps we need to do, we're going to convert these steps or this algorithm into code. First, we're going to run some JavaScript when we click these buttons. So let's use the onClick attribute again. We'll go to the opening tag of the button and type onClick equals double quotes. And then inside these double quotes, we can add our JavaScript. So now we have to figure out how to randomly select a move for the computer. To do this, we need to learn a new piece of JavaScript code. So here, we're going to type capital M math.random, open bracket, close bracket. Math.random generates a random number between 0 and 1. So if we console.log this, console.log, and save, and click this button, and then check in our console by right-clicking, inspect, and the console, it will display a random number between 0 and 1. If we click this button again, it will generate a different random number. So every time we run math.random, it generates a different random number between 0 and 1. Now, to be more precise, it actually generates a number greater than equal to 0 and less than 1. Now let's save this random number in a variable so we can use it later. So we'll replace the console.log with const and then a variable name. Let's just name it random capital N number and then equals. So we saved this random number inside this variable. Next, we need a way to convert this random number into a move, like rock, paper, or scissors. To do this, let's imagine the space between 0 and 1, and then divide this space into 3 equal parts. Each part represents a move. If we generate a random number and it's between 0 and 1/3, the move will be rock. If it's between 1/3 and 2/3, the move will be paper. And if it's between 2/3 and 1, the move will be scissors. This is how we can convert the random number into a move. And this will give the computer an equal chance of picking rock, paper, or scissors. Now let's convert these steps into code. And an if statement is the perfect solution for this. This already looks like an if statement. So in our onClick attribute, let's add some new lines and type if brackets and curly brackets. For this first condition, we're going to check if the random number is between 0 and 1/3. So let's check if random number is greater than or equal to 0. But in this case, we also need to check that random number is less than 1/3, because we're checking if the number is between 0 and 1/3. But how do we do this? How do we check that two comparisons are both true? To do this, we're going to learn another type of operator in JavaScript called logical operators. Logical operators let us combine Boolean values, which is what we need to do here. Let's go back into booleans.html, and we're going to learn logical operators. So first, let's open the tab for this file, and we're going to comment out all the previous code so our console doesn't get too messy. /*, and then at the bottom, */. Now let's create some new lines. And the first logical operator we're going to learn is called the AND operator. Let's type console.log a Boolean value true and another Boolean value true. So this is the AND operator, and it checks if two Boolean values are both true. So it checks if the left side is true and the right side is true. That's why it's called the AND operator. So here, the left side is true and the right side is also true. So the AND operator will result in true. If we save, this displays true. Now, if one of these sides is false, for example, if we change this to false, now let's check, is the left side and the right side both true? In this case, no. So AND will now result in false. If we save, it now displays false. So that's the logical AND operator. It checks if the left side is true and the right side is also true. So this is exactly what we need for our project. For example, let's create a new line and type console.log. And let's say that we generated a random number like 0.2. And we want to check if it's between 0 and 1/3. So we can do 0.2 is greater than or equal to 0. And we're also going to check if 0.2 is less than 1/3. So we're using the logical AND operator to check if the left side is true and the right side is also true. So in this example, both sides are true. 0.2 is between 0 and 1/3. So if we save, this whole thing will display true. Now, in the order of operations, logical operators like AND have a lower priority than math and comparisons. So in this example, it will calculate the math first, and then it will calculate the comparison on the left, and then the comparison on the right, and then at the end, the AND operator checks if both sides result in true. Now let's use the AND operator in our project. Let's go back to the file for our project. And then inside this first condition, we're going to check if the random number is greater than or equal to 0. And at the same time, is the random number less than 1/3. So this is how we check if a number is between 0 and 1/3. In this case, the computer will pick rock. So between the curly brackets, let's just type console.log rock. Let's get some practice and create the other two branches for picking paper and scissors. Feel free to pause this video if you want to try it yourself first. So here, we're going to type else if to add another branch, and then brackets and curly brackets. And in this condition, we're going to check if random number is greater than or equal to 1/3 and random number is less than 2/3. So if this random number is between 1/3 and 2/3, inside here, we're going to console.log paper. And finally, let's create another branch using else if random number greater than or equal to 2/3 and random number less than 1. And console.log scissors. If we save and then go back to our rock, paper, scissors tab and then click the rock button a few times, it will pick some random moves for the computer. So that's how we generate the computer's move. One thing I want to point out is that I use the less than comparison instead of less than or equal to. I just did this so that the comparisons don't overlap. Before we continue in the project, we're going to learn 2 other logical operators we can use. Let's go back to booleans.html, and let's also open the tab for this file. The next logical operator is called the OR operator. For example, let's type some new lines and type console.log true or false. So this is the logical OR operator. It checks if at least one side is true. So it checks if the left side is true or the right side is true. That's why it's called the OR operator. So here, one of these sides is true, so the OR operator will result in true. If we save, this displays true. If both sides are true, it will also result in true because at least one side is true. The last logical operator we're going to learn is called the NOT operator. For example, let's create a new line and type console.log exclamation true. So the exclamation is called the NOT operator. The NOT operator only uses one Boolean value, and it flips it into the opposite value. So if this value is true, the NOT operator will flip it into false. So if we save, this will result in false. Now, if you think about it, if we say that something is not true, that's the same thing as saying that it is false. So that's why this is called the NOT operator. Now, if we change the value to false, again, the NOT operator will flip this into true. So if we save, this will now result in true. So those are the logical OR and NOT operators. We don't need to use these in our project right now, but I'll leave some exercises for these at the end of this lesson. Now let's go back and continue the project. Let's open the code and open the tab. The next step is to compare the computer's move to our move, which is rock. So first, let's save the computer's move in a variable so we can compare it later. So instead of console.log, we're going to create a variable with const computer capital M move and make it equal to the string rock. And we'll do the same thing here. Const computer move equals paper. And here, const computer move equals scissors. And now at the bottom, let's console.log the computer move variable to make sure that it worked. If we save and then click our rock button, unfortunately, it gives us an error telling us that computer move is not defined, even though we created it right here. So what is happening here? If statements have a special feature. They create something called a scope. A scope limits where a variable exists. Basically, whenever we have these curly brackets like this, any variable we create inside the curly brackets will only exist inside the curly brackets. And we can't use these variables outside the curly brackets. So this is called a scope. Scopes are a feature of many programming languages, and they help us avoid naming conflicts. For example, if I create a variable here called random number equals 0.5, and this didn't create a scope, so if I delete these curly brackets, this variable name will now conflict with the variable name up here, because we can't have two variables with the same name. So you can imagine that if we didn't have scope and we had hundreds or even thousands of lines of code, we would quickly start to run out of variable names. So by creating a new scope here, all the variable names inside the scope only exist between the curly brackets, and it won't affect anything outside in the code. So scopes help us avoid naming conflicts. Okay, so I'll delete this example, and we'll learn how to access this variable outside of this scope. So to access this variable outside of the if statement, we have to create this variable outside of the if statement. So above here, we can create this variable. Const computer move. And let's just make it equal to the empty string for now. So this variable was not created inside any curly brackets. So it's accessible from all of this code inside the onClick attribute, including inside the if statement. And then inside the if statement, instead of creating a new variable, we're just going to save the move inside this variable up here, because we can access this variable anywhere else in the code. So instead of using const, we're just going to reassign computer move. And we're going to remove it here as well, and here as well. And remember, when we reassign a variable, we have to switch from const to let. And now if we save and then click the rock button, we're able to console.log computer move, because computer move is no longer inside this scope. It's up here. So we can access it in this line of code. So that's how scope works. Any variable that we create inside curly brackets will only exist inside the curly brackets. So remember in the previous lesson, we learned a third way of creating variables called var. The issue with var is that it doesn't really follow the rules of scope. For example, here, if we create a variable with var, like var and random number equals 0.5, this variable will conflict with the variable up here with the same name, even though it's inside a scope. So that's why we don't use var anymore, and we just use const and let. because var doesn't really follow the rules of scope. So we can remove this for now and move on to the next step. So we generated a random move for the computer. Now we have to compare our move, which is rock, to the computer's move to get the result and see who wins. To do that, we'll use another if statement. So at the bottom here, let's type if, and then brackets and curly brackets. And then inside this condition, let's check if the computer move is equal to rock. So remember, in JavaScript, we always use triple equals instead of double equals to avoid the conversion behavior. And now if the computer's move is rock and our move is rock, then inside the curly brackets, the result is going to be a tie. And let's save this string in a variable so we can use it later. Again, we have the same situation as before. We don't want to create the variable inside here because then it only exists in this scope between the curly brackets. Instead, we're going to create the variable above, outside the if statement. So we'll use let to create this variable because we're going to reassign it in the if statement. Let's name this variable result and just make it equal to the empty string at the top. And then in the if statement, we'll save the result into this variable. So result equals tie. Now let's create the other branches of this if statement. So here we'll add else if brackets and curly brackets, and we'll check if the computer move is equal to paper this time. If the computer move is paper and we picked rock, then we lose. So the result is equal to you lose. And finally, we'll add another else if brackets and curly brackets, and we'll check if the computer move is equal to scissors. And if the computer picked scissors and we pick rock, the result is that you win. So that's how we compare our move to the computer's random move using an if statement. The last step is to display this result in the pop-up. So at the bottom, let's create a pop-up using alert, open bracket, close bracket, and let's go back to Super Simple Dev to see the message in the pop-up. So we'll click this, and in the pop-up, it shows our move, the computer's move, and then the result. So we can actually just copy this, right-click, copy, and then in here, right-click and paste. So obviously, the computer is not going to pick this move every time, and this is not going to be the same result every time. Instead, we want to insert computer move into here, and we want to insert result into here. So because we want to insert values, we're going to turn this into a template string using backticks. And now instead of paper, we're going to insert a value using $ and curly brackets, and we're going to insert the variable computer move. And instead of this text every time, we're going to insert the variable result. And now if we save, and we can click OK to close this, and go back to our tab and click the rock button, we're going to pick rock, the computer will pick a random move and it will show us the result in a pop-up. So that's how we create this simple version of rock, paper, scissors. In our code, we did things step by step. First, we generated a random number, we converted it into a move for the computer, and then we compared our move to the computer move, and we displayed the result in a pop-up. So as you can see, when we're writing JavaScript, we first figure out what steps we need to do. This is called an algorithm. And then we convert these steps or this algorithm into code. So now we can actually remove this console.log because we don't need it anymore. And the last step is to make the other buttons here interactive. So feel free to pause this video if you want to try it yourself first. For the paper button, let's add some new lines to make it a little easier to read. And again, we'll add the onClick attribute. And then inside here, we can actually make a copy of all the JavaScript we wrote. So we can select all of this and then right-click, copy, and then in here, right-click and paste. If the formatting doesn't look right, we can select all of these lines and press Tab to add indents until the formatting looks good. The one thing we have to change here is that now we picked paper, so the result is going to be different. If the computer picks rock and we pick paper, that means you win. If the computer picks paper, now it means that we tie. And if the computer picks scissors, that means you lose. And here we'll also change you pick rock to paper. And that's it. The last step is to make the scissors button interactive. So again, on click equals double quotes, and then we'll make a copy of the code. So I already have it, so just right click and paste. And then again, select the code that we need to fix the formatting for and press Tab. And here we pick scissors. So if the computer picks rock, then the result is you lose. If the computer picks paper, the result is you win. And if the computer also picks scissors, the result is a tie. And we'll change you picked rock to scissors. Now, if we save and try out our game, if we click rock, we're going to pick rock, computer picks a random move, and it will show us the result here. Let's press OK and try paper. This also works correctly. Let's press OK and click scissors. And this also works correctly. And that's it. We just finished creating a simple version of this rock, paper, scissors game. In the rest of this lesson, we're going to learn more details about booleans and if statements. Let's go back to booleans.html and open the tab for this file. And let's comment out the previous code using /* and */ and create some new lines. The next thing we're going to learn is called truthy and falsy values. So if statements don't just work with Boolean values like true and false. They actually work with any type of value, including numbers and strings. For example, let's type if, brackets, and curly brackets, And inside this condition, instead of putting a Boolean value, we're going to put a number like 5. And then inside the curly brackets, let's console.log the string truthy. If we save, the number 5 behaves just like true. It causes the if statement to run this code. So we call this value a truthy value because it behaves just like true. Now let's change this value to a different number, 0. If we save, the number 0 behaves just like false. It causes the if statement to not run this code. We call this value 0 a falsy value because it behaves just like false. So how do we know if a value is truthy or falsy? In JavaScript, the list of falsy values are false, the number 0, the empty string, nan, undefined, and null. Any value that is not on this list is a truthy value. So why do we use truthy and falsy values? One way we use them is like a shortcut in our code. For example, let's create a variable at the bottom using const, and let's call it cart quantity and make it equal to 5. Next, let's create an if statement. If, brackets, and curly brackets, and inside the curly brackets, let's type console.log the string cart has products. Now let's say that we only want to display this message if our cart has products. Usually, inside this condition, we would check if cart quantity is greater than 0. But now, instead of doing this comparison, we can actually just type cart quantity, and it will behave the same way. If the cart quantity is not 0, they will both behave like true. If the cart quantity is 0, they will both behave like false. So here, the cart quantity is 5, which is a truthy value. If we save, this causes the if statement to run this code. As you can see, instead of doing comparisons, we can use truthy and falsy values as shortcuts. Truthy and falsy values also work with logical operators. For example, if we console.log the not operator and the number 0, 0 is a falsy value. It behaves just like false, so the not operator will flip it into true. If we save, this will display true. Now that we understand truthy and falsy values, let's go over the list of falsy values, because there are some that we haven't learned yet. We already learned false, 0, and the empty string. The next falsy value is nan, which means not a number. We get nan if we do some invalid math. For example, at the bottom, let's type console.log the string text divided by the number 5. So obviously, this is not valid math. If we save, JavaScript will tell us that the result of this calculation is not a number, or nan. The next falsy value is undefined. Undefined represents that something doesn't have a value. For example, at the bottom, if we create a variable with let variable 1 and we don't give it a value, and then we console.log this variable, and we save, it will show us that variable 1 contains the value undefined. So undefined represents that this variable doesn't have a value. One thing to note with undefined is that we can only use this syntax with let. We can't use it with const. If we really want to use this with const, we have to type out equals undefined directly. The last falsy value is null. We'll need some extra knowledge to understand null, so we'll learn about null later in this course. The last thing we're going to learn in this lesson are some shortcuts for if statements, called the ternary operator, the guard operator, and the default operator. First, let's comment out this code so our console doesn't get too messy. /*, and then at the bottom, */. And let's scroll down, and we'll start by learning the ternary operator. We're going to type a Boolean value like true and question mark, another value, for example, the string truthy, and then colon and another value like the string falsy. So this is the ternary operator. This is similar to an if-else statement. The first value is like the condition. If it's truthy, the result of this code is the value after the question mark. If the first value is falsy, the result of this code is the value after the colon. So you can think of the question mark as the if branch and the colon as the else branch. This is sort of like a shortcut for an if statement like this. Now, an advantage of the ternary operator over an if statement is that we can save a ternary operator in a variable. So at the front, we can do const result equals. And now if we console.log the result and save, the first value is true. So the value after the question mark gets saved in the variable. As always, we can use truthy and falsy values instead of just true and false. So here, if we change the first value to a falsy value like 0, this will cause the value after the colon to get saved inside the variable. If we save, that's exactly what happens. So this is the ternary operator. It's sort of a shortcut for an if-else statement like this. The next shortcut is called the guard operator. Earlier in this lesson, we learned the AND operator, which checks if two sides are both truthy. The AND operator has a special feature. Let's say we have an AND operator and the left side is false. In this situation, we already know it's impossible for both sides to be truthy, so we don't even need to check the right side. So the AND operator actually stops early and doesn't even run the code on the right. This is called a short circuit evaluation. For example, let's go into our code and create some new lines, and we'll type false and console.log hello. If we save, the left side is falsy, so the AND operator stops early or short circuits, and it doesn't even run the code on the right. So as you can see, we can use the value on the left to block or guard the code on the right. So when we use the AND operator like this, we call it the guard operator. This is sort of like a shortcut for an if statement like this. And just like the ternary operator, we can save the guard operator in a variable. For example, let's create a variable const message and make it equal to false and the string hello. If the first value is falsy, the guard operator will stop early, and the result will be the first value. If we console.log this message and save, the value false will be saved inside this variable. Now let's change this value to a truthy value, like the number 5. Now it will not stop early, and it will give us the second value as the result. If we save, the string hello is now saved inside this variable. This is sort of like a shortcut for an if statement like this. So don't worry if it's a bit confusing. All of these are just shortcuts for an if statement. They're sort of like an if statement that we can write on a single line. The last shortcut is called the default operator, which is similar to the guard operator but uses OR. Earlier in this lesson, we learned the OR operator, which checks if at least one side is truthy. Let's imagine we have an OR operator, and the left side is true. In this situation, we already know the result of the OR operator, because the left side is already truthy. We don't even need to check the right side. So the OR operator also stops early or short circuits if the first value is truthy. For example, let's create some new lines. And let's say that in our final Amazon project, we can choose a currency to pay for our order. Let's create a variable with const currency and make it equal to the string EUR, or euros. Now let's say that choosing a currency is optional. If we don't choose a currency, we'll use a default value of USD, or United States dollars. To create a default value, we can go to the end and type or the string USD. So here, the left side is truthy. So the OR operator will stop early, and it will result in the value on the left. If we console.log the currency and save, it will display euros. Now let's say that we didn't choose a currency because it's optional. So let's go here, and we're going to change this currency to undefined. Now the left side is falsy, so the OR operator does not short circuit. It will continue, and the result will be the value on the right. If we save, now the string USD is saved inside currency. As you can see, we can use the OR operator to set a default value. So when we use the OR operator like this, we call it the default operator. The default operator is sort of a shortcut for an if statement like this. So don't worry, remember that everything that we learned in this last section are basically some shortcuts for if statements. We don't have to use them, but they can save us some typing. And that's the end of this lesson. In this lesson, we learned about Booleans and if statements. Boolean values represent whether something is true or false. We learned how to use if statements to make decisions in our code. We learned how to use comparison and logical operators. We learned about algorithms and created a simple version of rock, paper, scissors. We learned about truthy and falsy values. And we learned some shortcuts for if statements: the ternary operator, the guard operator, and the default operator. Here are some exercises to help you practice Booleans and if statements. In this lesson, we're going to learn the next feature of JavaScript called functions. And we're going to use functions to improve our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and create a new file. And let's name this file 07-functions.html and press enter. Next, let's copy booleans.html to functions.html. So we'll click this file and then select all this code using Control A or Command A, and then right click, copy, and in here, right click and paste. And we'll hide our files and prepare this file for this lesson. So at the top, we'll change the title to functions, and we'll remove all the code in the script element. And let's save, and we'll open this file in Live Server by right-clicking, Open with Live Server. And we're going to open the console as well. So right-click, Inspect, and then click the console. And finally, we can close the previous tabs as well as the previous code. Okay, now we're ready to learn functions. First of all, what is a function? A function lets us reuse code. Let's create our first function. We're going to go to the script element and type the word function and space. So this creates a new function. And then we're going to give a name to our function. We can name it almost anything we want, but for now, let's just name it function1. And then we're going to type round brackets and curly brackets. Then inside these curly brackets, we're going to create a new line and we're going to type some code. So console.log the string hello, and we'll also type console.log 2 plus 2 and save. So this creates a function. Now let's learn how to use this function. We're going to type at the bottom the function name. So function1, and then open bracket, close bracket, and semicolon. When we type the function name with brackets, this will run the code inside the function. If we save, notice that it runs the code inside the function and displays the two lines in the console. So why do we use functions? A function lets us reuse code. So if we wanted to run both these lines of code again, all we have to do is type the function name again with brackets. So function1 and brackets again. If we save, this will run the code inside the function 2 times. And we can reuse this code as many times as we want by typing the function name with brackets. So that's what a function is. It lets us reuse code. Now let's learn the syntax rules for functions. The word function creates a new function, and then we choose a name for our function. The rules for function names are the same as variable names. We can't use special words like function, we can't start with a number, and we can't use special characters, although $ and underscore are allowed. And just like variable names, the best practice is to use camel case for function names. And inside these curly brackets, we put the code that we want to run when we use the function. This is called the function body. Now, one very important thing to remember is that this code only creates a function. It doesn't run the code in the function or do anything else. In order to actually run the code, we have to use the function like below by typing the function name with brackets. This is known as calling the function. It's also known as running the function or executing the function. Now that we learned the syntax rules for functions, let's do a practical example. We're going to use functions to improve the code of our rock, paper, scissors project. First, let's click here to show our files, and we're actually going to make a copy of the project just for this lesson. So we're going to right-click this file, copy, and then at the bottom, right-click and paste. And we're going to rename this file. So right-click, rename, remove copy at the end, and then at the beginning, we'll change this to 07 and press enter. Next, we're going to open this file in Live Server by right-clicking and then open with Live Server. And let's also open the console on this page. We'll right-click, inspect, and then click the console. All right, now if we look at the code for generating a computer move, you'll notice that this code is the same for all three buttons. So this is a perfect situation to use a function, because a function lets us reuse code. So let's scroll down to the script element, and we're going to make a function here. So let's type function and then a function name. Let's name this function pick computer move, and then brackets and curly brackets. So one recommendation for function names is to use a verb or an action in the name, such as pick. So next, we're going to move all the code for picking a computer move into our new function. So let's create a new line here, and we'll scroll up to the scissors button because it's the closest one, and we'll select all of this code for picking a computer move, and then right-click, cut, and inside the function, right-click and paste. If we need to fix the formatting, we can select these lines and press Tab to add indents. So the reason we created this function in the script element is because remember that the script element runs when the page is loaded. So we want to make sure that we create the function first, and then we use it in the buttons after. Now remember, this code just creates a function. It doesn't actually run the code inside. To run the code inside, we're going to call this function. So let's scroll up to the scissors button, and we're going to call this function by typing the function name pick computer move, open bracket, close bracket, and semicolon. If we save and then click the scissors button. Unfortunately, it now gives us an error saying computer move is not defined. Now, this might seem weird because down here, we actually create the computer move. So what's going on? The reason this happens is because functions create a scope. In the previous lesson, we learned about scopes, which limit where a variable exists. We learned about if statements, and that if statements create a scope between the curly brackets. This means that any variable created between the curly brackets only exists between the curly brackets. Functions also create a scope. Any variable that is created between these curly brackets only exists inside the curly brackets, and we can't use it outside the curly brackets like we do here. So that's why we're getting this error. So how do we solve this problem? Remember that with if statements, we solve this by creating the variable outside of the if statement, like this. We can use a similar solution with functions. To make this variable exist outside the function, we just have to create it outside the function. So let's select this code. We're going to right-click and cut and remove these lines. And then outside the function, we're going to right-click and paste. So now this variable is no longer inside the function's scope, and it can be used anywhere else in the code. So variables like this that can be accessed anywhere are called global variables. If we save and now click the scissors button, everything is working again because this code above can now access this variable. Now let's press OK, and let's use this function to reuse this code. So we'll scroll up to the paper button, and now instead of all this code again, we're just going to remove it and call the function pick computer move, open bracket, close bracket, semicolon, and also with the rock button. We'll select all this code and remove it and just call the function pick computer move, brackets and semicolon. Now, if we save and click the rock button, it works just like before. We'll press OK and click the paper button. It also works just like before. So as you can see, functions let us reuse code, and they make our code a lot cleaner by removing all the duplication that we had. Another benefit of removing duplication is that before, if we ever wanted to update the code for picking a computer move, we had to update it in 3 places in each of the buttons. But now, if we scroll down, we only have to update it in 1 place inside this function. So functions also make our code easier to update in the future. Next, we're going to learn a feature of functions called a return statement. A return statement lets us get a value out of a function. So at the end of this function, let's type some new lines, and we're going to type return, and then a value like the number 5 and semicolon. Now, whenever we call this function, it will result in a value, the number 5. So up here, when we call this function, this will result in the number 5. So we can actually console.log this, console.log, and then save and click the scissors button. and it will show us that calling the function now results in the number 5, and we display it in the console. So that's how a return statement works. It lets us get a value out of this function. Let's press OK and do another example. We'll scroll down, and this time let's change this value to the string rock. Now, whenever we call this function, it will result in the string rock. If we save and then click scissors and scroll up here, calling this function now results in the string rock. And then we display it in the console. So now let's press OK, and we'll learn the syntax rules for a return statement. So we just have to type the word return and then a value, and it will get this value out of the function. Now, instead of just a value, we can also return a calculation or a variable or anything that results in a value. So this is known as returning a value from a function. And this value is known as the return value. We also don't have to return anything from a function. If a function doesn't have a return statement, or we return without a value, like this will return the value undefined. So if we save and then click scissors again, the function will return undefined. And lastly, when we use a return statement, it ends the function immediately. So after the return statement, if we type console.log the string after and press OK here and save this file, and then click the scissors button, notice that it doesn't run this code. And that's because once we return, the code returns back to where we called the function. That's why it's called a return statement. So it's not going to run anything after the return. So we can remove this code and press OK. So now that we understand return statements, we're going to learn a better way of getting the computer move out of this function. So first, let's actually move this variable back into the function. So we'll right click and cut, and then in here, right click and paste, and delete these lines. So now we're back to the original problem. How do we access computer move outside of the function? So another solution is to return this variable, because remember, a return statement lets us get a value out of the function. So down here, we're going to return the computer move. So this will take whatever value is saved inside computer move, which is one of these values, and return it out of the function. If we save and then click the scissors button, we were able to get the move scissors outside of this function. So what happened here is that we returned this move, and then up here, we took the move and displayed it in the console to get scissors. So that's another way of getting the computer move out of a function using the return statement. However, now we're back to this problem with computer move not being defined because we moved it back into the function's scope. So let's scroll up and remember that this return value is just a value. We can use it like any other value. For example, we can console.log it, or we can also save this in a variable. So let's do that right now. we're going to remove this and create a new variable with const. And let's just name this variable computer move to match what we use down here. And we'll use equals to save the return value inside this variable. So note that even though we use computer move here as well as here, they're different variables. This one is inside the function's scope, so it prevents it from conflicting with variables outside the function's scope. That's one of the main benefits of scopes. So now that we save the return value into this variable, and we're using this variable down here, the code should now work. If we save and click scissors, everything is back to normal. And let's press OK. So don't worry, functions can be a little confusing at first because the code is no longer simply going from top to bottom. It sort of jumps around a little bit. So let's go through this step by step. When we click this button, we're going to run this function. So the code is going to jump down here. And then it's going to run all of this code from top to bottom. At the end, we're going to return whatever is inside computer move back to where we called this function. So we're going to return all the way back here. And then we're going to save that return value into a new variable, computer move, and then use computer move down here. So following the code line by line like this is called tracing the code. It's a useful technique to understand exactly what the code is doing. Now let's compare the two solutions that we used, a global variable and returning a variable. So returning a variable like this is actually preferred over using a global variable. And that's because a scope can help us prevent naming conflicts. So all the variables inside here will not conflict with anything outside the scope. So generally, it's a best practice to keep things inside a scope if we can. Now let's move on and use this function in the other buttons. Feel free to pause the video if you want to try it yourself first. So we'll scroll up to the paper button. And then here, we're going to save the returned computer move into a variable. So const computer move so that it matches the code down here. Make it equal to whatever is returned. And then same thing for the rock button. We're going to save the return value in a variable const computer move equals. If we save and click the rock button, it works. Let's press OK and click the paper button, and this also works. And let's press OK. So that's how we use a return statement to take advantage of the benefits of scope. Next, if we look at the rest of this code, where we compare our move and display the result, you'll notice that this code is very similar for each of the buttons. The only thing that's different is the result and the message that we display. So we can actually use functions here as well to reuse code that has small differences. To do this, we're going to need another feature of functions called parameters. So let's go back into functions.html and let's open the tab for this file. And let's also comment out the previous code by typing /* and at the bottom */ and create some new lines. And now we're ready to learn parameters. So parameters are sort of the opposite of a return statement. A return statement gets a value out of a function. A parameter puts a value into a function. So let's do an example. Let's say that we're working on the final Amazon project, and we need to calculate the tax for our order. Let's create a function to calculate the tax. So function, let's name it calculate tax, brackets and curly brackets. And then inside the curly brackets, let's say that the cost of our products is 1,000 cents or $10, and the tax is 10%. To calculate the tax, we can do 1,000 times 0.1, which is 10%. Let's also display this number in the console. So at the front, we'll type console.log and brackets. Now let's save. And remember, this code only creates a function. It doesn't run the code inside. To run this code, we're going to call this function. So down here, we're going to type the function name, calculate tax, and then brackets. If we save, it runs this code, and then it displays the tax, which is 100 cents or $1. However, right now, this function only calculates the tax for 1,000 cents. What if we want to calculate the tax for a different amount? How would we modify this function to work with any number? To do this, we're going to learn a feature of functions called parameters. A parameter lets us put a value into a function. So let's finally create our first parameter. So inside these round brackets, we're going to choose a name for our parameter. So let's just name this parameter 1. A parameter works the same way as a variable. We can save a value inside this parameter and then use it just like a variable. So first, let's save a value inside the parameter. To do that, we're going to go to where we call the function. And then inside these brackets, we're going to put a value. For example, 2,000. This will save this value into this parameter. And now we can use it just like a variable. So instead of 1,000, we're going to type parameter 1. And it will take whatever value is inside parameter 1, in this case 2,000, and substitute it into the code. If we save, it now calculates 2,000 times 0.1 to give us 200 cents as the tax. Now, every time we call the function, we can save a different value into the parameter. For example, let's create a new line and call the function calculate tax. And this time, we're going to save the value 5,000 into parameter 1. If we save, this line of code will calculate the tax for 5,000 cents and result in 500 cents. So as you can see, a parameter lets us put values into a function, and this allows our function to work with any value. Now let's learn the syntax rules for parameters. To create a parameter, we just typed the parameter name between the brackets. Parameter names follow the same rules as variable names. We can't use special words, we can't start with a number, and we can't use special characters other than $sign and underscore. And the best practice is to use camel case. Let's actually change this parameter name to cost. so the code makes more sense. And save. Next, when a function has a parameter, we usually say this function takes a parameter. If this parameter should be a number, we say this function takes a number. When we put a value into the function like this, we call this passing a value into the function. Another name for this value is called the argument. And believe it or not, we've actually used functions and parameters this whole time. The first code that we learned in this course was alert. Alert is actually a function. You can tell it's a function because of the round brackets. And between the brackets, we put a string. So this is an example of a parameter. And lastly, a parameter only exists inside the function's scope. So we can only use this parameter between the curly brackets. We can't use it outside the function. Next, a function can actually have more than one parameter. For example, right now, our calculate tax function can only calculate a 10% tax. But what if we're in a different country and we want to calculate a different tax percent? To solve this, we can add a second parameter by typing after the first parameter a comma and then another parameter name. Let's name this tax percent. And now to save a value into the second parameter, we'll go to where we call this function and also type a comma and a second value like 0.2 or a 20% tax. So the first value gets saved in the first parameter and the second value gets saved in the second parameter. And now we can use our second parameter just like a variable. So instead of 0.1 every time, we're going to calculate it with tax percent. And it will substitute whatever value is inside tax percent into the code. If we save, this first line will multiply 2,000 by 0.2 and give us 400 cents as the result. So we can have as many parameters as we want in a function. We just have to separate them with a comma. Now notice that the second time we call this function, we didn't give a value for the second parameter. If we don't save a value into the parameter will get the value undefined. So here, if we console.log the second parameter, tax percent, and save, it will show us that the second time tax percent is undefined. And then multiplying the cost times undefined is not valid math. So we get the result nan, or not a number. So now let's remove the console.log and we'll learn how to fix this. So to fix this, we can either pass a second value into the function, like this line, or we can also set a default value for the parameter. To set a default value, we can just type after the parameter and then add equal sign and a default value, like 0.1. If we save, the second function call will multiply 5,000 by the default value 0.1 and give us 500. So that's how we add a default value for a parameter. All right, now that we learned parameters, we're going to go back to the rock, paper, scissors project and reuse even more code. So let's go back to the file for the project and also the tab for this project. And now, if we look at the code inside each of the buttons, you'll notice that the code is basically the same for all three buttons. The only small difference is the move that we picked. So this is a perfect situation to use a parameter. So inside the script element, let's create a new function to reuse all of this code. We'll type function, and let's name this function play game, brackets and curly brackets. Next, let's move all of this code inside the function so we can reuse it. We'll select this code and then right-click, cut, and inside the function, right-click and paste. And if we need to reformat, we can select these lines and press Tab. So the value that is different for each button is the move that we picked. So we're going to turn this move into a parameter. So at the top, between the brackets, we're going to create a new parameter. Let's name it player move. And now let's save a value into this parameter. So inside our scissors button, we're going to call this function and run all this code. So let's type play game and call this function. And for the scissors button, let's save the string scissors into player move. To do that, we'll type between the brackets here and type the string scissors. So as we learned, this will save scissors into player move. And now we can use player move just like a variable in the function. Now let's modify the code based on the parameter. So here, this code calculates the result. However, this only works if the player move is scissors. So we're going to put this in an if statement. So we'll type if player move equals scissors and curly brackets. Inside this if statement, we're going to put this if statement. So let's select this and then right click, cut, and then inside here, right click and paste. And select these lines and press Tab. So notice that we can put an if statement inside another if statement. And we did this because this code only makes sense if the player move is scissors. And finally, let's modify the code that displays the message. So here, instead of displaying scissors every time, we're going to display whatever is saved inside player move. So we'll replace it with $, open curly bracket, close curly bracket. And in between, we'll insert player move. And that's it. We modified this function to use a parameter instead of always using scissors. Now let's save and click the scissors button. And you'll notice that it works. We display the move scissors and we calculated the result correctly. Let's press OK. And we're going to use this function to reuse the code for the other buttons. So we'll scroll up, and for the paper button, we're going to use a different if statement to calculate the result. So let's actually copy this into the function. We're going to right-click, click Copy, and then inside the function, we're going to create another branch if the player move is paper. So here, let's type else if brackets and curly brackets. Inside this condition, we're going to check if the player move is equal to paper this time. And then inside these curly brackets, we're going to paste the if statement we copied earlier. So right click and paste. And we can select these lines and press tab to reformat. So now we have the code that determines the result for paper. Down here, we don't need to modify this code because we're always displaying whatever is inside player move. Finally, we can scroll up to the paper button and remove all this duplicated code and just use our function, play game, and we're going to pass paper inside. So now paper will get saved inside player move, and it's going to run this if statement instead. If we save and click the paper button, in this example, I picked paper, computer picked rock, and it calculated the result correctly. Let's press OK and use this function for the rock button. Feel free to pause the video if you want to try it yourself first. So let's scroll up to the rock button. And first, we need to copy this if statement into the function. So let's right click, copy, and then inside the function, let's create a branch for rock. Else if player move is equal to rock, and then curly brackets, and inside here, we're going to right click and paste the if statement we copied earlier. And now let's select these lines and press tab a few times to reformat. And again, this doesn't need to change. The last step is to scroll up to our rock button. And instead of duplicating all of this code, we're going to remove it and just call our function instead. Play game, brackets, and then inside we'll have the string rock. Now let's save and click the rock button. So I picked rock, the computer picked paper, and we calculated the result correctly. Let's press OK. So by using a function with a parameter, we were able to reuse all of the code in our buttons. And you can see that it made our code a lot cleaner. So lastly, notice that inside a function, we can call other functions. Let's go through the code step by step so that we understand how it works. So here, when we call the play game function, we go inside here, and then we call the pick computer move function. So now we're going to go inside this function and run all the code. And then when this function returns, we're going to return back to where we called it, and then keep going and run the rest of the code. And then when the play game function finishes, it's going to return back to here. So inside a function, we can call other functions. Now, one last thing we're going to do for this code is we'll scroll down and we're just going to add some new lines to this if statement to separate the branches and make the code a little easier to read. And save. And let's scroll up. And that's the end of this lesson. In this lesson, we learned about functions, which let us reuse code. We learned how to get a value out of a function using return. We learned how to put values into a function using parameters, and we improved the code for our rock, paper, scissors project by reusing the code and removing duplication. Here are some exercises you can do on your own to practice using functions. In this lesson, we're going to learn another type of value in JavaScript called objects. And we're going to use objects to create a score in our rock, paper, scissors project. First, let's create a new file for this lesson. We'll go to our code editor and click this icon, and then click this icon to create a new file. And we'll name this file 08-objects.html and press enter. Next, we'll copy all the code in functions.html to objects.html. So we'll type here and press Ctrl A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide the files for now, and we'll prepare this file for this lesson. So we can change this to objects and remove all the code in the script element. Finally, let's save and open this in Live Server by right-clicking, Open with Live Server. And let's also open the console on this page. So we'll right-click, click Inspect, and click the console. Let's close our previous tabs and also the previous code. And now we're ready to learn objects. So what is an object? An object groups multiple values together. Let's do an example and create our first object. We'll go to the script element and we'll create a variable using const, and we'll name this variable product and make it equal to open curly bracket, close curly bracket, and semicolon. So this is an object. Inside this object, we can add some values. So we'll type enter and then name, colon, and then a value like the string socks. And at the end, we'll type a comma and then price, colon, and another value like the number 1090. So inside our object, we just added two values. So at the bottom here, let's try console.logging this object. Console.log product and save, and it will display both values into the console. So as you can see, an object lets us group multiple values together. So for each of these values, we have some code on the left. This code is called the property. And using the property, we can access specific values in the object. For example, let's type and enter and console.log. We're going to type the object product and then a dot and then a property like name. So .name will access the value that is associated with the name property, which is the string socks. So if we save, it will display the string socks in the console. Let's do another example, and we'll access this second value using the property price. So we'll type enter console.log the object, product, and then a dot, and then a property, price. So this will access the value associated with price, which is 1090. If we save, that's what gets displayed in the console. Now we can also use the property to change a value inside an object. To do that, we're going to type the object's name, product, and then dot, and a property like name, and just make it equal to something else, like the string cotton socks. So this code will change the value associated with the name property to cotton socks. So at the bottom, if we type console.log the product again and save, you'll notice the value associated with the name property was changed to cotton socks. So that's how an object works. We group multiple values together, and then we can access or change these values using the properties on the left. Now let's learn the syntax rules for objects. To create an object, we start with an open curly bracket and end with a closed curly bracket. Inside the object, we can put multiple values. For each value, the code on the left is called the property. This is how we access the value inside the object. We separate the property and value with a colon, and this is called a property value pair. We can have many property value pairs in an object, and we separate them with a comma. To access a value inside the object, we type the object's name, and then dot, and then the property we want to access, like name. This will give us the value associated with the name property. This syntax is called dot notation. If we access a property that doesn't exist, the value will be undefined. To change a value in an object, we can use the dot notation again. So product.name, and just make it equal to something else. Now using this syntax, we can also add a value to an object. We can type a property that doesn't exist. For example, here we can type product.new property and make this equal to something, like the Boolean value true. If we console.log the product again and save, it will add this value to the object along with the new property. We can also remove a value from an object by typing delete, and then the object product dot, and then the property we want to delete, like new property. If we console.log the product again and save, this code will delete new property from the object. And lastly, notice that an object is just another type of value. We can save an object inside a variable, and we can also console.log objects. If we check the type of this value, so type of product, and save, and scroll up in the console, it will tell us that product is an object. So let's remove this and save. And now we'll learn why we use objects. So objects make our code more organized. Instead of creating a bunch of variables for the product's values like the name and the price and other details, we can just group all these related values together into one object. Objects also allow us to use multiple values together. Instead of console.logging each of these values individually, we can just console log the whole object and display all the values at once. So objects let us group multiple values together and let us use multiple values together. Next, let's do a practical example with objects. We're going to add a score to our rock, paper, scissors game. So I've actually prepared a project we can use for this lesson. To see this project, we're going to go to our website and then create a new tab. And then up here, we're going to type supersimple.dev/projects/objects and press enter. So this is our simplified rock, paper, scissors game again, except in this project, when we play the game, it's also going to keep track of a score. So how many times we win, lose, and tie. And also, if we click OK, we have a reset score button. So if we play the game a few times and add to our score, and then click the reset score button, this will reset the score back to 0. So if we play the game again, the score starts from 0 again. So we're going to learn how to use objects to create this feature. Let's press OK. And first, let's create a copy of our project just for this lesson. We'll go to our code editor and click this icon to show our files, and we'll make a copy of the rock, paper, scissors project from the previous lesson. So we'll right click and copy, and down here, right click and paste. And we'll right click and rename this file. We'll remove the copy at the end, and at the front, we'll change this to 08 and press enter. Now let's hide these files, and we can close the 07 file for now. And let's open this in Live Server by right-clicking and open with Live Server. Let's also open the console on this page. So right-click, inspect, and the console. All right, now let's go into our code and add a score to our game. So remember, when writing JavaScript, a good strategy is to think about what steps we need to do. This is called an algorithm, and then convert those steps into code. So we already had an algorithm for the rock, paper, scissors game. Let's update this algorithm to include the score. So first, the computer randomly selects a move. This step will stay the same. Number 2, we're going to compare the moves to get the result. This step will also be the same. But now we're going to add an extra step. After getting the result, we're going to update a score. And finally, we'll display the result and the score in a pop-up. Now let's convert these updated steps or this algorithm into code. The first thing we need to change is we added a third step. We're going to save and update a score. So first, we need somewhere to save our score. So one place we can save it is inside a variable. Let's go to our script element, and at the top, we're going to create a variable for our score using const score and make it equal to an object. And inside this object, we're going to have the property wins So this will keep track of how many wins that we have. We'll type colon and the number 0 because the score starts at 0, and then a comma, and then another property, losses. This will be how many losses we have, and then colon and 0, and then another comma, and ties, colon and 0. So we use an object here because these values are related to each other. You could use separate variables, but we're using an object for convenience. Another thing you'll notice is that we're creating this variable outside of a function and outside of a scope. And that's because every time we make a move, we need to update the score from last time. So in order to save the score from last time, we need to keep it outside the function. If the score was inside the function would create a new score every time, which is not what we want. So in this situation, in order to save a score from last time, we're going to keep this variable outside. Now, every time we play the game, after we calculate the result, we're going to update the score. So let's scroll down to where we calculate the result, which is here. And then below it, we're going to type some new lines and type the code for updating the score. So we can do that with an if statement. So we'll type if, brackets, and curly brackets. And inside the condition, we're going to check if the result is a win. If it is a win, we're going to update the wins property and increase it by 1. So down here, if the result is equal to the string you win, and make sure that this string matches the string up here, inside the curly brackets, we're going to update score.wins, and we'll make it equal to itself plus 1. So this is how we increase the wins property in the score object by 1. Now remember from the variables lesson that we have a shortcut for increasing something by 1. And that shortcut is plus equals 1. Next, let's add another branch to this if statement for the other two results. So else if, brackets and curly brackets, and in the second condition, we're going to check if result is equal to the string you lose. And make sure this string matches the string up here. So if the result is you lose, we're going to update score.losses property and increase it by 1. So plus equals 1. And finally, we'll check if the result is a tie. Else if, brackets and curly brackets, result equals to the string tie. And here we'll update score.ties plus equals 1. So we converted this step in the algorithm to code. The score starts at 0, and every time we play the game, after we calculate the result, we're going to update the score using this code. Now let's convert the last step into code. We're going to display the result and the score in the pop-up at the end. So let's actually go back to the supersimple.dev project, and we'll see what the pop-up looks like. We'll click one of these buttons, and in this pop-up, on the second line, we display the score. So in our code, this is the code that displays that pop-up. So how do we add a second line to the pop-up? Remember that template strings have another special feature called multi-line strings. So we can type at the end of this template string and press enter to add another line to this string. So here we can type wins colon, and we're going to insert a value using dollar open curly bracket, close curly bracket. And here we're going to insert the number of wins that we have, which is score.wins. So we'll type score.wins. Next, we're going to show the number of losses that we have. So after this, let's type a comma and losses, colon, and insert another value. Here we'll insert score.losses. And finally, we'll type a comma and we'll display ties, colon, and insert a value, score.ties. And this will display our score in the pop-up. So let's save this and give it a try. We'll click OK, and then go back to our tab and play the game. So now on the second line, we will display the score. One small issue here is that we have a lot of spaces on the second line. So these spaces correspond to the spaces here. When we use multi-line strings, these extra spaces will show up in the pop-up. So to remove these spaces, we can just remove them in the code, like this. Now if we save, press OK, and play the game, it will show our score on the second line without those extra spaces at the front. Let's press OK. We're going to add one more feature to this project. If we go back to supersimple.dev, we have a reset score button, which will reset the score back to 0 when we click it. Let's add this button in our project. So we'll scroll up, and inside the HTML, we'll add a button with the code less than button greater than. And inside the button, we'll have the text reset score. And now when we click this button, we'll run some code using the onClick attribute equals double quotes. And then in here, we're going to write some code to reset this score back to 0. So one way we can do it is, because this score is an object, we can use dot notation to change everything back to 0. So we can type score.wins and make it equal to 0. We'll also type score.losses and make it equal to 0. And finally, score.ties and make it equal to 0. Now let's save and go back to our tab and play the game a few times to get a score. Let's press OK and press reset score, and then play the game again. And you'll notice that the score started from 0 again. So that's how we create the reset score button. We just set all of these properties back to 0. And that's it. That's how we add a score feature to our rock, paper, scissors project, using an object to save the score. Let's press OK. And we're going to learn more details about objects. Let's go back to objects.html. And we'll open the tab for this file. And let's also comment out the previous code using /* and at the bottom, */ and save. Now let's scroll to the bottom and we'll do some setup. So first, let's create a variable with const. We'll name it product2 and make it equal to another object. Inside this object, we'll have the property name, colon, and the string shirt. And we're going to console.log this object. So console.log product2 and save. So the next detail we're going to learn about objects is another way to access the values inside. We previously learned the dot notation to do this. For example, console.log product2.name. This will access the value associated with the name property. In JavaScript, we have another way of accessing values inside objects, which is using square brackets. So we'll create a new line and type console.log product2, and this time we'll type square brackets. And then inside the square brackets, we'll have a string with name. So this is called bracket notation. And this does the same thing as dot notation up here. It gets the value associated with the name property. If we save, these two lines of code both access the string shirt, which we see here. So when do we use the bracket notation instead of the dot notation? Bracket notation lets us use properties that normally don't work with dot notation. For example, at the bottom, we can type console.log product2 and then use a dot and try to access a property called delivery-time. If we save, this property will give us an error. And that's because JavaScript thinks that this dash is a minus sign and it's trying to do math. So in order to use a property like this, we have to use bracket notation. So we're going to replace the dot with square brackets and turn this into a string. Now, if we save, it no longer gives us an error. And because delivery time does not exist in the object, we get the value undefined. So using bracket notation, we can also add values to the object when we create it. So here, we can add a comma, and we'll add another property using bracket notation and a string delivery-time and a colon and then a value like the string 1 day. If we save, this lets us add a delivery-time property to this object. So as you can see, bracket notation lets us use properties that normally don't work with dot notation. Another feature of bracket notation is that between the brackets, we don't just have to use a string. We can use a variable, a calculation, or anything that results in a value. So you might be wondering, which one should we use? Dot notation or bracket notation? We usually use dot notation by default because it's shorter and easier to read. But if we need to use properties that don't work with dot notation, then we use bracket notation. Now a shortcut here is when we create the object, if we only have a string between the brackets are actually optional. So we can just type this. If we save, the code will still work. Okay, the next detail we're going to learn is that inside an object, we can save any type of value. So this includes numbers, strings, booleans, as well as other objects. Because remember, objects themselves are also values. For example, we can type a comma and add a property called rating, colon, and then an object, open curly bracket, close curly bracket. And inside this inner object, we can add more properties like stars, colon, 4.5. This is how many stars a product has, and then a comma, and a property called count, colon, 87. This is how many ratings a product has. So this is called a nested object, or an object inside an object. We can use nested objects to make our values more organized. So inside the product, the number of stars that it has and the number of ratings that it has are both related to a rating. So it makes sense to group them together further inside the product. Now, to access values inside the inner object, we just use the dot notation or bracket notation multiple times. For example, at the bottom, we can type console.log product 2 dot rating. This will get the value associated with rating, and this is an object. So we can use the dot notation again, count. So this will get the count inside the rating object, which is this value right here. So if we save, it will display 87. And finally, another type of value we can put in an object is a function. So in this object, let's type comma and another property, fun, colon, and we're going to create a function here. So let's type function, and we'll name the function function1 brackets and curly brackets. And then inside the function, we're going to have some JavaScript code like usual. So console.log the string function inside object. This saves a function inside the object. And this works because a function is actually just another type of value in JavaScript. But we'll learn more about this feature of functions later in this course. For now, just know that functions are also values, and we can save them in an object. To access this function, we can use the dot or bracket notation as usual. So at the bottom, we can type the object product 2 and then a dot and then the property fun. So this will access the value associated with the fun property, which is a function. And because this is a function, we can call it as usual using brackets. If we save, this will run the function here, and it will display function inside object into the console. So when we save functions inside an object, this is called a method. And we've actually been using methods this whole time. Console.log is actually a method. Console is an object provided by JavaScript, and log is a function that is saved inside the console object. If we go to the bottom and type console.log type of console, and save, this will confirm that console is just an object. And if we change this to console.log and save, this will show us that console.log is a function. So log is a function that is saved inside the console object. So we call this a method. Another example of a method is math.random, which we used in the rock, paper, scissors project. Math is also an object provided by JavaScript, and random is a function saved inside the math object. So we call math.random a method as well. So we've actually been using objects and methods all throughout this course. And now we understand all the code that we've been using so far. Next, we're going to learn about built-in objects. So the console object and the math object are known as built-in objects because they are built in to the language. They are provided by the language. We're going to learn two more built-in objects called JSON and local storage. And we will use these objects to improve our rock, paper, scissors project. Let's start with the JSON built-in object. This object helps us work with something called JSON. JSON stands for JavaScript Object Notation. The easiest way to understand JSON is it's basically a syntax. It's a similar syntax to a JavaScript object, but it has less features. For example, the code on the left uses JavaScript object syntax, and the code on the right uses JSON syntax. So one difference is that all properties and strings must use double quotes in JSON. JSON does not support single quotes. Another difference is that JSON does not support functions. So as you can see, JSON is basically a syntax that's similar to a JavaScript object syntax, but with less features. So why would we use JSON syntax instead of a JavaScript object syntax? A JavaScript object only makes sense in JavaScript. On the other hand, JSON syntax can be understood by almost every programming language. So JSON syntax is more universal. For this reason, we use JSON when we send data between two computers that might use different programming languages. We'll learn how to do this later in the course. We also use JSON when we store data. We'll learn how to store data in this lesson. Now that we understand what JSON is, let's learn about the built-in JSON object. The JSON object helps us convert a JavaScript object to JSON. For example, let's convert our object product2 to JSON. So we'll create some new lines and we'll type the JSON object dot stringify and open bracket, close bracket. So stringify is a method of the JSON object. So it's a function that is saved inside this object. And we can call this function using brackets. Between the brackets, we can give it a JavaScript object we want to convert, like product2. This will convert the object into JSON. So now let's console.log the result and save. And in the console, it will display the product using JSON syntax. If we scroll up, you'll notice that the function that we saved in the object is not inside the JSON, and that's because JSON does not support functions. So one thing to note about stringify is that it actually results in a string. So at the front, if we type of and save, it will tell us that the result that it gives is actually a string. So if we remove this and save, now this JSON string is ready to be sent to another computer or to be saved in storage. Next, let's learn how to convert the other way, from a JSON back to a JavaScript object. To do that, we'll use another method in the built-in JSON object called json.parse. At the end, we'll type json.parse and brackets. And between the brackets, we can put a JSON string that we want to convert. So we actually have a JSON string up here. So let's just make a copy of this. We'll select it, right-click, copy, and let's create an extra variable to make it more clear. Const JSON string, and make it equal to right-click and paste. And now let's convert this JSON string back into an object by putting it into parse. And finally, we'll console.log this result. So console.log and save. And json.parse will turn the JSON string back into a JavaScript object. So that's the built-in JSON object. It helps us convert back and forth between a JavaScript object and JSON. Now we're going to learn the next built-in object called local storage. Local storage is used to save values more permanently. So far, we've been saving our values in variables. However, variables are temporary. They only exist on the current page. If we refresh the page or close the page, all the variables are deleted. For example, if we go back to our rock, paper, scissors project and open the tab for this project, and we play a few games and play it again, so we have 2 games. If we refresh the page, notice the score starts from 0 again. And that's because when we refresh the page, all of these variables are deleted and the score gets reset back to 0. However, if we press OK and go to supersimple.dev and we refresh the page and we play the game, notice that the score doesn't start from 0. It starts from the previous score even though we refreshed the page. And that's because this project saves the score in local storage. And local storage doesn't get deleted when we refresh the page. Now let's learn how to use local storage in our project. Let's press OK. And we'll go back to our code. And we'll scroll down to where we update the score. So here, after we update the score, we're going to save it in local storage. But first, let's learn how local storage works. So at the bottom here, we're going to type the local capital S storage object. To save a value inside local storage, it has a method called setItem. So we can type dot set capital I item and brackets, because this is a method or a function saved inside the object. And we're going to give 2 strings to this method. The first string is a name. This is how we're going to access the value that we save later. So let's use the string message as the name. And we'll type a comma, and then we'll type the value that we want to save into local storage. So local storage only supports strings. So let's save the string hello inside local storage. If we save and then go back to our tab and play the game, it will run all this code and save the string into local storage. Now let's learn how to get this string out of local storage. We'll press OK, and we'll scroll to the top. And when we first load the page, we're going to get that value out of local storage by typing local capital S storage dot get item this time, and brackets. So the get item method gets a value out of local storage, and we're going to give it one string. So this string is the name that we used earlier, which was message. So we'll type the string message. Now let's console.log this result. So console.log and a bracket at the end, and save. It will get the value that we saved earlier out of local storage. So we saved the string hello, and that's exactly what gets displayed in the console. So using local storage, we were able to get the value that we saved earlier, even though we refreshed the page. Now let's save our score into local storage, so it doesn't get reset when we refresh the page. So let's scroll to the bottom, and instead of using the name message, we're going to use the name score to save our score. And instead of the string hello, we're going to save the score object. Now, one problem here is that local storage only supports strings. So we need to convert our object into a string. And we actually learned how to do this earlier using json.stringify. So at the front, we can type json.stringify and then brackets around the score. And this will convert the JavaScript object score into a JSON string. And then it's ready to be saved in local storage. So if we save this and then play the game, it will run this code and save our score into local storage. Now let's press OK, and then scroll up to the top. And now instead of getting the message, we're going to get the score out of local storage. If we save, now when we load the page, we're able to get the score that we saved from last time as a JSON string. The last step is, instead of resetting the score to 0 every time, we're just going to use the score from local storage. Before we do that, remember that this is just a string, so we need to convert this back to an object. We also learned how to do this earlier using json.parse. So at the front, we can type json.parse and then open bracket, and at the end, a close bracket, and it will convert this back to an object. If we save, it will convert the score from a JSON string back to an object. So now we can use it up here. So instead of doing this, we'll remove it and replace it with this code. So right click, cut, and then here, right click and paste. And we'll remove console.log and save. So now when we load the page, it will load the score from local storage. If we play the game, notice that the score doesn't start from 0. It starts from the score that we had last time. Let's review what we did step by step. First, when we update our score in this code, after we update the score, we're going to save it in local storage using local storage.setItem. Now, local storage only supports strings, so we have to convert our score object into a JSON string using json.stringify. And then, after we've saved this into local storage, when we load the page up here, we're going to load the score that we just saved from local storage using local storage.getItem. And the score was saved as a JSON string, so we need to convert it back into an object using json.parse. So that's how we use the JSON object and the local storage object to save our score more permanently. Let's press OK. And the last feature we're going to add is when we click the Reset Score button, we also need to remove the score from local storage. Otherwise, if we press Reset Score and refresh, and then play the game, it would just grab the old score from local storage. So Reset Score doesn't really work here. Let's press OK and fix this issue. So here in the Reset Score button, at the end, we're going to remove the score from local storage. So we'll type local storage and then a method called .remove item and brackets. And between the brackets, we're going to tell local storage which value we want to remove. So we're going to remove the score. So we'll type the string score. If we save and we click the reset button, and then we refresh the page and try to play the game again, unfortunately, it now gives us an error. So what is happening here? So remember that we removed the score from local storage. So now when we load the page, this actually doesn't exist. When something doesn't exist in local storage, it's going to give us a value called null. And at the bottom, if we try to access any property on null, it will give us an error. So that's what we see here. So how do we solve this problem? If we scroll up, one way to solve this problem is that if there is no score in local storage, we're going to give it a default value. Let's look at how we can do that. So after this line, we're going to check if the score is null. We can do that using an if statement. If, brackets and curly brackets, and we'll check if score is equal to null. And if it is equal to null, we're going to give this a default score. So inside the curly brackets, we'll just make the score equal to the default object we had earlier, which was wins 0 and then losses 0 and ties 0. And remember, if we need to reassign a variable, we have to change it from const to let. If we save, the score will be null because we removed it earlier, and now this will give it a default score. So everything should work as before. If we play the game, you'll notice that the score starts from 0 or this default score, and everything is working again. So that's how we create the score feature in the Rock, Paper, Scissors project, as well as the reset score feature. Next, we're going to use some shortcuts to simplify our code. So these shortcuts are things that we learned in the Booleans lesson. So remember that null is a falsy value. that means it will behave just like false. So a shortcut we can use here is, instead of checking if the score is equal to null, we can also remove this and check if not score. So not score does the same thing as checking if it's null. If the score is null, not score will flip it into true. So both of these will return true. If the score exists, it's an object, then both of these will return false. So instead of checking if a value is equal to null, we can just use the not operator as a shortcut. Now, also from the Booleans lesson, we have an even shorter shortcut for doing this. So notice here that this code basically sets a default value if the score doesn't exist. In the Booleans lesson, we learned a technique called the default operator, which is exactly what we need here. So on this line, we can remove the semicolon and type or, and then a default value. So we want our default value to be this object. So let's select it and then right click, copy, and then here, right click and paste. And I'll select these lines and press Shift Tab to remove and indent. And I'll add a semicolon back at the end. So the way that the default operator works is that if the left side is truthy, so in this case we have a score, it will use the left side. If the left side is falsy, or in this case the score is null, then we will use the right side as a default value. So this does the same thing as this code below, but it's just a shortcut. So now let's comment out this code using /star, and at the bottom /. So we'll leave it here just for reference, and then save. And if we click reset score again and refresh and play the game, it will still work. So this is a perfect situation to use the default operator to simplify our code. So let's press OK. And that's all we're going to do for this project in this lesson. Now let's move on and learn more details about objects. The first thing we'll learn is the value null. So null is one of the falsy values in JavaScript. It's similar to the value undefined. They both represent that something doesn't have a value. So what's the difference between null and undefined? We use null when we intentionally want something to be empty. For example, in the previous lesson, we learned that if a function has parameters, we can give the parameter a default value. If the parameter is undefined, it will use the default value. However, if we set this parameter to null, it will not use the default value, and it will just use null. So null means we intentionally want something to be empty. In most cases though, null and undefined work the same way. Okay, so the next detail about objects we're going to learn is called auto boxing. Let's go back to objects.html and open the tab for this file. And let's also comment out the previous code so our console doesn't get too messy. So /* and at the bottom */ and save. So let's scroll down. We learned in this lesson that objects can have properties and methods. So you might be surprised to learn that other values also have properties and methods. For example, at the bottom, we're going to type console.log the string hello, and then the dot notation and a property called length. So strings can also have properties. The length property tells us how many characters or letters are in this string. So hello has 5 letters. So if we save, the length property will be 5. Here's another example. We'll type console.log the string hello, and then the dot notation and a method this time. To capital U upper, capital C case, and brackets. So this string also has a method called toUpperCase. And this method gives us a copy of the string with all letters capitalized or in uppercase. If we save, it will give us hello in capital letters. So as you can see, simple values like strings can also have properties and methods. So now you might be wondering, these are strings, not objects. How can strings have properties and methods? The answer is that JavaScript has a special feature called auto boxing. JavaScript automatically wraps this string in a special object first, and this object has the property length and the method toUpperCase. So this is done automatically. We don't see the special object that's wrapped around this string. So this feature is called auto boxing because JavaScript automatically wraps the string in an object like a box. So auto boxing also works with other types of values like numbers and booleans. The only thing is that auto boxing does not work with null and undefined. It would just give us an error. The last detail we're going to learn about objects is a really important detail, and that is objects are references. To demonstrate, let's create a new variable with an object. So const object1 and make it equal to an object. Inside this object, let's have a property message colon and the string hello. So you might think that when we create an object like this, we create a value that has other values inside and we save the whole thing in a variable. However, this actually works a little differently. When we create this object, the actual value is created somewhere in the computer's memory. And this variable actually just gets a reference that points to that location in the computer's memory. This is like a shortcut on your computer. A shortcut points to where the actual file or folder is. So there's no way to actually see this reference, but just know that this is a reference, and the object is somewhere else in the computer's memory. So the reason it works this way is to make the language more efficient. For example, below this line, we can create a variable, const, and call it object2, and make it equal to object1. So this code doesn't actually make a copy of the object. It just makes a copy of the reference that points to the object. So this makes the language more efficient because if we had a really big object here, it's not good to copy the entire object over and over again. Instead, JavaScript just copies the reference, which is much faster. This is called copy by reference. Now that we learned that objects are actually references, let's learn some interesting behaviors of references. So at the bottom here, we're going to change the property message in this object. we can do that by typing the object1 dot message property and make it equal to something else, like the string good job. And now if we console.log object1 and save, notice that we were able to change the message property even though we created object1 with const. And that's because this variable just contains a reference that points to the object. So const prevents us from changing the reference in the variable, but it doesn't prevent us from reaching into the reference and changing the object that it's pointing to. So just be careful when you're working with objects. Even though we use const, we can still change the values inside the object. Another interesting behavior is that on this line, we're not actually copying the object into this variable. We're copying the reference. So object2 actually has the same reference as object1. They actually point to the same object in the computer's memory. So at the bottom, if we type console.log object2 and save, you'll notice that for object2, the message property was also changed, even though we only changed object1. The last interesting behavior is that we can't compare objects directly. For example, let's go to the bottom and we'll create a new object using const object3, and we'll make it equal to an object. And then inside, we're going to have the same values as object1. So we'll have the property message, and the value is the string good job. So now let's try comparing object3 to object1. So here, we'll type console.log and check if object3 is equal to object1. If we save, it will tell us that these two objects are not equal to each other, even though they have the same values inside. And that's because, remember, objects are references. So object3 also contains a reference. And this code compares the references and not the values inside the object. So because object3 is a different reference than object1, that's why this code results in false. If we did console.log and we check if object2 is equal to object1, object2 has the same reference as object1. It points to the same object in the computer's memory. So if we save, this will tell us that these two variables have the same reference. So just remember that when you're comparing two variables that contain objects, you're actually comparing the references, not the values inside. If we want to compare the values inside, we would do that manually by checking the message property against this message property. So don't worry, object references are a little confusing at first, but the more you work with it, the more you just get used to it. The last thing we're going to learn in this lesson are some shortcuts for objects. So first, let's make a copy of object3. We'll select the code and right-click, copy, and then at the bottom, we'll scroll down and right-click and paste. And let's rename this variable to object4. So now let's say that we want to get the message property out of this object. We can do that by typing object 4 dot message. And now let's also say that we want to save this in a variable, also called message. So at the front, we'll type const message and make it equal to this value. So now, if the variable name and the property name are the same, we actually have a shortcut for this. To use a shortcut, we're going to type const and curly brackets message and make it equal to object 4. So this shortcut is called destructuring. This will take the message property out of object 4 and save it in a variable called message. So this line of code does the same thing as the code above. So let's comment out this line using // and we'll just keep it for reference. So at the bottom, if we type console.log message and save, it will display good job. So the destructuring shortcut took the property out of the object and saved it in this message variable. Next, we can use this destructuring shortcut for multiple properties. For example, let's add another property to this object using comma, and we'll add a price property $7.99. And now we can take the price property out of this object by typing after message a comma and price. So this will take the price property out of the object and save it in a variable called price. If we console.log the price and save, it will display $7.99. So that's the destructuring shortcut. It's an easier way to take properties out of an object. The next shortcut we're going to learn is called the shorthand property. So at the bottom, let's create some new lines. And let's say we want to create a new object. So we'll type const, and let's name this object 5. And we'll make it equal to an object. And inside this object, let's say we want to create a message property. So we'll type message : and for the value, let's type the variable message. So what this does is that it takes whatever is inside the message variable and substitutes it into this code. So at the bottom, if we console.log object 5 and save, this object will have a property called message, and the value is whatever is inside the message variable, which is good job. So now we actually have a shortcut for this code. If the property and the variable name are the same, we can actually just type it out once, like message. So this code does the same thing as message : message. And this shortcut is called the shorthand property. So if we comment out this line using // and save, you can see that this shortcut creates the same object that we had before. The last shortcut we're going to learn is called the shorthand method. So at the end, let's create a new property, comma, and let's name it method, : and we'll save a function in this property. So we'll type function, and let's name it function1 brackets and curly brackets. And inside this function, let's console.log method. And now here at the bottom, let's run this function by typing object5.method. So this will access this function, and we'll run it by typing brackets. If we save, this will run the code in the function and display method in the console. So we actually have a shortcut for writing this. So at the bottom, we can type method again and just type brackets and curly brackets. Console.log string method. So this code does the same thing as the code above. So these brackets will create a function just like here. So this function name is actually not needed. So if we comment out these lines of code and save, it will still display method in the console because this is a shortcut for these lines of code. So this shortcut is called the shorthand method syntax. And that's the end of this lesson. In this lesson, we learned another type of value called objects. Objects group related values together. We added a score to our rock, paper, scissors game. We learned about built-in objects and used the JSON and local storage objects to save our score more permanently. We learned more details about objects like null, autoboxing, and references. And we learned some useful shortcuts like destructuring, shorthand properties, and shorthand methods. Here are some exercises to help you practice working with objects. In this lesson, we're going to learn one of the most important features of JavaScript called the Document Object Model, or the DOM. And we're going to use the DOM to improve our rock, paper, scissors project. So first, we'll create a new file for this lesson. Let's go to our code editor and click this icon to show our files, and then click this icon to create a new file. And we'll name this file 09-dom.html and press enter. Next, let's copy objects.html into dom.html. So we'll click here to open the file and then click inside and then type Control A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide these files and we'll prepare this file for this lesson. So let's scroll to the top and we'll change the title to DOM. And let's delete all the JavaScript code from the previous lesson. Now let's save this file and we'll open it in the browser by right-clicking, Open with Live Server. And let's also open the console on this page. We'll right-click, click Inspect, and then click the console. And now we can close the previous tabs as well as the previous code for now. And for this lesson, we're going to do an extra step in the setup. Inside the body, we're going to create a button. So here, let's type the code less than button greater than. And inside the button, we'll have the text hello. Now let's save. And we should have a button on the page. And now we're ready to learn the document object model, or the DOM. In the previous lesson, we learned about objects, which group multiple values together. We also learned about built-in objects, which are objects that are provided by JavaScript. Some examples of built-in objects are console, math, JSON, and local storage. The DOM is another built-in object called the document object. So let's go to our script element, and we're going to type document. So this is a built-in object provided by JavaScript. And we've actually seen this document object before. In the first lesson, one of the first pieces of code that we learned was document dot body dot inner capital HTML equals the string hello and semicolon. So this code removes everything on the page and replaces it with the text hello. If we save, it will remove the button and just put hello. And now that we learned objects in the previous lesson, we can fully understand this syntax. Document here is a built-in object, and this is the dot notation. This means we're accessing a property of the document object called body. Now, body is also an object, so we can use the dot notation again to access a property of the body object called inner HTML. And finally, we use an equal sign to change the inner HTML property to the string hello. But as you can see, there's something very special about the inner HTML property. When we change this property, it also changes the web page. So this document object and the web page are linked together. Let's do another example. We'll go to the end here and press enter, and we'll type the document object again, and we'll use the dot notation again. And this time, let's access the property title. And we'll change the title property using an equal sign, and we'll change it to the string good job. If we save, changing the title property will also change the title at the top of the tabs here. So now this says good job. Again, as you can see, the document object is linked to the web page. So from these examples, it shows us that the document object represents or models the web page. And that's why we call this feature the document object model, or the DOM. Now that we know what the DOM means, let's learn the syntax rules for the DOM. So the DOM is just this built-in document object. And this object works the same way as any other object. It contains properties like body and title that we can access using the dot notation. Now, the special thing about the document object is that it is linked to the web page. That means if we change certain properties in this object, it will also change the web page. Now, in addition to properties, the document object also has methods we can use, and we'll learn about them later in this lesson. Now that we understand the syntax of the document object, let's learn about the properties and methods we can use. First, let's comment out this previous code using /* // and we'll create some new lines at the top. So the first property we're going to learn is called document.title. So this property will give us the title at the top of the tabs here. So if we console.log this property, console.log, and save, this will give us the text at the top, which is DOM, and that's what gets displayed in the console. If we change the document.title property, it will change the text at the top of the tab. So here, if we type document.title and make it equal to the string changed and save, now the title at the top of the tab will be changed. So as you can see, the title property is linked to the title at the top of the tab. We can use it to get the title, and we can also use it to change the title. Next, we're going to learn another property called document.body. So let's go into our code, and let's type document.body. Now, document.body is a very special property. So this will literally get this body HTML element and put it inside our JavaScript. So let's actually console.log this to see how it works. Console.log, open bracket, and then close bracket, and save. And inside the console, it will tell us that document.body is the body HTML element. And if I hover over this, it will tell us that it is exactly the body on our page. If I expand this, you can see that this code is exactly the code that we have here. And this shows us one of the most important features of JavaScript. We can have HTML elements inside JavaScript. The document object, or the DOM, combines JavaScript and HTML together, and it gives JavaScript control of the web page. Okay, so now that we have an HTML element inside our JavaScript, what can we do with it? A really important thing to know is that when an HTML element is inside our JavaScript like this, the HTML element is converted into a JavaScript object. So for example, if we do console.log type of document.body and save, it will tell us that the body HTML element is just an object when it's inside JavaScript. So just like any other object, this has properties and methods we can use. So one useful property of the body element is inner HTML, which we saw earlier. So down here, let's type document dot body dot inner capital HTML. So the inner HTML property controls all the HTML inside the body. That's why it's called inner HTML. So if we access this property, it will give us all the HTML inside the body. So let's console.log to confirm. Console.log and save. And inner HTML will give us all of this HTML inside the body element. And if we change the inner HTML property, it will change the HTML inside the body element. So let's create a new line and we'll type document dot body dot inner capital HTML, and we'll change it to the string changed. So this will replace all of the HTML inside the body with the text changed. If we save, that's exactly what it does. And we can actually confirm this by going into the Elements tab. So this tab is for HTML and CSS. We can find the body element, expand it, and you can see all of the HTML that we had before was replaced with changed. And don't worry about this part. This part is just added by live server after. So this shows that inner HTML gives us control of all the HTML inside the body. We can get this HTML and we can also change this HTML. Now, another feature of inner HTML is that we can replace this HTML with new HTML code, not just text. So for example, instead of just text, we can replace it with the code less than, button, greater than, and also less than / button, greater than. So this is HTML code for creating a button. And inside the button, let's put the text, good job. And now this code will replace all the HTML inside the body with this new HTML. If we save, it removes all the previous HTML, and this new HTML creates this button. So using this inner HTML property, JavaScript can replace the HTML inside the body to whatever we want. We have full control of the web page. All right, now we're going to learn a method of the document object that we can use. As a reminder, a method is a function that is saved inside an object. So we're going to learn a very important method called document.querySelector. We just learned that document.body lets us get the body element and put it inside our JavaScript. Document.querySelector lets us get any element from the page and put it inside our JavaScript. Let's give it a try. So first, we'll comment out the previous code using /* and */. Let's create some new lines at the top. And let's type document.query capital S selector and brackets. So document.querySelector lets us get any element from the page and put it inside our JavaScript. Between these brackets, we're going to put a string. This string tells JavaScript which HTML element to get from the page. So if we type button, this will get the first button element from the page and put it inside our JavaScript. So let's console.log this to confirm. Console.log, close bracket, and save. And let's go back to our console. Now it will tell us that document.querySelector got this button element and put it inside our JavaScript, which you can see in the console. And if I hover over this button element, it will tell us that it is exactly the button on the page. So that's what document.querySelector does. It can get any element from the page and put it inside our JavaScript. This string tells it which element to get. If we type button, it will get the first button element from the page. If we type body, this will now get the first body element from the page. So it will do the same thing as document.body. But for now, let's just change this back to button as an example and save. So remember, when an HTML element is inside JavaScript, it's just a JavaScript object. So this button element is also just an object, and it has properties and methods we can use. Every HTML element actually has a property called inner HTML, which lets us control the HTML inside the element. So for this button element, let's type at the end dot inner HTML, and this will give us the HTML inside the button. If we save, it will give us hello. And again, if we change the inner HTML property, it will change the HTML inside the button. So let's make a copy of this code. We'll select it and right-click copy. And down here, right-click and paste. And let's change the inner HTML property using an equal sign and the string changed. So this will only change the HTML inside the button, which is here, to changed. If we save, you can see that the text inside the button is now changed. A little syntax shortcut I'm going to show you is that for the dot notation, we can actually put it on multiple lines. So we can type document.querySelector and then put dot inner HTML on a separate line to make it easier to read. And make sure to put a tab at the front so that we know it's a continuation of the previous line. Okay, so using document.querySelector, we can get any element from the page, put it inside our JavaScript, and then we can control the HTML inside that element. And this allows us to only change the parts of the page that we need. Next, what if we have two buttons on the page? So let's go up here and we'll create another button using less than button greater than. And we'll have the text second button and save. So now we have two buttons on the page, but document.querySelector will only get the first button on the page. How do we get this second button? The solution is that we're going to add an attribute to this button called the class attribute. So in the opening tag, we're going to type space class equals double quotes. So the class attribute sort of adds a label to this button. So inside the double quotes, we're going to label this button a JS-button. And now that we labeled this button, we can select it using document.querySelector. So at the bottom here, we'll type document.querySelector again, and brackets, and we'll type a string inside. And this time, we're going to start with a dot. When we start with a dot, this means that it's going to look for a class rather than an element name. So we're going to look for the class JS-button. And now document.querySelector will select an element with the class JS-button, which is this element here. So let's confirm this. by console.logging this code and save. And now you will see that this code gives us the second button on the page. So using a class attribute and then starting with a dot in query selector, we can get any specific element from the page and put it in our JavaScript. By the way, when we start with a dot, this is called a class selector. And this is also used in CSS to style elements with a specific class. In fact, anything we use in CSS can also be used in this string. And also, a common practice is to start the class with JS- to make it clear that this class is being used in JavaScript. And again, HTML elements are JavaScript objects. So this second button is also just an object. And remember, objects are values, and we can save them inside a variable. So instead of console.log, let's create a variable using const, and we'll name the variable button capital E element. We usually end the variable name with element or LM to make it clear there's an HTML element inside this variable. And finally, we'll type an equal sign to save this element. And we can remove this extra bracket. And now, if we console.log this variable, console.log button element, and save, it will tell us that the second button was saved inside this variable. So using the DOM, we can get HTML elements from the page, put it inside our JavaScript, and then save it in a variable. So the DOM combines JavaScript and HTML together. It gives JavaScript full control of the web page. All right, now that we learned how to use the DOM, let's do some practical examples. So I've actually prepared some projects that we can do for this lesson. To open these projects, we'll go to our browser and create a new tab at the top. And here we'll type super simple.dev/projects/DOM and press enter. On this page, we'll be working on 3 projects: the YouTube subscribe button, the rock, paper, scissors project we've been working on for the last few lessons, and this Amazon shipping calculator. And you'll notice that these projects modify the web page. So we're going to be using the DOM to create these projects. And in the next lesson, we're going to use CSS to style these projects and make them look nice. And you can preview that by clicking here. So using CSS, we can make the subscribe button look like the actual subscribe button on YouTube. And if we click this link to see the rock, paper, scissors game, you'll see that we'll make it look really nice with these icons. But for this lesson, we're only going to focus on the functionality and not the styling. So let's go back to the projects. We'll click back and click back again until we're at projects/DOM. And we're going to create the functionality for these projects first. So before we start, let's create a new file just for these projects. We'll go to our code editor and click this icon, and then click this icon to create a new file. Let's name this file 09-dom-projects.html and press enter. Now let's copy dom.html into this file. So we'll open it and then click in here and type Control A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's close our files and we'll prepare this file. So let's scroll up and we'll change the title to DOM projects. And let's remove our HTML, but keep the script element. And we'll also remove the JavaScript from before. Finally, let's save this file and we'll open it in the browser by right-clicking, Open with Live Server. And let's also open the console just in case. Right-click, click Inspect, and then click the console. All right, we're ready to start with the projects. Let's go back to supersimple.dev, and we'll start by creating the YouTube subscribe button. Let's actually press refresh to get it back to normal. And when we click this button, it will change to subscribed. First, let's create the HTML elements for this project. We'll go to the body. We'll create some new lines. And let's create the paragraph first. We'll type less than p greater than, and inside the paragraph, we'll have the text YouTube subscribe button. And now let's create the button. So on the next line, we'll type less than button greater than. And inside the button, subscribe. Now let's save and go back to our tab. And now we have the HTML elements that we need. So now let's make this interactive with JavaScript. And remember, we have a process for this. First, we'll figure out what steps we need to do. This is called an algorithm. And then we'll convert these steps into code. So the steps that we need here are when we click this button, if the text is subscribe, we'll change it to subscribed. Otherwise, we'll change it back. Now let's convert these steps into code. Let's go to our button element, and we're going to add an onClick attribute. We'll type space on click equals double quotes, and inside here, we'll write some JavaScript. So first, we need to get the text inside the button. And we learned how to do this earlier. We can use document.querySelector to put this button into our JavaScript and then use inner HTML to get this HTML inside the button. So in our code, let's type document.querySelector, brackets, and a string. And as we learned, we're going to use a class attribute to select this specific button. So in the opening tag, let's add a class attribute, and let's make the class JS-subscribe-button. And then inside document.querySelector, we're going to type a dot to select a class, and we're going to select the class JS-subscribe-button. And now let's console.log this to confirm that we got this button. So at the front, console.log, and save. And now let's click our button. and it will show us that document.querySelector got the button on the page. So now let's save this button in a variable so we can use it later. Instead of console.log, let's type const to create a variable, and we'll name it button element and make it equal to this result. So now that we have the button inside our JavaScript, we're going to check if the text inside the button is subscribe. To check the text, we can use an if statement. So at the bottom here, we're going to type if brackets and curly brackets. And inside this condition, let's get the text inside the button. So we'll type button element dot inner capital HTML. And we're going to check if it's equal to subscribe. So we'll type triple equal the string subscribe. Now, if it is equal to subscribe, inside the curly brackets, we're going to change the text in the button to subscribed. So let's type the code button element dot inner capital HTML, and we'll change it with an equal sign to the string subscribed. And the last step is otherwise, we'll change it back. So we'll add an else to this if statement. Else and curly brackets. And inside, we're going to change the text back to subscribe. So let's type button element dot inner capital HTML and make it equal to the string subscribe and save. Now, before you try out this project, make sure that the text inside the button has no spaces or new lines around it, and it looks like this. And I'll show you why in a second. Let's go to our project and try it out. So when we click this button, it will change to the text subscribed. If we click it again, it will go back to the original text. So that's how we create the subscribe button project using the DOM. So now let's go back into our code, and I'll show you why if we add new lines and some spaces around this text, there's actually going to be some problems. So if we save this code and then go back to our project and click the button again, you'll notice that it no longer changes the text. And that's because now we have a bunch of spaces around this text. And these spaces will show up in inner HTML. And now inner HTML will not equal exactly subscribe. So how do we solve this problem when there are spaces around our text? To solve this, we're going to use a different property of an HTML element. So instead of the inner HTML property, we're going to use the property inner capital T text. So inner text will give us the text inside this element, but without all the spaces around it. So now this will equal exactly subscribe. If we save and go back to our project and click it again, it'll start working again. So that's the inner text property of an HTML element. It gets us the text without the extra spaces. So before we move on to the second project, I'm going to show you how to make our code cleaner. Right now, we're mixing HTML and JavaScript together. So to make our code cleaner and easier to read, we're going to separate the JavaScript code. And to do that, we're going to put this code in a function instead. So inside the script element, let's create a function using function, and we'll name the function subscribe brackets and curly brackets. And inside these curly brackets, we're going to move all of this code. So let's select this code, and we'll right click, cut, and in here, right click and paste. And if we need to fix the formatting, we can select these lines and press tab a few times. And now that we have this function, we're going to go to the onClick attribute, and we're going to call this function. So we'll type the function name, subscribe, and brackets. So this will run all the code inside the function. So it will do the same thing as before, except now our code is cleaner because we grouped all the JavaScript code at the bottom, and we're no longer mixing as much HTML and JavaScript together. Now let's move on to the second project. We'll go back to supersimple.dev, and we're going to work on the rock, paper, scissors project. So let's click this link, and it will show us the next version of this project. So you'll notice a few changes here. The first change is that we're going to show the score on the page instead of in a pop-up. And the second change is that when we click one of these buttons to play the game, it will show us the result and the moves that we picked on the page rather than in a pop-up. Let's create a new file for this rock, paper, scissors game for this lesson. So let's go to our code editor, and we'll click this icon and click this icon to create a new file. And we'll name this 09-rock-paper-scissors.html and press enter. And let's copy the previous rock, paper, scissors, which is here. We'll click here and type Control A or Command A, right click, copy, and here, right click and paste. And let's hide our files. And let's save this file. And we can also close 08 rock, paper, scissors. And finally, we'll open this in the browser by right-clicking, open with live server. Now we're ready to begin the second project. So let's go back to the project at supersimple.dev, and we're going to start by putting the score on the page. So to do this, we're going to need somewhere to put the score. So let's create an HTML element for this. We'll scroll up to our HTML, which is here. And after the scissors button, let's add a paragraph element where we're going to put our score. So less than, P greater than. And let's add a class attribute so we can select this element in our JavaScript. So in the opening tag, we'll type space class equals double quotes JS dash score. Now that we have a class, let's get this element in our JavaScript. So let's just do it down here. So we'll type document dot query selector brackets and a string, and then we're going to type a dot, and we're going to select the class JS dash score. So JS dash score. So this will get the paragraph element from above and put it inside our JavaScript. And now let's put the score inside the element. To do that, we can use inner HTML. Dot inner capital HTML, and we'll make it equal to the score. If we scroll down, we actually create the score down here. So we can actually just copy this string. So we'll select it, right click, copy, and let's scroll up to here. And I'll actually put this on a separate line to make it easier to read. And now here, we're going to type a string using backticks. And inside the string, we're going to right click and paste. So this will put the score that we used to have in our pop-up inside this element. So inside this paragraph. If we save and then go back to our tab, you can see that now it displays the score on the page. Now, before we move on, I want to point something out with HTML. So remember that our reset score button was beside our other buttons, and now it's below them. So what determines if an element appears beside something or below something? So the paragraph element here is known as a block element. A block element will always take up an entire line by itself. So this line already has some buttons, so the paragraph will take up the entire line under the buttons. That's why this text appears under the buttons and not beside them. And also, because a block element like this paragraph takes up this entire line, the next button has to appear below it. So that's why we get this layout here. So this is just a short review of layouts. If you want to learn this in more detail, you can check out my HTML and CSS full course in the video description. All right, the next feature we're going to do is if we play the game, we also want to update the score. Right now, if we play, it doesn't update it on the page. Let's fix this in our JavaScript. So let's go down to where we update the score. So we'll scroll down, which is right here. We update the score and save it in local storage. And after we do this, we're also going to update the score on the page. So we can actually use the same code that we used above, which is here. So let's make a copy of this code, right click, copy, and down here, right click and paste. And I'll add a tab at the front. If we save and then try out our game, we'll click a move, press OK, and now you'll notice the score also updates on the page. So let's go back into our code and do some cleanup. So you notice that this code is the same as the code we had above. And this is a great situation to use a function to reuse this code. So at the bottom here, let's create a function using function, and we'll call it update score element, brackets and curly brackets, and we'll move this code into the function. So we'll select it, right click, copy, and in here, right click and paste. And now instead of writing this code multiple times, we're just going to call the function update score element and brackets. This will run all the code inside the function, so it does the same thing as before, except we can reuse the code. So let's scroll back up. And instead of typing out all this code again, we can just use our function. Update score element and brackets. Now let's save. It will display the score on the page at the start. And when we click a move and click OK, it will update the score on the page. So the last feature we're going to do in relation to the score is when we click the reset score button, we also want to update the score on the page. Right now, if we click it, it doesn't actually update it. So let's go into our code and let's go to the reset button, which is here. And after we reset the score, we're going to call that function again. Update score element and brackets. If we save, and now let's play the game and press OK. So we have a score, and if we click reset score, it will reset everything back to 0. So now we finished the score. Let's go back to Super Simple Dev and play the game. And now we're going to work on this section. We're going to show the result and the moves that we picked on the page. So first, let's create some paragraphs for these as well. We'll go to our HTML, and above the score, let's add a less than p greater than. This is going to be the result. So let's give it a class of JS-result. And let's create another paragraph, less than p greater than. And we'll give this one a class equals JS-moves. Now let's use the DOM to put the result and the moves in these paragraphs. Feel free to pause the video if you want to try it yourself first. So let's scroll down to where we display the result, which is here. So we display it in a pop-up. And instead of a pop-up, we're going to get the paragraph and put this result inside the paragraph. So we'll type document.query selector, brackets, and a string. And we'll type a dot and select the class JS-result. And then dot inner capital HTML. And we'll change this to result. And now let's also display the moves. So we'll type some new lines and document.query selector again, brackets and a string, dot JS-moves, dot inner capital HTML, and make it equal to this text right here. So let's type a template string because we're going to insert our moves inside the string. And we'll type U, and we'll insert the player move, $ curly brackets, player move, and then a dash, and then the computer's move. So $ curly brackets again, and computer move, computer at the end. So now that we're displaying everything on the page, we don't need this pop-up at the end. So we can actually delete this pop-up. All right, now let's save and go back to our tab and play our game. Now it will show the result and the moves that we picked on the page instead of in a pop-up. Let's play it again to make sure it works. And finally, when we click Reset Score, it will reset everything back to 0. And that's it. Now we're displaying everything on the web page using the DOM. Now let's move on to the third and final project. We'll go back to supersimple.dev and we'll click back to go back to our projects. And we're going to create this third project here, which is an Amazon shipping calculator. The way this works is that inside this text box, we're going to type the cost of an order in dollars. If the order is under $40, for example, $25, and we click calculate, it will add $10 of shipping and display the total down here. But if we type a cost that is over $40, like 50, and press calculate, it will be free shipping. So it will display the same total down here. So let's learn how to create this using the DOM. Let's go back to our 09 DOM projects file, and we'll start by creating the HTML elements. So under our subscribe button, let's create this paragraph using less than p greater than Amazon shipping calculator. And next, let's create this text box. So the HTML element for a text box is called input. So we'll type less than input greater than. So the input element is special because it doesn't require a closing tag. This is called a void element. And lastly, let's create the button. So here, we'll create less than button greater than calculate. Now let's save and open the tab for this file, which is right here. And we have the text box, and the button that we need. Now, one other thing we're going to add is that in the final project, if we don't have anything in the text box, we're going to have this gray text. So this is called a placeholder. To add a placeholder to a text box, we're going to use the placeholder attribute. So inside our input element, we're going to type space placeholder equals double quotes. And inside the quotes, we'll put the text we want as the placeholder, which is cost of order, and save. Now, if we go back to our project, we now have a placeholder in our text box that disappears when we start typing. So that's all the HTML that we need. Now let's work on the JavaScript. And again, we'll figure out what steps we need to do. So when we click this button, we're going to get the text inside the text box. If the amount is below $40, we'll add $10 of shipping, and then we'll display the total on the page. Let's convert these steps into code. So we'll go to our button and add an onClick attribute. And inside here, let's also create a function to separate our JavaScript code like we did before. So in the script, we're going to create a function, and let's name it calculate total, brackets and curly brackets. And inside onClick, we're just going to call the function. So calculate total, brackets. The next step is to get the text inside the text box. So first, let's get this input element and put it inside our JavaScript. To do that, we can use document.querySelector again. So we'll add a class to this input so we can select it. Class equals js-cost-input. And then inside our JavaScript, we'll use document.querySelector brackets and a string and a dot and this class js-cost-input. So this code will get the input element and put it inside our JavaScript. Let's confirm by console.logging the result and save. And now when we click the calculate button, it will give us the input element from the page. Let's save this input element in a variable so we can use it later. Instead of console.log, we'll use const and we'll name the variable input element and make it equal to this element and remove the extra bracket. And next, we need to get the text inside the input element. So far in this lesson, we've been using the property inner HTML to do this. However, for input elements, you'll notice that there is no HTML inside. So for input elements, we're going to use a different property called value. So at the bottom here, we're going to type input element dot value. This is how we get the text inside a text box. So let's console.log this to confirm that it works. So we'll console.log and save. And now let's type something in the text box like 50 and click calculate. And input.value will give us the text inside the text box. Let's save this text in a variable so we can use it later. Const, and we'll name the variable cost and make it equal to the text in the text box. The next step is to check if this cost is under $40. If it is, we'll add $10. So down here, let's type if brackets and curly brackets. And inside the condition, we'll check if cost is less than 40. And if it is, inside the curly brackets, we'll do cost equals itself plus $10 of shipping. And remember, when we change a variable, we have to switch from const to let. And finally, we're going to display the total cost on the page. So let's create a paragraph where we can display the cost. So down here, we'll create a paragraph less than p greater than. Let's give it a class js-total-cost. And now inside our JavaScript, let's use document.querySelector brackets and string, and we'll type a dot and the class js-total-cost. And we're going to put the cost inside the paragraph. We can use dot inner capital HTML and make it equal. And let's use a template string. So backticks, and we'll have a dollar, and we're going to insert the cost using dollar and curly brackets, cost. Now let's save and try out this project. So first, we'll type a cost that is over $40, like 50. If we press calculate, we're not going to add $10 of shipping, and we'll display the same total on the page. Now let's try a number under $40, like 25, and press calculate. And this number doesn't look right. It's saying that we have to pay $2,510. So what's going on here? Let's go into our code, and let's use console.log to figure out what's wrong. So first, let's console.log the cost to make sure that we're getting the right number from the text box. So down here, console.log the cost, and save, and then let's type 25 again and press calculate, and it will give us 25. So we're getting the correct text from the text box. Now let's console.log down here to see if the math is working. So we'll type console.log cost and save, and let's try 25 again and calculate. And down here, when we add 10, this is where things go wrong, and it results in 2,510. So it's not doing math properly here. So let's check if cost is a number to make sure that it's doing math. So here, we'll type console.log the type of cost and save. Let's type 25 again and calculate, and aha, it's telling us that the cost is a string. So this is actually not a number, it is a string. That's why it's not doing math. So remember from the strings lesson, when we add a string with a number, JavaScript will automatically convert this number into a string and combine them together. That's why it just combines 25 and 10 here. This is called type coercion. So whenever we get a value from the DOM like this, the value will be a string. So in order to do math, we have to manually convert this string into a number. To do that, JavaScript has a built-in function called number. So before this code, we're going to type capital N number, open bracket, and close bracket. So the number function takes whatever's between the brackets and manually converts it into a number. So now if we save and we type 25 and press calculate, the cost is now a number, and it will do the math properly and give us 35. So remember, whenever we get a value from the DOM, the value will be a string. So if we want to do math with it, we have to manually convert this value into a number first. So now let's remove the console.logs that we used to figure out this problem. And save. Okay, we're going to add one more feature to this project. Let's go back to supersimple.dev, and inside the text box, we're going to type 25 and press enter. So pressing enter will also calculate the total and display it on the page. So let's learn how to create this feature. So if we go back to our code, so far in this course, we've been using the attribute onClick, which runs some JavaScript when we click an element. HTML has another attribute we can use called onKeyDown, which runs JavaScript when we press a key down on our keyboard. So inside the input this time, let's add the attribute onKeyDown equals double quotes, and then inside here, console.log and the string typing. So now every time we type in the input, it will console.log this message. Let's save it and give it a try. We'll go to the tab for this file, and then inside the text box, we'll type some numbers. And you can see that every time we type something, it will run this code and display this message. So that's how we do something when we type in an element. So clicks and keydowns are known as events. OnClick and onKeyDown are known as event listeners. They check for events and runs JavaScript when those events happen. Now, in addition to clicks and keydowns, there are many other events we can listen for in JavaScript. Okay, so now let's figure out what steps we need to do for this project. When we press a key down in the text box, we're going to check if the key is the Enter key. If it is, we'll do the same thing as the Calculate button. So how do we know what key we pressed? Inside onKeyDown, we're actually given a special object called event. So instead of this string, let's remove it and we'll console.log event. So this is an object that's provided to us by JavaScript, and it contains information about the event. Every event listener, including onClick, also gets an event object. If we save and type in this text box, it will show us that event is this object. And inside the object, it has a bunch of information, including the key that we typed. So here, let's use the event object, and we'll get .key and save. So now inside this text box, if we type something, it will tell us the key that we pressed. And if we press enter, it will tell us that the key is enter. So the next step is to check if the key is enter. And we can do that using an if statement. So in our code, we'll type a new line, if brackets and curly brackets, and inside the condition, we'll check if event.key is equal to the string enter. If it is equal to enter, we're going to do the same thing as the calculate button. So we can actually just use this function again. Inside the curly brackets, we'll type calculate total and brackets and save. So now let's go back to our project and type 25 enter, and it will calculate the total and display it on the page. So that's how we create this keyboard feature of this project. Lastly, let's clean up our code and move this into a function like the rest of our code. So inside the script element, let's create a new function using function, and we'll name it handle cost key down brackets and curly brackets. And let's move this code into the function. We'll select it, right click, cut, and in here, right-click, and paste. If we need to fix the formatting, we can select these lines and press Tab. And let's remove this console.log. And now up here, we're going to call this function handle cost key down and brackets. Now, the last thing we have to do is that event does not exist inside this function. So we have to put the event object into the function. And remember, to put a value into a function, we can use a parameter. So between these brackets, we can create a parameter called event. And now to save something inside this parameter, we're going to go up to these brackets and type event. This will take the event object and put it inside the function, where we can use it just like a variable. So now if we save and try out the project, 25, enter. So this still works. And now we finished all 3 projects in this lesson. So in the rest of this lesson, we're going to learn some more details about JavaScript. In the last project, we learned how to manually convert a string into a number using the number function. We can also convert the other way, from a number to a string. So let's go to the top of the script element, and we can type capital S string and brackets. So the built-in string function will convert a value into a string. Between the brackets, we can put a number like 25, and this will convert the number into the string 25. The next detail we're going to learn is a special behavior of strings. So below this line, we can type console.log the string 25 minus 5. So if a string only contains a number and we subtract, multiply, or divide, JavaScript will automatically convert the string into a number. So this gets converted into the number 25 minus 5. And if we save, it will do math and give us 20. So this is another example of type coercion or automatic type conversion. However, it's not recommended to do math with strings like this because adding works differently. For example, on a new line, let's type console.log the string 25 plus 5 and save. This will convert the number into a string and combine them together into 255. So because adding strings works differently, the best practice is always do math using numbers. Don't do math using strings. If we need to, we can manually convert the string into a number using the number function, like we did here. The last thing we're going to learn in this lesson is another built-in object called the window object. So in this lesson, we learned about the document object. The document object represents the web page. The window object represents the browser. So let's go into our script element and try it out. Below this, we'll type window. So this is the window object, and it represents the browser. Because it represents the browser, everything inside the browser is inside the window object. So let's think. What's inside the browser? Well, the web page is inside the browser. So the document object is inside the window object. If we type window.document, this will give us the same document object that we've been using in this lesson. So what else is part of the browser? Well, the console is also part of the browser. So here, if we type window.console, this will give us the same console object we've been using in this course. So we can actually do console.log and the string window and save. And this will do the same thing as console.log. What else is part of the browser? Well, pop-ups are also part of the browser. So if we type window.alert, this will give us the same alert function that we've been using in this course to create pop-ups. However, you might have noticed that we never type window.document or window.console.log. And that's because the window object has a shortcut. We don't have to type window dot at the front. We can just type document or console, and JavaScript will automatically add window dot at the front for us. So window is a built-in object that represents the browser. We don't have to type out window dot ourselves because JavaScript adds it for us automatically, but it's still nice to know how this works behind the scenes. And that's the end of this lesson. In this lesson, we learned about the document object model, or the DOM, which allows JavaScript to fully control the web page. We learned how to use document.querySelector to get elements from the web page and put them inside our JavaScript. We learned how to use inner HTML to modify the HTML inside an element. We worked on 3 projects using the DOM. We learned how to make elements interactive with the keyboard using onKeyDown, and we learned some more details about strings, as well as the window object, which represents the browser. Here are some exercises you can do on your own to practice using the DOM. In this lesson, we're going to add CSS to all of our projects, and we're going to finish our rock, paper, scissors project. CSS is a different language that changes the appearance of our website. It's one of the 3 languages that we use to create websites. So first, let's look at the projects we're going to work on in this lesson. We'll go to our browser and create a new tab at the top. And here, we're going to type super simple.dev/projects/dom-with-css and press enter. So these are the same 3 projects we created in the previous lesson, except this time we're going to add CSS to make these projects look nice. Let's start by creating a copy of the project's HTML file from the previous lesson. We'll go to our code editor and click this icon to show our files. And then here, we're going to select 09-dom-projects. We're going to right click, copy, and down here, right click and paste. And let's rename this file by right clicking, rename. At the end, we're going to remove copy. And at the beginning, we're going to change it to 10 and press enter. Now let's hide our files, and we're going to open 10 DOM projects in the browser by right-clicking, Open with Live Server. Now we can close our previous tabs, as well as the previous code from lesson 9, which is this file and these two. And now we're ready to add CSS to our projects. We'll start with the YouTube subscribe button. Let's go to the tab for our project, and we're going to style this button first. So we reviewed CSS in lesson 4, and one of the ways we can write CSS code is using the style element. So inside the head section, we're going to create an element using less than, style, greater than. So the style element lets us write CSS code inside. So inside here, we're going to write button, open curly bracket, close curly bracket. So the code in front of the brackets is called the CSS selector. This tells the computer which elements we want to style or change the appearance. So button will style all button elements on the page. But in this situation, we only want to style the subscribe button because the calculate button will be styled differently. So to style a specific element, we can use the class attribute. So if we look at our button, currently it already has a class of JS subscribe button. But this class is being used by our JavaScript. A good practice is to add a different class that would be used by CSS. So an element can have multiple classes. We just separate them with a space. So inside this class attribute, we're going to type space and add another class, subscribe dash button. Now this element has two classes, and we're going to use this second class in our CSS. So to style a specific class, we're going to remove button, and we're going to type a dot. So starting with a dot means we're going to style a class rather than an element name. So we'll style the class subscribe dash button, which is this button right here. And now inside these curly brackets, we're going to tell the computer how to style this button. For example, border, colon, none, and semicolon. If we save, this will remove the border from the button. So it no longer has a border like this button. So that's how we style a specific element with CSS. We add a class to the element, and then inside CSS, we start with a dot and the class. And between the curly brackets, the code on the left is called the property. This tells the computer what we want to change. On the right is called the value. This tells the computer what we want to change the property to. We separate the property and value with a colon, and we end the whole thing with a semicolon. So this is also called a property value pair. As a reminder, this is just a review of CSS. If you want to learn CSS in more detail, you can check out my HTML and CSS full course in the video description. So we just added one style to this button. We're going to add more styles so that it looks like our final design. To make this easier, I'm going to rearrange my windows, and I'm going to put the final design at the bottom and then our project at the top. This will make it easier to compare the two designs. Next, to make it look like the final design, we're going to style our element one by one. Let's go back to our code and press enter. And next, let's change the background color to black. To do that, we'll type background dash color colon black and semicolon and save. Now our button has a black background. Let's keep going one by one. We'll change the text color to white next. So in our code, we'll type color colon white and semicolon and save. Now, if you're wondering how I know all these properties, you can usually find them by searching in Google. Just make sure you search for what you are trying to do. Let's keep going one by one. The next thing we'll change is we're going to add spacing on the inside of the button. In CSS, space on the inside of an element is called padding. So we'll create a new line and we'll use the property padding dash top colon 10px and save. So this will add space on the inside of the element called padding at the top of 10px. So the px here means pixels. A pixel is a unit of measurement in computers. Your screen is made up of many small little squares. Each of these squares is called a pixel. So a pixel is the smallest thing that you can have on your screen. Screen sizes are measured in pixels. Images and video sizes are also measured in pixels. And don't worry, the more you work with pixels, the more you'll get used to how big a pixel is. So in this example, 10 pixels is equal to this amount of space, and it looks pretty close to the final design. So let's keep going. We'll add space on the inside of the element at the bottom this time. So we'll create a new line and type padding dash bottom colon 10px again and save. And that adds space at the bottom of the element of 10 pixels. Next, let's increase the space on the left and the right. We'll go into our code and add padding dash left colon 10 pixels and padding dash right colon 10 pixels. Let's save. And it added some extra space on the left and right, but I think our final design has a little more space on the left and right. So let's go back and increase our padding. So instead of 10, let's try 15 on both sides. So we'll save, and now the spacing looks close enough to the final design. So in CSS, it's normal to do some trial and error to get the styling right. Let's keep styling this one by one. Next, we'll make the text thicker or bold. So let's go into our code, and to change the thickness of the text, we'll use the property font dash weight colon bold. Let's save, and that will make our text bold. So we're almost there. Now let's make the corners rounded, like in the final design. We'll go back to our CSS, and the property for making the corners round is called border dash radius, and we'll make it colon 5 pixels. Let's save, and you can see that it made our corners round. So the pixels here tells the computer how round we want the corners to be. The higher the pixels, the more round it will get. So if we change this to 10 pixels and save, it will make the corners even more round. So let's change this to something really big, to make it completely round. We'll change this to 50 pixels and save. And now our button is completely round. The last style we're going to add is in the final design. If we put our mouse over the button, it turns into this hand icon. So we call this a pointer. And we're going to do the same thing in our project. So let's go to our code. And to create that pointer icon, we're going to use the property cursor : pointer. And let's save and put our mouse over the button. And you'll notice it turns into this hand pointer icon. And that's it. Now our subscribe button looks like the final design. Next, let's click the subscribe button. You'll notice that it only changes the text. But if we click the final design, it also changes the background color and the text color. So we're going to learn how to change the CSS when we click a button. Let's go back to our code, and this time we're going to scroll down to our JavaScript, which is here. So we learned in the previous lesson, we can get HTML elements from the page and put them inside our JavaScript. And we also learned that these HTML elements are just JavaScript objects, and they can have properties like inner text and inner HTML. Every element has another property we can use called class list. Class list gives us control of the class attribute. So one solution we can do is when we click the button, we can add a class. And then this class will have different styles. So let's see how we do that in our code. We'll scroll down to the subscribe function. And when we click the button and make the button subscribed, we're also going to add a class. So let's create a new line and we'll type button element dot class capital L list. So class list itself is an object, which means it has properties and methods we can use. One method is called .add, which adds a class to an element. So after this, let's type .add and brackets. And now inside these brackets, we're going to put a string. So this string is a class that we want to add when we click this button. Let's add a class called is-subscribed and save. So now every time we click this button, it will add a class to the button called is-subscribed. Let's give it a try. First, we'll right-click on the page and then click Inspect. And we'll go to the Elements tab. And I'll rearrange my windows so you can see it. And then inside the HTML, pay attention to the class of the button. Now when we click the button, it's going to add an extra class called is-subscribed. So that's what this line of code does. And now that this button has the is-subscribed class, we can style it in our CSS. So let's go back to our code and we'll scroll up to our CSS. And here we'll type dot to style a class, and we'll style the class is-subscribed. Is-subscribed. And curly brackets. And now inside these curly brackets, let's change the background color to gray and the text color to black. Background dash color colon gray, and then color colon black. And make sure to type these styles below the subscribe button styles, so that these styles will override the styles above. Now, if we save and then click our button, it will add the isSubscribed class, and now this button will get our new styles that we added here. So that's one way to change the CSS when we click a button. All right, now I'm gonna move this back to the top. And notice that our background color is different from the final design. The final design uses a much lighter gray. So how do we get this exact color? To do that, we're going to open the Elements tab again. So on this page, we're going to right-click, click Inspect, and then click the Elements tab. And I'll rearrange my windows so we can see it. So in this section, in the Style section, we can see the CSS that the element has. So first, let's actually find this button, which is right here, and we'll click it. And here, it will show us the CSS that this button has. And it will show us the background color that we should use. So let's make a copy of this color and put it into our code. Right-click, copy, and here we'll remove it and right-click and paste. Now let's save and go back to our project and try it out. And now we get the exact same color as the final design. So by the way, this color is known as an RGB value. RGB means red, green, and blue. And computers can create any color using a combination of red, green, and blue. So the first number here is how much red we want in our color. The second number is how much green we want. And the third number is how much blue we want. Each number goes from 0 to 255. 0 means less color and darker. 255 means more color and lighter. So this color here uses 240 for all of the colors. So it's close to 255 and will give us a very light gray color that you see here. Next, if we go back to the final design and we click our button again, it will change back to the original style. So we're going to create this feature in our project as well. So one way to do this is when we click the button again, we can remove this class. So let's scroll down to the bottom to the subscribe function. And when we click the button and we change it back to subscribe, we can remove this class. To do that, ClassList has another method we can use called remove. So let's create a new line and we'll type button element dot class capital L list dot remove and brackets. So this does the opposite of dot add. It will remove a class from this element. So inside the brackets, we'll type a string and the class we want to remove, which is is-subscribed, and save. Now let's try out our project. We'll click the button. It will get the class isSubscribed and get the extra styles. And now when we click the button again, it will remove the class and it will remove the extra styles. So notice here that when we add a class, we just type the class name. We don't type a dot and the class name like we did for query selector. Typing a dot only makes sense in query selector. Next, we're going to style the text on the page. Let's scroll up to our CSS. And one thing we can do is to style all the paragraph elements on the page using this code, P and curly brackets. However, we're going to use a better solution. Instead of styling all the paragraphs, we're just going to style the body element. When we change the text in the body element, it will change the text in the entire page. So inside these curly brackets, let's change the text here. So we're going to use a different style of text. This is called a font. To change the font, we're going to use this property, font-family, colon, and we'll change it to Arial, which is what I used in the final design. So let's save, and this will style all the text inside the body and change the font to Arial. And a good practice is to write any styles for the body at the top. So if we need to, we can override it later. So let's move these to the top. We'll right click, cut, and then up here, create some new lines, and right click and paste. And we're going to add one more style before moving on. Let's add some space between the subscribe button and the second project. So earlier, we learned that space on the inside of an element is called padding. Space on the outside of an element is called margin. So inside our subscribe button, at the bottom, let's add a property called margin-bottom, colon 30 pixels, and save. So this will add space on the outside of the element at the bottom of 30 pixels. Now let's move on and style the Amazon shipping calculator with CSS. Again, we'll add a class to these elements and then style them in our CSS. Let's scroll down to the text box, which is the input element, and we're going to add another class by typing space, and let's use the class cost-input. And now we're going to style this in CSS. So let's scroll up, and here we'll style the class using .cost-input and curly brackets. And inside, we'll style this one by one. Let's look at our final design and see what styles we need. So first, let's change the text size because our text is a little smaller than the text here. So to change the text size, we're going to use font-size, colon, and let's try 15 pixels. And save. And now our text looks close enough to the final design. Next, let's add some space inside the text box. So remember, space inside an element is called padding. So we're going to type padding -top of 10 pixels, padding -bottom also 10 pixels, and let's add padding to the left 10 pixels and padding -right of 10 pixels. So this will add space on the inside of our text box in every direction. If we save, now it looks just like the final design. Now I'm going to show you a shortcut for padding that will save us some typing. So if we create a new line, we can actually use a property called padding. and colon, and then type 10 pixels. This padding property lets us add padding on multiple sides at once. If we type one value here, like 10 pixels, it will add 10 pixels to every side. So this line does the same thing as these 4 lines above. So let's actually comment this out using /* and */ and save. And you can see that this one line of CSS did the same thing as the other 4 lines of CSS. So this shortcut can save us some typing. Next, let's move on and style the Calculate button. Again, we'll add a class to this button so we can style it. So in this button, let's add a class attribute. Class equals calculate dash button. Now let's style this in our CSS by scrolling up. And here, we'll type dot calculate dash button and curly brackets. And inside these curly brackets, we're going to style this button one by one. So let's start with the background color. So we'll type background dash color colon green and semicolon and save. Next, let's change the text color to white. So we'll type color colon white and save again. Okay, let's keep going, and we'll remove the border around this button. So we'll type border colon none, save. Next, let's make our text a little bigger, like in the final design. So we'll type font dash size and make it 15 pixels and save. Okay, so now let's add the space on the inside of the button. So we're going to use this shortcut again. We'll type the padding property, colon, and this time we're going to give it 2 values separated by spaces, 10 pixels and maybe 50 pixels. So it's easier to see what this does. So when we give 2 values to padding, the first value is the vertical padding, so the top and bottom. The second value is the horizontal padding, or left and right. If we save, so you can see that the left and right has a lot of padding, which is 50 pixels. So now let's make this match our final design. So instead of 50 pixels, let's bring it down to 15 pixels and save. Okay, so that looks pretty close. Let's also increase the padding on the top and bottom so that the text box and the button line up with each other, like in the final project. So let's change the vertical padding to maybe 12 pixels and save. The last thing we'll style for this project is when we put our mouse over the button, it turns into the pointer icon. So to create this, we're going to use the property cursor colon pointer and save and give it a try. And that's it. We just finished styling the Amazon shipping calculator. So now let's give this a try. We'll type 25 in the text box and press calculate. And at the bottom, it will add $10 of shipping and show $35. Finally, we're going to style the last project in this lesson, which is the rock, paper, scissors project. And this will finish the project. Let's go back to supersimple.dev and we'll scroll down on this page and then click this link to show the final design for rock, paper, scissors. So I'll rearrange my windows so we can see this. And we're going to change the buttons to these nice big icons for each of the moves. And when we click a move, it will show the result in bold and show an icon of the move that we picked and the move that the computer picked. So we're going to make this project look really nice. Now let's get started. I'm going to rearrange my windows back so we have it at the bottom. And let's create a copy of the rock, paper, scissors project for this lesson. We'll go to our code editor and click here to show our files. And we're going to make a copy of 09-rock, paper, scissors. So let's click this file and then right click, copy, and down here, right click and paste. And we'll rename this file by right clicking, rename, and at the end, we'll remove copy, and at the beginning, we'll change it from 9 to 10 and press enter. Now let's click here to hide the files, and we can close the 09 file. And let's open the 10 rock, paper, scissors file in the browser. So we'll right click and then open with live server. And I'll move this tab to the top here so we can see it side by side. So let's start by styling the body. We want to make the background color of the entire page this dark gray color. We'll go into our code and let's create a style element so we can write some CSS. Inside the head, let's type less than style greater than, and then inside here, we're going to style the body. So we'll type body and curly brackets. Now inside here, we're going to change the background color. So background dash color colon, and we're going to get the color that we see here by right clicking, click inspect, and then go to the elements tab, and I'll rearrange it so we can see it. And then here we'll find the body element and click it, and in this style section we can find the background color that we need. So let's select this and right click, copy, and in here, right click and paste, and a semicolon at the end. Let's save, and I'll move this back to the corner. And now our project has the same background color as the final design. Next, let's make the text color white. So in our CSS, we'll use the color property and colon white and semicolon and save, and that will make our text white. Next, let's change the style or the font of this text. We'll type font dash family colon Arial, which is what the final design uses, and save. All right, now let's style these elements one by one to match the final design. We'll start with this paragraph at the top. So inside the paragraph element, let's add a class so we can style it in CSS. We'll add class equals, let's call this the title, and then in our CSS, we can style this class by starting with a dot and then title and curly brackets. So let's make our title really big, like the final design. We'll change the font dash size colon 30 pixels and save. So that looks close enough. Next, let's make the text bold. In our CSS, we'll use font dash weight colon bold and save. Now let's move on to styling the buttons. So first, we're going to need these images in our project, and I'll show you how to get them. We'll put our mouse over the rock image, and we'll right-click, and we'll click Save Image. And now we're going to find the folder that contains all of our code. So for me, it's on the desktop, and it's this folder right here. So I'll double-click this folder, and then leave the file name as the default, rock-emoji, and click Save. And now in our code editor, if we click here, we should be able to see the rock image. Let's do the same with the paper and scissors image. So we'll hover over it, right-click, Save Image, and in the same folder that contains our code, we're going to save the paper image. And finally, right-click, Save Image, and we'll save the scissors image. All right, now that we have these images in our code editor, let's learn how to load them onto the page. So we can do this using an HTML element. So we'll go back to our HTML code, and we'll scroll down, and inside the button, we're going to add an image element. So let's type less than img and greater than. So this is the image HTML element. It loads an image onto the page. The image element doesn't require a closing tag. This is called a void element. Now to load an image, we're going to add an attribute to this element called src. So src stands for source. It tells the computer which file or image to load. So let's look in our project. For this button, we're going to load rock-emoji.png. Inside the source attribute, we'll type rock-emoji.png. So what this does is it will look for the file with this name beside the HTML file, and it finds it right here, and it will load it onto the page. If we save, now inside our button, it loaded the rock image. Right now, this image is too big, so let's use CSS to decrease the size of this image. We'll hide the files, and let's give a class attribute to the image element so we can style it. So we'll type class equals, and let's call this a move-icon. And I'm also just going to add some new lines to make the code a little easier to read. So we'll scroll up to the CSS, and we're going to style this class using .move-icon and curly brackets. And let's decrease the height of this image. We can use the property height colon and a pixel value, 50 pixels, and save. So this will make the height of this image 50 pixels, and it will also resize the width automatically so that the image keeps its shape. So this size looks pretty close to the final design, so we can move on. Another feature of the source attribute is that we can put our files into folders. So let's open the files by clicking here. And let's say that we want to organize all of our images into a folder. So we're going to create a folder by clicking this icon. And let's name this folder Images. And we're going to drag these images into this folder. And drag this in here and in here. Now, unfortunately, you can see that the image doesn't load anymore. And that's because if we look at our code, source tells the computer to look for this file beside this HTML file. And right now, there is no file called rock-emoji.png because we put it in a folder. So to tell the computer to look inside this folder, we're going to type the folder name at the start, which is images. And then we're going to type a slash to go into the images folder and then look for this file, which is right here. If we save, the computer is now able to find this image and load it onto the web page. So this feature is called file paths. We can tell the computer to look for a folder beside the HTML file, like images, and then use a slash to tell it to go into the folder and look for a file. Now let's use this code to load the other images onto our page. So for the paper image, we're going to go to this button, remove the text, and then create an image element less than img greater than. And we'll give it an attribute source equals, and we'll locate the image. It is in the images folder. So we'll type images and then slash to go into the folder. And we'll load the file paper-emoji.png. So paper-emoji.png and save. So our image is really big. Let's give it the same class that we gave the rock image. So we'll add a class equals move-icon and save. So these styles get applied to all elements with the class move-icon. So it applies to both of these elements. Now let's do the same thing for the scissors button. We'll remove the text and we'll replace it with an image element. And we'll give it the source attribute, images slash scissors dash emoji dot png, and we'll also give this a class of move dash icon to resize the images like up here. Let's save, and now we have all the images that we need. Now let's make these buttons look like the final design. We'll scroll up and let's add a class to these buttons so we can style them with CSS. So we'll add class equals, and let's use move dash button. And for this button, we'll add the same class equals move dash button, as well as for the third button, class equals move dash button. Now let's scroll up to our CSS, and we're going to style this class using dot move dash button and curly brackets. So first, let's change the background color to match the background color of the page. So we'll use background dash color, colon, and we'll use a special value called transparent. And this will make the button see-through. If we save, now these buttons are see-through. Next, let's add this white border to our buttons. So we'll use the border property, colon, and we're going to give it 3 values. The first value is our border width, or how thick the border is. Let's use 1 pixel for now. The second value is the border style, and we'll use solid because it's a solid border. Other values we can use here are dotted or dashed. And the third value is the border color. So we're going to use white. And semicolon at the end and save. And that will add a border. So let's make our border a little thicker like the final design. We'll change this first value, which is the border width, to 3 pixels and save. Okay, so that looks pretty close. Now let's change the size of our buttons. Usually we use the padding to add space on the inside of an element, but in this case, our images have different sizes. So we're going to use width and height to set an exact size. So in our CSS, we'll type width, colon, and let's make it 100 pixels, and height, and also 100 pixels, and save. So it looks like our final design is a little bigger than what we have here. So let's increase the width and the height. So let's try 120 pixels and save. All right, so that looks pretty close. Now let's make these buttons round. And the property for that is called border-radius, colon. And to know how much we need to make it round, we can set it to half of the width or the height. So we'll set it to 60 pixels and save. Okay, so it's coming along really well. And lastly, we're going to add some space between the buttons. So remember that space outside of an element is called margin. So let's add some margin on the right. So we'll type margin dash right colon and maybe 10 pixels and save. And finally, when we put our mouse over the button, it turns into a pointer. So the property for that is cursor colon pointer and save. And now our buttons match the final design. So let's keep moving and style the next part of the project, which is the result and the moves. If you don't see this here, you can just play the game and it'll give us a new result. So to make this easier to style, we're going to go into our code. We're going to find the result, which is here, and we're going to add some fake results like you win. Let's save. And now we have this result and we're going to style it. So let's give this a class of result. And then in our CSS, we're going to style the class dot result and curly brackets. So let's make the text bigger. We're going to use font dash size colon and maybe 25 pixels and save. Okay, that looks pretty good. Let's make the text bold. So we'll use font dash weight colon bold and save. And finally, we're going to add extra spaces between this and the buttons. So we'll add margin dash top and maybe 50 pixels and save. Okay, so I think that looks close enough. Now let's style the moves. And again, we'll scroll down and we're going to add some fake moves in here so it's easier to style. So we'll type U and then an image. So let's use the less than image and the source attribute. And let's just load the rock image and the scissors image for the computer. So to load the rock image, we'll look inside the images folder, / to go into the folder, and then rock-emoji.png. So rock-emoji.png and greater than. And we'll add another image, less than image source equals images / the scissors emoji, scissors dash emoji dot png and greater than, and finally the text computer. Let's save, and this will create some results, although the images are really big. So we can use the class move icon to resize them to be the same size as the buttons. So for both of these images, let's add the class move dash icon. And here as well, class equals move dash icon and save. And now our images look good. Next, let's style this score section. So the only thing we need here is to add spaces between these two. So in this score element, let's add a class of score, and we'll scroll up and style this element using dot score brackets, and let's add some margin at the top. So margin dash top colon 50 pixels and save. And let's compare it. And it looks like our final design has a little more spacing than this. So let's change this to 60 pixels and save. And that looks close enough. And finally, we'll style the reset score button. So let's go back to our HTML. We'll add a class to this button. So here, class equals reset dash score dash button. So at the top, we'll type dot reset dash score dash button, curly brackets, and we'll make the background color white. So background dash color colon white. And let's also remove the border from our button using border colon none. Let's save and see how it looks. And then let's increase the size of this text because the final design looks a little bigger. So we'll add font dash size colon 15 pixels and save. Now let's add some extra space on the inside of the button. So that's padding colon, and we'll give it 2 values. The first value is the vertical padding. Let's use 10 pixels. And the second value is the horizontal padding. So let's use 15 pixels and save. And it looks like our final project is a little shorter than our button. So let's change the vertical padding to maybe 8 and save. And the last step is to add the cursor pointer. So here, cursor :pointer and save. And that's pretty much it. We finished styling our rock, paper, scissors project. So now I'm gonna rearrange my windows so we can see the entire design, and it looks really nice. The last step here is to remove these fake results and use JavaScript to insert these results instead. So let's scroll down and we'll remove this result. And let's actually copy this code because we want our JavaScript to generate this code. So we'll right click and copy. And let's scroll to the bottom to where we insert the moves onto the page, which is here. And instead of this text, we're going to right click and paste the code that we had before. And this time, instead of picking rock every time, we're going to substitute this with the player move. So we'll remove this, and because this is already a template string, we can insert a value directly inside using $ and curly brackets, and we'll insert the player move. Let's also insert the computer's move in here. So we'll remove this and insert a value using $ and curly brackets, and we'll insert computer move. And now that we're inserting this with JavaScript, we can scroll up and remove the fake result, which is here. So we can select it and delete it. Now let's save. And we're not going to have anything in our results. And when we click a move, it will show us the result and also show us the moves that we picked. And that's it. We finished the rock, paper, scissors project. The last thing we're going to learn in this lesson is how to organize our code into different files. So notice that right now, all of our HTML, CSS, and JavaScript is in one HTML file. And this makes the code harder to read because the file is bigger and it mixes 3 different languages. To make our code more organized and easier to read, we're going to separate each language into its own file. So let's scroll down and we'll start by separating our JavaScript into its own file. We'll click here to show our files, and then click this icon to create a new file. And we'll name this file 10-rock-paper-scissors.js and press enter. So when we end a file with .js, it tells the computer that this file contains JavaScript code, not just text. Now let's go back to our HTML file, and we're going to move all of this code into the JavaScript file. So we'll select this code, and then we'll right-click and copy, and inside the JavaScript file, we'll right-click and paste. Now let's save, and we'll go back to the HTML file, and we can delete all this JavaScript code. And now we're just going to load our JavaScript file onto the web page. To do that, we can use an attribute of the script element called src, or source. So we'll make it equal, and this does the same thing as the image element. It tells the computer which file to load. if we type 10 rock paper scissors .js, this will look for a file called 10 rock paper scissors.js beside our HTML file, which is this file here, and it will run all the JavaScript inside this file. So it does the same thing as before, except now our JavaScript code is in its own file. And this makes our code cleaner because each file only contains one language, and each file also contains less code. Now let's go back to the HTML file and save. And you'll notice that our project works the same way as before. We just organized our code better. Another feature of the source attribute is that it also uses file paths. So we can put this JavaScript file in a folder and we'll be able to find it. For example, let's show our files and let's create a new folder by clicking this icon. And let's name this folder scripts. So this folder will contain all of our JS files. So we can drag this file into the folder. And now we can locate it using the source attribute by typing the folder name, which is scripts, and then a slash to go inside this folder and look for this file. And it will find it right here. If we save, everything works as normal. Another feature is we can use multiple script elements. This lets us split our JavaScript into multiple files and then load them all onto the page from top to bottom. Next, we're going to learn how to separate our CSS into its own file. Let's scroll up to our CSS. So we can do the same thing with CSS. So let's click the HTML file and let's create a new folder. And we'll call this folder styles and press enter. So this folder will contain all of our CSS code. Let's click the folder and we'll create a new file by clicking this icon. And let's name this file 10 rock paper scissors .css and press enter. So ending the file with .css means this file contains CSS code. And now we can go back to our HTML and move our CSS into its own file. So let's select all this code and then right click, copy, and in here, right click and paste. And save this file. Now let's go back to our HTML and we can remove this code. And we'll learn how to load our CSS file onto our website. So we're not going to use the style element for this. We're going to use a different element called the link element. So we'll type less than link greater than. And the link element doesn't require a closing tag. This is another void element. So the link element uses two attributes. The first attribute is called REL. REL means relation. This tells a computer what type of file we're loading. So we're going to set this attribute to style sheet. This means we're loading a CSS file. And then we'll add a second attribute called href. So href tells a computer which file we want to load. So this also supports file paths. So we can type the styles folder this will look for a folder beside the HTML called styles, which is this one right here. And then we'll type / to go inside the folder and look for this CSS file, which is 10-rock-paper-scissors.css. So this will load all the CSS inside this file and apply it to our page. So it does the same thing as before, except we separated each language into its own file. If we save, everything still works and all the styles get applied. And just like the script element, we can also use multiple link elements to load multiple CSS files. So that's how we separate our code into separate files using the script element and the link element. It makes our code a lot easier to read because each file contains one language and it contains less code. And that's the end of this lesson. As a final reminder, the CSS we learned in this lesson is just a review. If you want to learn CSS in more detail, you can check out my HTML and CSS full course in the video description. So in this lesson, we reviewed CSS and added CSS to all of our projects. We learned about the class list property, which lets us control the class attribute of an element. We finished our rock, paper, scissors project, and we learned how to organize our JavaScript and CSS code into separate files. Here are some exercises to help you practice using HTML, CSS, and JavaScript together. In this lesson, we're going to learn two more features of JavaScript called arrays and loops. And we're going to use these features to create this to-do list project. First, let's create a new file for this lesson. We'll go to our code editor and click up here to show our files. And this time, make sure you have one of these HTML files selected, so we don't create the new file in one of these folders. So now we're going to click this icon to create a new file, and we're going to name this file 11-arrays-and-loops.html and press enter. Now let's copy the previous lesson into this file. So we'll click on 10 DOM projects and we'll type here and type Control A or Command A to select the code, and then right click, copy, and in here, right click and paste. Now let's hide our files and we'll prepare this file for this lesson. So we can scroll to the top and we'll change the title to arrays and loops. And let's remove all of the CSS. And we'll also remove the HTML, which is right here. And we'll remove all the JavaScript. Now let's save, and we'll open this file in the browser by right-clicking, open with live server. And let's also open the console. So we'll right-click, click inspect, and click the console. And now we can close the previous tabs and the previous code for now, until we just have the lesson 11 file. Now we're ready to learn arrays. An array is another type of value in JavaScript, and it represents a list of other values. So let's do an example and create our first array. We'll go into the script element, and we're going to type open square bracket and closed square bracket. And inside the square brackets, we'll type a value, like the number 10. And then we'll type comma and another value, like the number 20, and then comma again, and a third value, like the number 30. So this is an array, and it represents a list of 3 numbers, 10, 20, and 30. Now, arrays themselves are also values, which means we can save them in a variable. So at the front, we can create a variable using const, and let's name it my array, and we'll make it equal to this array. And we'll add a semicolon at the end. So now we created a list of values, and we saved this list in this variable. Let's create a new line, and we'll console.log my array and save, and it will display the list of values in the console. So that's basically what an array is. It's a list of values. Now, to get a specific value in an array, we can use square brackets. So let's create a new line, and we'll type my array and square brackets. Inside these brackets, we'll put a number like 0. This number represents the position in the array. So 0 means the first value. If we console.log this code and save, my array square bracket 0 gives us the first value, which is 10. And that's what's displayed in the console. Now, if we change this to 1, this will get us the second value in the array, which is 20. If we save, it displays 20. So this number represents the position in the array. 0 is the first value, 1 is the second value, 2 is the third value, and so on. We can also change a value in an array, also using square brackets. So let's create a new line, and we'll type my array square brackets, and let's say we want to change the first value. So we'll type 0 for the first value, and we just make it equal to something else, like 99. Now, if we console.log my array again and save, you can see that this changed the first value to 99. So that's basically how arrays work. We can access a value inside an array, and we can also change a value inside an array. Now that we understand the basics of arrays, let's learn the syntax rules. To create an array, we start with an open square bracket, and we end with a closed square bracket. Inside, we can put a list of values, and we separate each value with a comma. We can also write an array on multiple lines, like this. We just put the new lines after the comma. Now, to get a value inside an array, we can use square brackets and a number, like 1. This number is called the index. It represents the position in the array that we want to get. So the first value is index 0, the second value is index 1, third value is index 2, and so on. Notice that the index starts as 0. This is called a zero-indexed array. Now, inside an array, we can put any type of value. For example, let's create a new line, and we'll create a new array using square brackets, and inside we can put the number 1 and then comma, and we can also put a string like hello and another comma, and we can put a Boolean value like true and another comma, and we can even put an object like curly brackets, name, colon, socks. Now, an array itself is also a value. That means we can save arrays in variables like this, or even save it in an array. For example, in this array, we can add an array inside, like 1, 2. Next, arrays have a weird behavior when we try to check the type of an array. So on a new line, let's type console.log type of, and then square brackets 1, 2, and save. This will tell us that an array is an object. And that's because an array is actually an object, but is just a special type of object. If we want to check if something is specifically an array, we can use this code. Capital A array dot is array brackets. And inside the brackets, we'll put an array like square brackets 1, 2. So this will check if this value is an array. If we console.log this result and save, it will display true. And finally, because arrays are just a type of object, they also have properties and methods we can use. So one useful property is called .length. So we'll type console.log my array.length. This will tell us how many values are in the array. So my array has 3 values. So if we save, it will display 3. Next, we'll learn a useful method of an array called .push. This adds a value to the end of the array. If we did my array.push 100, this will add 100 to the end of my array. If we console.log my array and save, you can see that 100 was added at the end. The last method we're going to learn for now is called .splice. This removes a value from an array. For example, my array.splice and brackets, and a splice takes 2 numbers. The first number is the index that we want to remove. So let's say we want to remove the first value, which is index 0. The second number we give to splice is the number of values we want to remove. If we give it 1, it will remove 1 value at index 0. If we give it 2, it will remove 2 values starting at index 0. So for now, let's just remove 1 value. And let's create a new line and console.log my array and save. You can see that splice removed the first value from the array, or index 0, which was 99. All right, now that we understand the basics of arrays and the syntax rules, let's do some practical examples. So I've prepared a project we can do for this lesson. We'll go to our browser, create a new tab at the top, and here we'll type super simple.dev/projects/arrays and press enter. So this page contains the to-do list project we're going to create in this lesson. So down here is the final version of the project. We can type a name for our to-do, like make dinner, give it a due date, and then click add, and it will add it to our list. We can add another to-do, like wash dishes, and then select a due date and click add again, and it will add another to-do to our list. And each to-do also has a delete button, so we can delete it when we're finished the task. So this is the final version of the project. And these two up here are simpler versions of the project that we're going to use to work our way up. So let's start with the first project up here. We're going to open our console by right-clicking, click Inspect, and click the console. And the way this first project works is we can type a to-do in this text box, like make dinner. And when we click add, it will add the to-do to an array and display it in the console. If we type another to-do, like wash dishes, and click add, it will add it to the array and display it in the console. So let's create this project. We'll start by creating a file for this project. We'll go to our code editor and click up here to show our files, and click this icon to create a file, and we'll name this 11-to-do-list.html and press enter. Now let's copy the code from arraysandloops.html. So we'll click here, Control A or Command A, and then right click, copy, and down here, right click and paste. And let's close this for now. We'll scroll up and change the title to to-do list and remove all the JavaScript code. And this time, instead of writing all the JavaScript in here, let's actually put the JavaScript in a separate file, which we learned in the previous lesson. So we'll open our files again, and this time we'll go to our scripts folder. We'll click this JS file, and we'll click this icon to add a new file to this folder. And let's name it 11-to-do-list.js and press enter. Next, we're going to load this file into our HTML file. So let's open this. And in the script element, we can remove the spaces, and we're going to add an attribute called src equals and we're going to load the JavaScript file that we just created, which is inside the scripts folder. So we'll type scripts and then a slash to go into this folder, and we'll load the file 11-todo-list.js and save. So now I'm going to drag this file down here so I can see both the HTML and JavaScript at the same time. Close this for now, and I can close the other code for now as well. And finally, let's open this in our browser. So we'll right-click, open with Live Server. And let's also open the console on this page. Right-click, click Inspect, and click the console. Now, one more thing I'm going to do for this video is I'll rearrange my windows so that we can have the final design at the bottom. Let's start by creating the HTML elements. Let's go to the body, and we'll actually create a paragraph element to start. Inside the paragraph, we'll put the text to-do list. Next, let's create the text box. So to create a text box, less than input, greater than. And we'll add a placeholder to this text box. Placeholder equals to-do name. Finally, let's add this button. So on a new line, let's type less than button greater than, and inside the button, we'll have the text add. Now let's save, and this creates all the HTML elements that we need. Next, let's write our JavaScript. So first, we're going to create an array to store our to-dos. And then when we click the add button, we're going to get the text from the text box and add it to our array. And finally, we'll console.log the array. Now let's convert these steps into code. Let's create a new array first. Using const, let's name it to-do list, and we'll make it equal to square brackets. So this is an array with no values inside. We also call this an empty array. Next, when we click the button, let's get the value from the text box. So let's go to our button and add an onClick attribute. And then inside here, let's create a function for this. So down here, let's create a function. We'll name it add to do brackets and curly brackets. And then inside the onClick attribute, we're just going to call this function. Add to do and brackets. The next step is to get the text in the text box. We can do that using document.querySelector. So to use query selector, we're going to put a class on this input element. So we'll type the class attribute js-name-input, and then in here, document.querySelector, brackets and a string, and we'll type a dot to get a class, and we'll get this class, js-name-input. As a reminder, this gets an element with the class JS-name-input, which is this element, and puts it into our JavaScript. And now let's save this in a variable. So at the start, let's type const input element and make it equal to this result. So now we took this input and put it into our JavaScript. To get the text out, we're going to use a property of the input element called value. So down here, input element dot value. And let's save the value in the text box in a variable so we can use it later. At the front, const name, and we'll make it equal to whatever's in the text box. Before we continue, let's console.log the name to check if this is working. So let's save this JavaScript file, and let's also save this HTML file. We'll go to our browser, and I'll resize it so we can see the console. And now if we type something in the text box, like make dinner, and click add, it will get the text from the text box and then display it in the console. Okay, so it's looking good so far. The next step is to add this name to our to-do list. So we learned how to do this earlier. We can use a method called push. Push will add a value to the end of the array. So let's remove this for now. And at the bottom, we're going to type our array to-do list dot push brackets. And then between the brackets, we're going to add our name here. And now the last step is to console.log the entire array. Console.log to-do list and save. Now let's give it a try. We'll type make dinner in the text box and click add. It will take this text, add it to the array, and then console.log the array. And now we have our to-do list. Let's add another to-do. We'll type wash dishes and click add. Again, it will get the text in the text box and then add it to the array. So now our array has two values, and then we display them in the console. So that's how we create this first version of the to-do list project. Now, one more feature we're going to create is if we add something to our to-do list and click add, it will reset the text box. To do that, let's go into our code and we'll create some new lines. And remember that the value property represents the text in the text box. So to change the text in the text box, we can simply change the value property. So we'll type input element dot value and change it to the empty string. So this will make the text in the text box become empty. If we save and now type something in the text box and click add, it will reset the text in the text box. Let's move on to the second version of the to-do list. So here, when we type something in the text box, like make dinner and click add, it will actually display it on the page. If we type something else, like wash dishes and click add, it will also add it to the page. So how do we take our array and display each value on the page? To do this, we're going to learn another feature of JavaScript called loops. Loops let us run some code over and over, like a loop. So let's go back to our 11 arrays and loops file, and we can close this JavaScript file for now, and we're going to learn loops. So first, let's comment out the previous code by typing /star and at the bottom */. Let's scroll down and we'll create our first loop. We'll start by creating a variable using the word let, and we'll name this variable I, and we'll make it equal to 1. Next, we're going to type the word while, and then brackets and curly brackets. And then inside these curly brackets, we're going to put some code that the computer will run over and over, just like a loop. Let's put the code console.log I. So this will display the variable I in the console over and over again. Now, obviously, we don't want to loop this forever. So how do we get this loop to stop? We can do that using the round brackets up here. Inside these round brackets, we're going to put some code that results in true or false. For example, we can check if I is less than or equal to 5. So the way this works is that if this code results in true, the loop will keep going over and over. Once this results in false, the loop will stop and it will go to the next line. Now you may notice that this code will never result in false because I is equal to 1 and 1 is always less than or equal to 5. So when does this actually become false and stop the loop? The answer is, inside this loop, we're also going to update this variable I. So we'll type I and we'll make it equal to itself plus 1. So now every time we loop over this code, we're going to increase I by 1. And eventually, I will be greater than 5. This will return false, and it will stop the loop. If we save, and then go back to the tab for this file, and I'll rearrange my windows so we can see the console, this loop makes the computer count from 1 to 5. So let's go over this code step by step to make sure we understand how it works. First, we create a variable I and we make it equal to 1. And then we do a loop. So if this condition is true, the computer will keep running this code over and over again. So the first time it loops, I equals 1, and then it displays 1 in the console, and then we increase I to 2. Now we go back to the top, and we check this code. 2 is less than or equal to 5. This is true, so we're going to run this code again. This time I equals 2, and we display it in the console, and then we increase I to 3. And now 3 is still less than or equal to 5, so this is true, which means we keep running this code. And eventually, this is going to increase I to 6. Once I is 6, this will become false, which will cause the loop to stop, and then we go to the next line. So that's why it counts from 1 to 5, and then it stops at 5. So this is called a while loop. While this condition is true, it will keep running this code over and over again, just like a loop. As soon as this condition is false, it will stop the loop. All right, now that we understand how a while loop works, let's learn the syntax rules. To create a while loop, we type the word while, and then round brackets and curly brackets. The code inside the round brackets is called the loop condition. The code inside the curly brackets is called the loop body. The variable I at the top is called the loop variable. Every time we loop, we're going to increase the loop variable. This is known as the increment step. The increment step makes sure that the loop ends at some point. Without this increment step, the loop would just keep going forever. This is known as an infinite loop. Now remember that I equals I plus 1 has a shortcut. Instead of this, we can just do I plus equals 1. And remember, we actually have an even shorter shortcut for plus equals 1. Instead of this, we can also do I plus plus. So this will increase the value of I by 1 every time, just like before. So those are the three major parts of a loop: the loop variable, the loop condition, and the increment step. Now, each time we run this loop, this is called an iteration. So in this loop, we did 5 iterations. We ran this code 5 times. And lastly, loops create a scope. Any variable that we create between these curly brackets will only exist inside the curly brackets. So that's a while loop. While this condition is true, it will keep running this code over and over again. Once this condition becomes false, it will stop the loop and go to the next line. So in JavaScript, there's actually 2 types of loops. The first type is a while loop, which we just learned. Now we're going to learn another type of loop called a for loop. To create a for loop, we'll create some new lines, and then down here, we'll type for, and brackets and curly brackets. Inside these brackets, we're going to type 3 pieces of code. The first piece of code is the loop variable, which is the same thing as this line up here. So we'll type let I equals 1, and then semicolon, space, and we'll type a second piece of code, which is the loop condition. So here we'll type I less than equal to 5, and then semicolon and space. And the last piece of code is the increment step, which is this line right here. So we'll type I plus plus. And between these curly brackets, we'll write the code that we want to loop over and over. So let's just type the code console.log I and save. So this for loop does the same thing as the while loop above. It counts from 1 to 5. And if we look at this code, we can see that a for loop is just a shorter version of this while loop. Instead of writing the loop variable, condition, and increment step separately, we group all of them together at the top. So this loop works the same way. First, we create a loop variable, and then as long as this loop condition is true, we will keep running this code over and over. And every time we run this code, we're also going to increase the loop variable by 1. So now that we learned 2 ways of doing a loop, which one should we use? If we're doing a standard loop, for example, it has a loop variable, a condition, and an increment step every time, it's recommended to use a for loop because a for loop is shorter and more organized than a while loop. However, if it's a non-standard loop, then it might be better to use a while loop. So what's an example of a non-standard loop? So let's say we want to generate random numbers until we get a number that's at least 0.5. To create this loop, we'll create a variable that will store the random number using let random number and make it equal to 0 to start. And then we'll do a while loop, brackets and curly brackets. Now inside the loop condition, we want to keep running this loop until random number is at least 0.5. So we'll check if random number is less than 0.5. Because if it is less than 0.5, we want to keep running this loop until we get a random number that's at least 0.5. And then inside this loop, we're going to generate a random number between 0 and 1, and then save it in the variable up here. So we'll type random number and make it equal to capital M math dot random. So if this random number is less than 0.5, it will keep generating random numbers until we get a number that is at least 0.5. So at the bottom, if we console.log random number and save, it will give us a random number that's at least 0.5. So notice that this is a non-standard loop. It doesn't really have a loop variable that we increase every time, and it also doesn't have the increment step. So in this situation, when we have a non-standard loop, it's better to use a while loop because they're a bit more flexible. All right, now that we learned the basics of loops, let's do some practical examples. We're going to learn a technique called looping through an array. This means we're going to go through each value of an array one by one and do something with each value. So first, let's comment out the previous code using /* and */. At the bottom, let's create an array of strings. So we'll create a variable const to do list equal to an array. And inside this array, we'll have the string make dinner, another string wash dishes, and another string watch YouTube. Now let's take each value in this array and display it in the console. To do that, we're going to run a loop, and this loop is going to count from 0 to the last index in the array. So remember that the index is the position of a value in the array. The first value is index 0, the second value is index 1, third value is index 2, and so on. So below this, let's type for brackets and curly brackets. Inside these brackets, we're going to create the loop variable. So here, we're going to count the indexes. Let index equals 0, semicolon space, and we'll do the loop condition. So we'll keep looping as long as the index is less than or equal to the last index. So remember that the index starts from 0. This means that the last index in an array will be the number of values in the array minus 1, or the array.length minus 1. To do list.length minus 1. And here we'll add another semicolon, and we'll add the increment step, which is index plus plus. So we'll increase it by 1 every time. Now inside these curly brackets, we can do something for each index of this array. For now, let's just console.log this index and save. So this will count from 0 to 2, which is exactly all the indexes in this array. And now, using this index, we can also access the value at this index. So instead of just the index, here we can do to-do list and then square brackets, and between the brackets, index. This will take whatever the index variable is and access that index in the array. So if the index variable is 0, this will access to-do list index 0, which is the first value. When the index is 1, it will access to-do list index 1, which is the second value, and so on. So for now, let's save the value in a variable using const value and make it equal to-do list bracket index. And now let's console.log the value instead. If we save, this will loop through each index of the array, get the value at each index, and then display each value, which is what we see in the console. So this technique is called looping through an array. We use a loop to go through each value of an array, and then we can do something with each value. Now, I'm going to show you a few shortcuts we can use when looping through an array. Instead of checking if index is less than or equal to to-do list.length minus 1, we can shorten this to index less than to-do list.length. So this check does the same thing as before. The loop will stop at index equals length minus 1, but it saves us some typing. Another shortcut is, instead of naming the loop variable index, we can shorten this to I. And we'll shorten this as well, and this as well. And that's why we often name the loop variable I. I means index. Next, we're going to learn a technique that we can combine with looping through an array, called the accumulator pattern. So first, let's comment out the previous code using /* and */. And at the bottom, let's say we have an array of numbers like this. How do we calculate the total of all the numbers in the array? Let's set up this problem. Let's say we have an array of numbers, const nums equals array, and then the numbers 1, 1, and 3. And we want to calculate the total of all the numbers in this array. To calculate the total, we'll learn the accumulator pattern. The first step of the accumulator pattern is to create a variable to store the result. So below this, let's create a variable const total, and we'll make it equal to 0. And the next step is to loop through this array and update the result. So down here, for brackets and curly brackets, and inside the round brackets, we'll create the loop variable let I or index equals 0, semicolon space, and we'll create the loop condition I less than nums dot length, and then semicolon, and the increment step, I plus plus. So as we learned earlier, this loop will go through each index of this array. And now between these curly brackets, first, let's use the index to get each value. So we'll type nums and then square brackets and access the index I. And let's save this in a variable using const num equals this value. And finally, we're going to add each number to the total. We can type total and make it equal to itself plus each number. And remember, we have a shortcut for this, which is plus equals. And finally, since we're changing this total variable, we have to change from const to let. All right, so after this loop, we should have added each number in the array to the total. So at the bottom, let's console.log the total and save, and it will display 5, which is the exact total of all the numbers in this array. So that's the accumulator pattern. We first create a variable to store the result, and then we loop through the array and update the result. So notice that as we loop through the array, we're adding or accumulating the results into this variable. And that's why this is called the accumulator pattern. And we call this variable the accumulator variable. All right, let's do another example using the accumulator pattern. Let's say we're given this array of numbers again, and we want to create a copy of the array where each number is doubled. So if the array is 1, 1, 3, we're going to create a new array with 2, 2, 6. So at the bottom, we'll create some new lines and use the accumulator pattern. The first step is to create a variable to store the result. Let's type const, and let's name this nums doubled. And we'll make it equal to an array this time. So notice in the previous example, the accumulator variable was a number. In this example, the accumulator variable is an array. So we can use different types of values to accumulate the result. It all depends on the problem we're trying to solve. So now the next step is to loop through this array and update the result. At the bottom, we'll create a for loop, brackets and curly brackets. Inside the round brackets, we'll create the loop variable let I equals 0, and we'll create the loop condition I less than nums dot length, and then the increment step I plus plus. And now between the curly brackets, we're going to get the number at each index. So const num equals nums square bracket I, and then we're going to update the result. So down here, we're going to add this number doubled to this array. So remember, to add a value to an array, we can use the method push. So we'll type nums doubled dot push brackets, and we're going to add to this array the number num multiplied by 2. And now at the bottom, let's console.log the result, nums doubled, and save. So this second loop will create an array where each number is doubled. So that's how we solve this example. All right, now that we understand how to loop through an array and the accumulator pattern, let's go back and we'll create the second version of our to-do list. So when we add something to the list, it will appear on the page. Let's go to our code editor and we'll open 11 to-do list.html. And we're also going to open the JavaScript file. So it's this one. And for the video, I'm going to drag it to the bottom of my code editor so that I can see the files side by side. So I'll close this for now, and I'll rearrange my windows a bit. Let's open the tab for this project. So we'll review what we have so far. We can click in this text box and type a to-do like make dinner and click add, and it will add this to-do to this array, which is this array right here. We can type another to-do like wash dishes and click add, and it will add it to the end of the array. So now that we have this array of to-dos, we want to display it on the page. To do that, we're going to loop through this array and we're going to create some HTML code for each to-do and then put that code on the web page using the DOM. So first, let's loop through this array. To make this easier, let's make a copy of this array. So right-click, copy, and then here, we'll remove this and right-click and paste. So this will give us some default values to work with. So at the top, let's loop through this array using a for loop. So we'll type for brackets and curly brackets. And then inside the round brackets, we're going to create the loop variable let I or index equal 0, semicolon, and the loop condition I less than to-do list dot length, semicolon, and then the increment step I plus plus. So this will loop through each index of this array. And then inside the curly brackets, let's get the string for each index. So we'll create a variable to save it, const to do, and we'll make it equal to do list, square brackets, and I. And now for each to do, we're going to create some HTML code. So we'll create a new line and create a variable const HTML and make it equal, and we'll create some HTML code using this to do, using a template string. And then inside, we'll create a paragraph element. So less than p greater than, and then less than /p greater than. Inside this paragraph, we're going to insert this to do. So we'll type $ and curly brackets and to do. All right, so now we're looping through this array, and for each to do, we created some HTML code. And now we're going to combine all of this HTML code together and put it on the web page. To combine this HTML together, we're going to use the accumulator pattern. So at the top of the loop, we'll create a variable to store the result, let to do list capital HTML, and we'll make it equal to the empty string at the start. And then as we loop through the array, we're going to add this HTML to the variable up here. So let's create a new line, and we'll do to-do list capital HTML plus equals HTML to combine all of this HTML code together. So now after the loop, let's console.log to-do list HTML to see what we get. If we save, we took this array of strings, generated paragraph elements for each string, and then combined them all together. So now that we have all this HTML, we can put it on the page using the DOM. So first, let's create an element where we can put this HTML. So inside the HTML file, after the button, we're going to create a different type of element called a div element. So we'll type less than div greater than. So the div element represents a container. Its purpose is to contain other elements inside, like paragraphs, buttons, and even other divs. So in this situation, we can't actually use a paragraph element because in HTML, we cannot have a paragraph inside another paragraph. So that's why we have to use a div element here. For now, let's put some text inside this element so we can learn more about it. We'll type text and save. So like the paragraph element, the div element is a block element. That means it will take up an entire line by itself. And that's why it appears below the text box and the button. Now, one difference between a div and a paragraph is that a paragraph adds extra space above and below the paragraph, while a div does not add any extra space above or below. So it doesn't have any default styling. All right, so now that we learned the div, let's put this HTML code inside this div. First, we need to get this element into our JavaScript. And to do that, we'll add a class to this element, class equals js-to-do-list. And then down here, let's scroll down and we'll put this div element inside our JavaScript. We can do that using document.querySelector, brackets and a string, and we'll type a dot to select a class, and we'll select the class js-to-do-list. So this will get this div element and put it inside our JavaScript. And then every HTML element has a property called .inner capital HTML, which controls the HTML inside this element. And now to put the to-do list HTML into this div element, we're going to make the inner HTML equal to the to-do list HTML. And now let's save this file and also save the HTML file. So this code will take the HTML that we created using the loop and put it into the div element. And that's how we make them show up on the page. So now let's try adding another to-do. We'll type watch YouTube and click add. And unfortunately, this new to-do doesn't show up on the page. And that's because when we click add, it will run this add to-do function and update the list. But we didn't actually update the HTML on the page. So to update the HTML, we need to run all this code again every time we add a to-do. So let's create a function for this code so we can reuse it. So at the top, we'll create a function, and let's name this render to-do list, brackets and curly brackets. So the word render means to display something on the page. So we'll put all of this code into this function. So we can delete this curly bracket, and then at the end, we'll type a closed curly bracket. And let's reformat this code by selecting these lines, and then press Tab to add an indent. So now let's use this function. At the start, we'll display this to-do list on the page. So we'll call this function by typing render to-do list and brackets. And then let's scroll down. Every time we add a to-do to the list, we're also going to display the list again. So at the bottom, render to-do list and brackets again. So if we save, at the start, it will display the list on the page. And then if we add to the list, like watch YouTube, and click add, it will add it to the list and also display it on the page. So that's how we create the second version of the to-do list project. By the way, if we scroll up to the render to-do list function, this technique is called generating the HTML. Instead of writing all the HTML by hand up here, we looped through an array and we generated the HTML using JavaScript. Let's take a break before continuing with the rest of this lesson. Here are some exercises you can do on your own to practice what we learned so far. Now let's create the final version of the to-do list. We'll go back to supersimple.dev, and then here we'll scroll down and we'll create this final version. So in this version, we can type a to-do like make dinner, and we can also add a due date. And when we click add, each to-do will now have a name and a due date. And they will also have a delete button that we can click to remove it from the list. So let's build this out one feature at a time. We'll start by creating this delete button. We'll go into our code, and remember, we're generating the HTML for the to-do list. So for each value in the array, we create a paragraph element. So to add a delete button, we just have to add a delete button inside here. So inside the paragraph, we'll create a less than, button, greater than, and then less than slash button greater than. And then inside this button, we'll put the text delete. Let's save. And in the console, you'll see that the HTML we generated now has a delete button inside the paragraph. And that's what shows up on the page. Next, we're going to reformat this HTML to make it a little easier to read. So we'll create some new lines here and at the end. And let's put the content of the paragraph on its own line, like this. and also put the delete button on its own line. So remember that template strings have a feature called multi-line strings. So this is perfect for writing HTML code. Next, let's make our delete button do something when we click it. To do that, we use the onClick attribute as usual. So inside this button, we're going to add an onClick attribute equals double quotes. And then inside these double quotes, we can run some JavaScript when we click this button. So this works the exact same way as what we've been doing so far in this course. The only difference now is that here we're generating this HTML using JavaScript. Okay, so when we click one of these delete buttons, we want to remove this to-do from the list. Earlier in this lesson, we learned how to remove a value from an array using a method called splice. So inside this onClick attribute, we're going to type the to-do list dot splice and brackets. So splice takes two numbers. The first number is the index that we want to remove. So if we click this delete button, how do we know which index to remove? Well, if we look at our loop up here, we already have the index. It's this variable I. So we're going to insert I into this string. And we can do that by typing dollar, curly brackets, and I. Now splice also takes another number. So we'll type comma, and the second number is how many values we want to remove. So here, we just want to remove one value at this index. And finally, because we updated the to-do list, we need to display the list again on the page. To display the list, we can use this function, render to-do list. So down here, we're going to type render to-do list and brackets. Now, if we save, you can see that in the generated HTML, when we click the first delete button, it will remove the value at index 0, which is the first value. If we click the second button, it will remove the value at index 1, which is the second value. So we're basically generating all this HTML using a loop. So now if we click this delete button, it will remove it from the list and then display the updated list on the page. So that's how we create the delete button. Next, let's go back to supersimple.dev, and we're going to create the due date feature. So first, let's create this date selector in our HTML. We'll go to our HTML file, and then under the text box, we're going to add another input element. So less than, input, greater than. And to make it a date selector, input elements have an attribute called type. So this attribute determines what kind of input it is. If the type is text, which is the default value, it's going to be a text box. Now, if we change the type to date and save, it's going to create a date selector. Now let's go back into our JavaScript code, and first we're going to scroll up. And remember that right now our to-do list is just an array of strings. But this time, each to-do is also going to have a due date. So how do we group the name and the due date together? We can do that using an object. So here, instead of just a string, we're going to create an object. And we'll give it a name property, which is make dinner, and we'll give it a due date property. And we'll make the due date a string. So you can type whatever date you have on the page. For me, it's 2022-12-22. And I'll end this object with a curly bracket, and I'll turn this second to do into an object as well. So open curly bracket, name, and due date. 2022-12-22, and closed curly bracket. Now that each to-do is an object, we need to update the rest of our code. Let's scroll down, and we'll start with the render function. So here, inside the loop, each to-do is no longer just a string, it's an object. So let's change this variable name to to-do object to make it more clear. And now we need to get the name and due date out of this object. So we'll type const name equals to-do object dot name and const due date equals to-do object dot due date. And now instead of inserting to do, which no longer exists, we're going to insert the name. And we're also going to insert the due date. If we save, now each to do will also display a due date. Before we continue, we're going to review a shortcut we can use with objects called destructuring. So here, you'll notice the variable name is the same as the property name. We actually have a shortcut for this using const curly brackets name equals to-do object. So this is called destructuring. This takes the name property out of the object and puts it in a variable also called name. And this is a shortcut for this line up here. So we can comment out this line. We can also use multiple properties in this shortcut. To also take the due date out of the object, we can just add a comma and due date. So this will do the same thing as this line of code, and we can comment this out. If we save, everything still works. Next, let's scroll down, and we're going to update our add to do function. So this time, when we click the add button, we're going to get the name and the due date and put it into our list. So let's get the due date out of this date selector first. We can do that using the DOM like we did here. So let's add a class attribute so we can get it using query selector js-do-date-input. And then down here, let's create a variable const date input element and make it equal to document.query selector and a string dot, and then the class we want to select, which is this class, js-do-date-input. So this will get the date selector element and put it into our JavaScript. And now below this, let's get the due date out of the element. We can do that using the value property again. So let's create a variable first, const due date, and we'll make it equal to the date input element dot value. So this will get the date that we selected and save it in this variable. And now when we add a to-do to our list, instead of just a name, we're going to add an object. So open curly bracket, we'll add a name property, and the value will be the name variable up here. So name, and then comma, and a due date property. And the value will be this due date variable up here. So due date, and then a closed curly bracket. And remember that objects also have a shortcut for this. If the property and the variable name are the same, we can just type it out once, like this. This will do the same thing as this line above. Same thing with this second line. If the property and the variable name are the same, we can just type a comma and type it out once. This is called the shorthand property syntax. So these two lines do the same thing as these lines above. So we can comment this out using double slash and double slash. So that's all the code that we needed to update. Now let's save our JavaScript file, and we'll also save our HTML file. And let's go to our project. We'll add a new to-do like watch YouTube and select a date and click add and scroll down. You can see that it added our new to-do with a name, due date, and a delete button. If we click this delete button, it will remove that to-do. If we click this one, it will also remove the correct to-do. And that's actually all the functionality that we need for this project. So let's go into our code, and we're going to clean up by removing the console.log here and the console.log up here. And save. Finally, let's add CSS to our project to make it look like the final design. We'll go into our code editor and scroll to the top. And instead of writing all the CSS in here, let's put the CSS in a separate file, just like our JavaScript. So we'll click here to show our files, and then find the styles folder. And we'll click the styles folder and click this icon to create a new file inside. And we'll name this file 11-to-do-list.css and press enter. And for the video, I'm going to take this CSS file and put it at the bottom of my code editor so I can see these files side by side. And now I'll click here to close it, and we'll load this CSS into our HTML. To do that, we can use a link element. So inside the head section, let's type less than link greater than, and we're going to give it two attributes. Rel equals style sheet, and href equals the file that we want to load. So we created this in the styles folder. So we'll type styles and then a slash to go into the folder, and we'll load this file 11-to-do-list.css and save. Now let's style our project one by one until it matches the final design. We'll start with the text on the page. We're going to change the font. So in here, let's type body, curly brackets, and then we'll change the font dash family : Arial and save. So that looks pretty good. Now let's work on styling the to-do list. First, let's add some more to-dos to the list. So we'll type watch YouTube, and then we'll select a date and click add. And we're going to learn how to style our list to look like this. So notice that this list creates a sort of grid. We're going to create this grid using a feature called CSS Grid. So let's go into our HTML first. We're going to add a class to this div element so we can style it. To-do-grid. And let's save. And inside our CSS, we're going to style this class using .to-do-grid and curly brackets. And to turn this into a grid, we're going to use the property display and grid. And we're going to add another property called grid-template-columns. So this basically sets how many columns are in our grid. The number of values that we give it is the number of columns. For example, if we give it 200 pixels, 150 pixels, and 100 pixels, this will create 3 columns in the grid. The first column will be 200 pixels, the second column will be 150 pixels, and the third column will be 100 pixels. And now each element inside this div will go into the columns. So the first element will go in the first column, second element will go in the second column, and the third element will go in the third column. If we have more than 3 elements, it will wrap around and create a new row. So let's save. And unfortunately, that didn't quite work. And that's because if we go back to our JavaScript, remember that each to-do is one paragraph element. So this entire to-do with the name, due date, and delete button will go inside the first column, and then the next entire to-do will go inside the second column. But what we actually want is for the name to go in column 1, due date column 2, and delete button column 3. To do this, we're going to separate this element into 3 elements so that each element will go into each column. So instead of one paragraph, let's actually use a div element. So less than, div, greater than, and less than slash div greater than. And in between, we'll insert the name. So the reason we used a div element is because div elements don't have any default styling. So it's a little easier to style with CSS. For the due date, let's also create a div element. So less than div, and then at the end, less than slash div, greater than. And finally, for the delete button, we already have an element. So let's just reformat these lines. We'll select these lines and then press Shift-Tab to remove the indent. Let's remove the extra line, and we basically separated each to-do into 3 elements. If we save, now the grid is working because this element goes into the first column, this element goes into the second column, and the button goes into the third column. And that's how we lay out these elements in a grid, like the final design. Next, let's also lay out the inputs and the add button in a grid. We'll go to our HTML, and let's put these 3 elements in a div so we can use grid. So we'll create a less than div greater than, and then inside, let's remove this, and we'll add it at the end, less than slash div, and let's reformat these lines by selecting them, and then press tab to add an indent. And now let's make this div a grid as well. Let's go back to our CSS, and we'll add a class to this div. Class equals, let's call it to-do dash input dash grid. And instead of writing all this CSS again, we can use a feature of CSS. So here, we're going to type a comma and enter. So when we type a comma, we can style multiple classes at the same time. So we're also going to style dot to-do dash input dash grid. If we save the CSS file, and let's also save the HTML file, now the input and the add button are also laid out in the same grid. Next, let's adjust the spacing inside our grid. So grid has some properties for this. We'll go to our CSS, press enter, and we'll use the property column dash gap. So this sets the spacing between the columns of the grid. So let's make this colon 10 pixels and save. So now it will add 10 pixels between each column. Let's add some spacing between the rows as well. And grid has another property for this. Row dash gap colon 10 pixels and save. So that will add 10 pixels of space between the rows. Now notice it didn't add space between these two rows. And that's because these two are separate grids. This is the to-do list, and this is the to-do input grid. So to add space between them, we're just going to use margin. At the bottom, we'll style dot to-do dash input dash grid. And we'll just add some margin under this grid. So margin dash bottom colon 10 pixels and save. All right, now let's move on to styling the inputs and the buttons. We'll start with the inputs first. Let's add a class so we can style them. Here, let's add a class name dash input. And down here, let's also add another class due dash date dash input. Let's save. And now inside our CSS, we'll style both of these inputs. So we'll style dot name dash input curly brackets. And first, let's make the text bigger, like the final design. We'll set the font dash size colon 15 pixels and save. Okay, so that looks pretty good. Now let's add spacing on the inside of this input. So we'll add padding 6 pixels and save. And that looks pretty good. Let's move on to the due date input. So we actually want the same styles as the name input. So again, we can use that feature of CSS. We'll type a comma and then dot due dash date dash input. So now these styles will be applied to this class and to this class. Let's save. And that looks pretty good to me. Let's move on and style the buttons. We'll go into our HTML and find the add button. Let's add a class so we can style it. And we'll use add dash to do dash button. Let's save. And then inside our CSS, we'll style that class using dot add dash to do dash button curly brackets. And let's start with the background color. We'll set the background dash color :green and save. Now let's do the text color :white and save. Now let's remove the border around our button using border :none, save. And let's make the text a little bigger. So we'll do font dash size :15 pixels and save. And the last thing we'll add is when we put our mouse over the button, it turns into this pointer icon. We can do that using cursor :pointer and save. Next, let's style the delete buttons. So these delete buttons are created in our JavaScript. We'll go into our JavaScript file, and then here, let's add a class to each of the delete buttons so we can style them. So we'll add class equals double quotes and then delete dash to do dash button. Let's save. And then inside our CSS, at the bottom, we'll style dot delete dash to do dash button curly brackets. And let's start with the background color. So we'll set background dash color : and for this design, I use the color dark red and save. So that will style our delete buttons. Now let's change the text color to white. So we'll use color :white and save. Now let's remove the border using border :none, save. And let's also make the text bigger using font dash size :15 pixels. Save. Let's add this pointer icon using cursor :pointer. Save. And let's add some padding at the top and bottom of the button. So we'll add padding dash top :10 pixels and padding dash bottom :10 pixels and save. So that's all the styles we need for the delete button. And we can also close the console to see the entire list. However, now we have another problem, which is this text and this button are not vertically aligned in the center. To vertically align in the center, we're going to go back to the grid styles. So we'll scroll up to the to-do grid, and CSS Grid has another property for vertical alignment, and that is align dash items :center to vertically align in the center. If we save, now the text is aligned with the button. But now we have a new problem. Our add button is no longer stretching to be the same as the inputs. So by default, align items is stretch. That's why this button stretches to match the inputs. And now that we changed it to align center, it's no longer going to stretch. So to solve this problem, we just have to make this grid stretch. So down here, in the to-do input grid styles, we'll change align dash items back to stretch and save. And that will cause this grid at the top to stretch vertically again. And that's it. That's all the styling that we need. And now we finished this to-do list project. In the rest of this lesson, we're going to learn more details about arrays and loops. So I'm going to put this back in the same window, and I'll rearrange this window. And now let's go back to 11 arrays and loops.html, and we'll open the tab for that file. And we can also close these other files for now. And first, let's comment out the previous code using /* and at the bottom, */. And we'll scroll down and save. The first detail we're going to learn is that arrays are references. So in the object lesson, we learned that objects are references. Arrays work the same way. So for example, if we create an array, const array1 equals the array 1, 2, 3, this variable doesn't actually contain the values 1, 2, 3. This array is saved somewhere in the computer's memory, and this variable only contains a reference that points to where this array is in memory. And that means if we create a copy of this variable, const array2 equals array1, array2 doesn't contain a copy of the values. It actually just contains a copy of the reference. So now both of these variables are pointing to the same array. So if we did array2.push 4, and then we console.log array1, and we console.log array2, and save, it will show us that even though we added 4 to array2, array1 and 2 were both modified. And that's because arrays are references. So both of these point to the same array in memory. To avoid this behavior, we can create a copy of the values in the array using a method called slice. So here, if we did array1.slice instead, this will make a copy of the values in array1. And now these two variables point to two different arrays. If we save, now you'll see that this line only affected array2. The second detail we're going to learn is a shortcut called destructuring. So at the bottom here, let's create a new array, const array3 equals the array 1, 2, 3. And let's say we want to get the first value and the second value out of this array. One way to do this is to use the index like this. Another way is to use a shortcut called destructuring. So here, we're going to replace this with ** square brackets. And now we can type some variable names. If we type first value, it will take the first value and save it in a variable called first value. If we type comma and second value, it will take the second value and save it in this variable. So this is an easier way to get values out of an array and save them inside a variable. Next, we're going to learn more details about loops. So loops have two features called break and continue. Break lets us exit a loop early. For example, let's create some new lines, and let's create a loop that counts from 1 to 10. So as usual, we can use a for loop. Let I equals 1, I less than or equal to 10, and I plus plus. And we'll console.log I and save. So this will count from 1 to 10. So now let's say that when I is 8, we want to stop this loop early. So first, let's check if I is equal to 8. If it is equal to 8, we're going to stop this loop by typing break and semicolon. If we save, once this reaches 8, break will cause this loop to stop. And now it only counts up to 8. So that's the break feature of a loop. It lets us stop a loop early. The next feature is called continue. Continue lets us skip one iteration of the loop or one run of the loop. For example, let's say we want to skip the number 3. So at the top, we can check if I is equal to 3. And if it is, we can use the code continue. This will skip the rest of this code and go back up to the top of the loop and do I equals 4. If we save, this will skip 3 in the loop. So continue lets us skip one iteration of the loop. So now let's say that we want to skip a number if it's divisible by 3. Divisible by 3 means the number can be divided evenly into 3. For example, 3 and 6 are both divisible by 3. But 7 is not divisible by 3 because there's 1 remaining. This is called the remainder. And we can calculate the remainder using the remainder operator, which looks like this. So to check if a number is divisible by 3, we can check if the remainder is 0. So here, we're going to replace this with I remainder 3, and we'll check if the remainder is equal to 0. If we save, this will skip 3 and 6 because they're both divisible by 3. Next, let's use continue in a while loop. So at the end here, we'll create some new lines. And let's say we want to count from 1 to 10 using a while loop. So we'll create a loop variable, let I equals 1, and we'll create a while loop, I less than or equal to 10, curly brackets, and the increment step, I plus plus. And inside the loop, we'll just console.log I and save. So this will count from 1 to 10 again. And let's say we want to not count numbers that are divisible by 3. So 3, 6, and 9. So at the top here, we can check if I remainder 3 is equal to 0 and curly brackets, and we might just try to do continue. However, in a while loop, continue will actually skip the increment step, and this will cause an infinite loop. So when using continue in a while loop, we have to do this increment step manually. So before continue, we have to do I++ to avoid an infinite loop. If we save, it will skip the numbers that are divisible by 3, which is 3, 6, and 9. So remember, in a while loop, if we use continue, always do the increment step manually. In a for loop, however, the increment step is done automatically after every iteration. All right, the last detail we're going to learn is how to use loops with functions. So let's say we have an array of numbers, and we want to create a copy of this array where each number is doubled. So we already have the code for this. We can scroll up, and the code for this is here. So let's actually make a copy of this code from before. We'll right-click, copy, and scroll down here. And at the bottom, right-click and paste. At the top, let's create an array called nums. So const nums equals array and 1, 1, and 3. If we save, this will create an array where each number is doubled. Now, what if we wanted to use this loop on a different array other than 1, 1, and 3? We can do that using a function. So let's create a function around this loop. We'll create function. Let's name it double array, brackets, and curly bracket. We'll remove the closed curly bracket, and at the bottom, we'll add it back. And we'll select these lines and press tab. So now, instead of doing this loop on the same array every time, we can turn this into a parameter. So at the top here, we'll create a parameter called nums. And we're going to delete this line. And we're going to loop over this parameter instead. So at the bottom, we can call our function using double array and brackets. And between the brackets, we're going to save an array into nums. So square bracket, 1, 1, and 3. If we save, this will do the same thing as before. But now, because it's in a function, we can use this loop with any array, not just 1, 1, and 3. So at the end, we can do double array, brackets, and an array 2, 2, 5 this time, and save. And it will create an array where these numbers are doubled. So using a function, we can reuse this loop for any value. Another feature of using a function with a loop is that we can break out of this loop using a return instead. So first, let's actually use a return in this function. Instead of console.log, we're going to return nums doubled. And here we're going to console.log the result. Console.log and console.log. And save. So this does the same thing as before, except we're returning the result and console.logging outside of the function. Now let's say that if we see the number 0, we want to stop this loop early. To do that, we can click here and check if num is equal to 0. And if it is, we can break out of this loop. Now, when we're inside a function, we can also use a return statement to break out of this loop. So we can also do return nums doubled. So a return statement will end this function immediately. So this is another way of ending the loop. So down here, if we add the number 0 and then 5 and save, you'll notice that the loop stops when we see the number 0. So return is another way of breaking out of a loop when it's inside a function. And that's the end of this lesson. In this lesson, we learned about arrays, which represent a list of values. We learned about loops, which let us run some code over and over, just like a loop. We learned a technique we can use with loops called the accumulator pattern, and we used it to create a to-do list project. We learned that arrays are references and the destructuring shortcut, and we learned more features of loops, like break, continue, and using loops inside a function. Here are some exercises to help you practice arrays and loops. In this lesson, we're going to learn some advanced features of functions, and we're going to use them to improve our previous projects. First, let's create a new file for this lesson. We'll go to our code editor and click here to show our files, and click here to create a new file. And we'll name this 12-advanced-functions.html and press enter. Now let's copy 11 arrays and loops into this file. So we'll click here, Control A or Command A, and then right click, copy, and in here, right click and paste. And we can close this for now. And let's prepare this file for this lesson. So we'll scroll up and change the title to Advanced Functions. And let's remove all the JavaScript code from before. And now let's save and open this file in the browser by right-clicking, Open with Live Server. Now let's also open the console on this page. So we'll right-click, Inspect, and open the console. And now we can close the previous tabs, as well as the previous files. And now we're ready to begin. So first, we're going to review how to use functions. Inside the script element, let's create a function using the word function. We'll give it a name, greeting, brackets, and curly brackets. And inside the function, we'll type the code console.log the string hello. So this is a function, and it lets us reuse code. To run the code inside this function, we can type the function name, which is greeting, and then brackets. If we save, this line of code will run the code inside the function and display hello. This is known as calling the function or running the function. So now that we understand functions, we're going to learn an advanced feature of functions, which is functions are values. So we learned many types of values in this course, like numbers, strings, and booleans. And we can save a value in a variable. For example, let's create some new lines, and we'll create a variable const num equal 2. So this will save the value 2 inside the variable num. Now functions are also values, and this means just like a number, we can save a function inside a variable. So let's give it a try. We'll create a new line and type const function 1, and we'll make this equal to a function this time. So we'll just type function and a name, greeting, brackets, and curly brackets. And inside the function, we'll type console.log the string hello 2. And we'll put a semicolon at the end, since we're saving in a variable. So this variable now contains a function. We're using the exact same syntax as before, except we're just taking this function and saving it in a variable, because functions are values. So now that this function is inside this variable, let's actually console.log it. So we'll console.log function 1 and save. And this will show us that the variable function 1 actually contains this function. Now on a new line, we can also do console.log and check the type of function 1 and save. And it will tell us that the type of this variable is a function. So as you can see, a function is just another type of value, and we can save it in a variable. We can also run the function inside this variable by typing the variable name function 1, and because this contains a function, we can actually just call it using brackets. So this will run the code inside this function. If we save, it displays hello 2. Now let's do some cleanup in this code. In JavaScript, as long as there's a way to access a function, this function name is not needed. So here, we can access this function using this variable. So this function name is not needed, and we can actually just delete it like this. And now this is called an anonymous function, which means a function without a name. Now, an interesting thing to know is that the function syntax that we've been using this entire course up here is actually a shortcut for this code. Now, even though this syntax uses var, and we usually don't recommend var, this syntax actually has a couple advantages. Number one, it's easier to read, and number two, it gives us a feature called hoisting, which means we can call this function greeting brackets before we create it in the code. So using hoisting, we don't have to worry about what order we write this code. Hoisting doesn't work when we create our function and save it in a variable like this. So in JavaScript, functions are values, and just like any other value, we can save it in a variable. Now let's think, what else can we do with a value? Well, we can save a value in an object. For example, let's scroll down and create some new lines, and we'll create an object. Const object1 equals curly brackets. And inside this object, we'll have a property num with the value 2. So this saves the number 2 inside this object. Now, because functions are values, we can also save a function inside this object. So we'll type comma, and then a property fun, colon, and we'll create a function this time. Function greeting brackets and curly brackets, and inside we'll type console.log the string hello 3. So this saves a function inside this object under the property fun. Now to access this function, we just use the dot notation as normal. So object1 dot fun. And because this value is a function, we can call it using brackets. If we save, this will run the code inside the function and display hello 3. So remember, this is called a method when we have a function saved inside an object. Again, as long as there's a way to access this function, for example, using object1.fun, then we don't need this function name. So we'll delete it and use an anonymous function. Now let's think, what else can we do with a value? We can pass a value into a function. For example, down here, let's create a function display brackets and curly brackets, and we'll give this function a parameter. So in here, we'll create a parameter and name it param. And inside the function, we can use a parameter just like a variable. So we'll console.log the param. And then down here, let's call this function using display brackets and 2. This will take the value 2, save it inside param, and then we can use it just like a variable. If we save, this will display 2 in the console. So this is known as passing a value into a function. Now, because functions are values, we can also pass a function into a function. So let's give it a try. Down here, we'll create a new function run brackets and curly brackets. And this function will also have a parameter. Let's call it param. And down here, we'll call this function run brackets. And between the brackets, we're going to give it a function this time. So we'll type function brackets and curly brackets. And inside the function, we'll type console.log the string hello 4. So this will take this function and save it inside param. And now up here, we can use param just like a variable. So we can type param, and because param contains a function, we can actually just call it using brackets. If we save, this code will run the function that we created down here and display hello 4. So this is called passing a function into another function. The function that we're passing in is called a callback function or a callback. So to summarize, functions are values. Anything we can do with a value, we can also do with a function. Now let's do some practical examples using functions as values. We're going to learn a feature of JavaScript called setTimeout. SetTimeout allows us to run a function in the future. First, we'll comment out the previous code using /* and at the bottom */. And let's create some new lines. And we're going to type the code set capital T time out. So setTimeout is a built-in function. So we can type brackets to call this function. Now setTimeout takes 2 parameters. Inside these brackets, the first parameter is a function that we want to run in the future. Let's create a function, brackets, and curly brackets. And inside this function, let's type console.log the string timeout. So here we're using a function as a value and we're passing it into another function. At the end, we'll type a comma and we'll give setTimeout a second parameter. The second parameter is how long to wait before running this function. So this is a number in milliseconds. 1000 milliseconds is equal to 1 second. So if we type 3000 milliseconds, this is equal to 3 seconds. So setTimeout will wait for 3 seconds and then call this function. If we save, after 3 seconds, it's going to display timeout in the console. So that's setTimeout. We give it a function and it will call this function after a certain amount of time. So now we're going to learn an important concept called asynchronous code. So after setTimeout, let's type console.log the string next line and save. So notice that it displays next line first, and then after 3 seconds, it displays timeout. So what's happening here? Why are they reversed? setTimeout sets up a timer, and after 3 seconds, it will call this function. However, it doesn't actually wait for the 3 seconds to finish. It just sets up the timer and immediately goes to the next line. So that's why this line is displayed first. So this is called asynchronous code. Asynchronous code means the computer won't wait for this line to finish before going on to the next line. So for setTimeout, it'll just set up the timer and then immediately go to the next line. Synchronous code, on the other hand, means the computer will wait for one line to finish before going to the next line. So all the code we've written in this course so far has been synchronous code. In addition, all the code inside this function is also synchronous code. So if we added console.log the string timeout2, and save, the code inside the function will still run line by line. It will wait for each line to finish before going to the next line. And after 3 seconds, it will display timeout followed by timeout 2. So don't worry, all the code that we normally write will be synchronous code. It will run line by line as usual. The only time that code becomes asynchronous is when we use certain features of JavaScript, like set timeout. So set timeout is the only part that is asynchronous. Now, the advantage of set timeout being asynchronous is that it doesn't block our code for 3 seconds, waiting for this timer to finish. It just sets up the timer in the background and then goes to the next line of code. So this allows our code to do other things while this timer is running in the background. And this is similar to real life. If you set up a timer on your alarm clock, you're not going to stop and wait for the timer to finish. You're going to go and do something else. Asynchronous code is the exact same concept. Next, we're going to learn a similar function to set timeout called set interval. So at the bottom, let's type the code set capital I interval. And set interval is another built-in function, so we can call it using brackets. And set interval takes the same 2 parameters as set timeout. The first parameter is a function that we want to run in the future. So let's type function, brackets, and curly brackets, and inside we'll type console.log the string interval. Now let's add a comma, and the second parameter is also a number in milliseconds. So we'll type 3000 milliseconds or 3 seconds. So set interval will run this function 3 seconds in the future, but this time it will keep running the function every 3 seconds. If we save, in the console, every 3 seconds, it will run the function and display interval. So set interval is also asynchronous. Below it, if we type console.log the string next line 2 and save, it will set up the interval and then immediately go to the next line and display next line 2. So that's set interval. We give it a function and it will keep running this function after a certain period of time. So now let's do a project using what we learned so far. Let's go to our browser and we'll create a new tab at the top. And here, let's type supersimple.dev/projects/advanced-functions and press enter. So this is basically the rock, paper, scissors game that we created earlier, except this time it has an extra button called autoplay. If we click this button, every second the computer will play by itself. So this feature will help us practice using set interval. So first, let's make a copy of the project files. We'll go into our code editor and click this icon to show our files. And let's make a copy of 10 rock, paper, scissors for this lesson. So we'll right-click, copy, and down here, right-click and paste. And I'll stop this for now. So here, we're going to change the name by right-clicking, rename. We'll remove copy at the end, and at the beginning, we'll change it to 12 and press enter. And let's also make a copy of the JavaScript and CSS files. So we'll click this file and right click, copy, and then click the folder, right click, paste, and we'll rename this file. Right click, rename, remove copy at the end, and at the beginning, change it to 12 and press enter. And let's also make a copy of the CSS file. Select it, right click, copy, click the folder, right click and paste. And right click, rename, remove copy, and at the front, change it to 12 and press enter. Now let's scroll down to 12 rock, paper, scissors. And I'll close this for now. And inside the head, let's change this to load 12 rock, paper, scissors. And we'll scroll to the bottom. And here, instead of the lesson 10 file, we'll load the lesson 12 JavaScript file. Let's save. And we'll open this in the browser by right-clicking, open with live server. So now we're ready to begin. Let's go back to supersimple.dev. And the first thing we're going to create is this auto play button. So beside the reset score button, which is here, we're going to create a new button, less than, button, greater than, and inside we'll have the text auto play. Let's save and go back to our tab. And now we have this button. So next, let's style this button with CSS. So we'll give it a class equals auto-play-button, and save. And now let's open the CSS file. I'm going to take this file and then drag it to the bottom so I can see it side by side. So I'll close this for now and rearrange this a little bit. And then down here, and we're going to style the auto play button. So let's just make the style the same as the reset score button. So in the CSS, we'll scroll down to the reset score button styles. So we'll add a comma at the end and type dot auto dash play dash button. So now these styles will apply to the class reset score button and the auto play button. If we save, now we styled our project. So next, let's make this button interactive. So at the top here, we'll add an on-click attribute. And then in here, we're going to run some JavaScript code. Let's actually create a function so we can separate the JavaScript into its own file. So we'll run a function called auto play and brackets. So now let's save. And right now, this function doesn't exist. So we have to create this function in the JavaScript file. So for me, the file's right here. I'll select it and then drag it down here so I can see it side by side. So let's scroll down. And I'm going to create it just above the play game function. So here, we'll create some new lines and type function auto play, brackets and curly brackets. And now inside this function, we want to play the game every second. So we can use set interval to run some code every second. So let's type set interval brackets And inside the brackets, we'll give it a function that we want to run. So brackets and curly brackets. And then at the end, let's type a comma and we'll give it 1000. So this means it will run this function every 1000 milliseconds or 1 second. And now inside this function, we're going to automatically play the game. And to play the game, we can use this function right here, play game. So here, we'll type play game brackets. Now we need to provide this function with a player move. And remember, we have another function, pick computer move, which will give us a random move. So above this line, let's create a variable const player move, and we'll make it equal, and we'll pick a random move using pick computer move and brackets. And finally, we'll take this move that we picked and pass it in to this function. So player move. So now when we click this button, it should play the game every second. Let's save and click autoplay. And it works. The computer is playing against itself every second. So now let's make this button stop playing when we click it again. So at the top, let's create a variable to keep track of whether or not we're playing. So we use let is auto playing, and at the start, we'll make it equal to false and save. And now inside this function, we'll check using an if statement, brackets and curly brackets. And inside this condition, let's check if we're not playing. So not is auto playing. So if we're not playing, then we want to start playing the game, which is this code down here. So let's select this code and then right click, cut, and in here, right click and paste. And also, after we start playing the game, we're going to change this variable to true. So is auto playing, and we'll make it equal to true because now we are auto playing. So now let's add the else branch to this statement. Else, curly brackets. So now we need to stop this interval. So how do we do that? The answer is that setInterval actually returns a number. And this number is like an ID. We can use this ID to stop the interval. So at the front, let's create a variable to save this ID. Const interval ID and equals. However, there's another problem here. Every time we run the function, we're going to get a different ID. So in order to save the ID from last time, we need to put this variable outside the function. So let's select this and remove it for now. And we'll scroll up. And here, we'll create the variable. Let interval ID. And we'll leave it undefined to start. And now down here, we're going to save the return value into this variable by typing interval ID equals set interval. And now at the bottom, we're going to use the interval ID to stop the interval. Let's scroll down. And to stop an interval, we can use a function called clear interval. So we'll type clear, capital I, interval, and brackets. And between the brackets, we're going to give it an ID that we want to stop. So we'll give it this interval ID. Interval ID. And then at the bottom, let's also change is auto playing to false because we just stopped it. So is auto playing equals false. And save. So now if we try out this button, it will start playing the game by itself every second. And if we click the button again, it will stop playing the game. So that's how we stop an interval. We need to save the ID and then call clear interval with this ID. So now I'll clean up the code a little by removing this extra line and save. And now we're finished with this feature. So next, let's go back to our advanced functions file. So I'll click up here, and then at the bottom, I'll open 12 advanced functions and hide the files for now. And we're going to learn some more features of functions as values. So let's actually close the other files that we opened. And first, let's comment out the previous code with /* and at the bottom, */. Let's scroll down and save. And let's open the tab for this file. So now we're going to learn another way to loop through an array. First, let's create an array. We'll type square brackets, and inside the array, we'll have the string make dinner and another string wash dishes and another string watch YouTube. So in the previous lesson, we learned how to loop through an array using a for loop or a while loop. Another way to loop through an array is using a method of the array called for each. So at the bottom, let's type dot for capital E each and brackets. So this is the for each method, and it allows us to loop through this array. Inside these brackets, we're going to give for each a function. So we'll type function, brackets, and curly brackets. So again, we're just passing a function into another function. However, this function will be a little different. We're going to give it a parameter. So up here, let's create a parameter called value. So what for each does is that it loops through the array, and for each of these values, it will save the value in the parameter and run the function. So let's console.log value and save. So this will loop through the array and display each value in the console. So let's go through this step by step. So it'll take the first value, save it in this parameter, and run the function. Then it will take the second value, save it in the parameter, and run the function. Then it will take the third value, save it in the parameter, and run the function. So the for each method is actually the preferred way to loop through an array, because this is easier to read than a for loop like this. And for each also has another feature. We can give this function a second parameter. So we can type comma, and the second parameter is the index. or the position of the value in the array. So for the first value, index will be 0. For the second value, index will be 1. Third value, index will be 2, and so on. So above this line, let's also console.log the index and save. And this will also display the index of each value. All right, now let's do a practical example using the for each method. We're going to go back to the to-do list project that we created in the previous lesson. So we'll click up here to show our files. And let's scroll up. And let's open 11todolist.js. So in this code, we used a for loop to display the to-do list on the page. We're going to switch this to using a for each method instead. So first, let's actually make a copy of the files for this project. We'll click up here, and let's click 11 to-do list, and right-click, copy, and let's click the script folder, right-click, and paste. And now we'll rename this by right-clicking, rename, remove copy from the end, and change the beginning to 12, and press enter. Let's also make a copy of the CSS and HTML file for this project. So we'll click the CSS file, right-click, copy, click the styles folder, right-click, and paste. Right-click, rename, remove copy, and at the front, change it to 12, and press enter. And finally, we'll scroll down, click 11todolist.html, right-click, copy, and then down here, right-click and paste. Right-click, rename, remove copy at the end, and at the beginning, change it to 12, and press enter. Now we can hide these files, and we can close the lesson 11 files. And now here, we're going to change the CSS file that we load to 12 to-do list. And we'll scroll down, and we'll also change the JavaScript file that we load to 12 to-do list. Now let's save, and we'll open this in the browser by right-clicking, open with live server. Okay, now let's go back to the JS file. So I'll take this file and drag it to the bottom, and I'll rearrange the windows here. And we're going to scroll down, and we'll change this for loop to use a for each method. So first, let's type above this for loop, and we'll type the array that we want to loop through, which is to-do list. And we'll type dot and use the for each method and brackets. Inside the brackets, we'll give it a function that we want to run for each to-do. So we'll type function, brackets, and curly brackets. And this function can have two parameters. The first parameter will contain each value in the array. So we'll call it to-do object. We'll type a comma, and the second parameter contains each index in the array. So we'll just call it index. And now inside this loop, we basically want to do everything that we did here. So let's just make a copy of this code, right-click, copy, and then up here, inside for each, right-click and paste. So now if we scroll up, we already have the to-do object up here. So we don't need to get it from the array like before. So we can remove this line. And let's also remove these comments. The other thing we have to change is that previously we were using I for the index, but now the index is called index. So we just change this to index. So that's how we use a for each method instead of a for loop. If we compare this code to the for loop that we had before, the for each method is easier to read. So for the rest of this course, we're going to prefer to use for each instead of a for loop. So we're going to remove this for loop. Let's scroll back up and save, and the project still works. So that's a practical example of using the for each method. Now let's go back and learn some more details about for each. We'll close the JavaScript file for now and go back to advancedfunctions.html and open the tab for this file. So in the previous lesson, we learned a feature of loops called continue. Continue lets us skip to the next iteration or the next run of the loop. For each methods don't have continue, but we can do the same thing with a return statement. So let's say in this loop, we don't like washing dishes. If the value is wash dishes, we're going to skip it and not display it in the console. So above, we'll create an if statement. And then inside the condition, we'll check if value is equal to the string wash dishes. And then in the curly brackets, if it is equal, we'll return and semicolon. So this return statement will end this function early, and it will go on to the next function. So it basically does the same thing as continue in a for loop. If we save, you'll notice that it skipped wash dishes. In the previous lesson, we also learned a feature of loops called break. Break lets us exit a loop early. Unfortunately, there's not an easy way to break in a for each loop. So if we need to use break to exit this loop early, then it's better to use a regular for loop. Let's take a break before continuing with the rest of this lesson. Here are some exercises you can do on your own to practice what we learned so far. So next, we're going to move on and learn a shorter way to write functions called arrow functions. So let's go to the bottom of this code. We'll create some new lines, and let's create a variable, const. And we'll name the variable arrow function. And we'll make it equal to brackets equal greater than or an arrow and then curly brackets. Inside the curly brackets, we'll type some code. Console.log brackets and the string hello. And we'll put a semicolon at the end. So this is an arrow function. It works the same way as a regular function. For example, we can call this arrow function by typing the variable name, arrow function, and brackets. If we save, this line of code will run the code inside this arrow function and display hello. So arrow functions mostly work the same way as regular functions. So to compare them, let's actually type above this code. We'll create some new lines and type const regular function equals the word function, brackets and curly brackets, console.log string hello. So these two syntaxes do the same thing. The difference is that instead of using the word function, an arrow function just uses an arrow. Now, parameters work the same way in an arrow function. We just type the parameter between these round brackets. So here, let's type param, and here as well. If we want multiple parameters, it also works the same way. Up here, we can type comma param2, and down here, comma param2. And finally, return statements also work the same way. So in this function, we can return 5, and in the arrow function, we can also return 5. So now let's learn some differences between these two. Arrow functions have a few shortcuts that regular functions don't have. For example, at the bottom, let's create an arrow function using const, and we'll name it 1param, and make it equal to an arrow function, brackets, arrow, and curly brackets. Now in this arrow function, we're going to give it one parameter, param. And inside the function, we'll console.log param plus 1. So when an arrow function only has one parameter, these round brackets are optional. So we can actually remove them. If we do 1 param brackets 2, if we save, it will display 2 plus 1, which is 3. Let's learn another shortcut. We'll create some new lines and type const 1 line and make it equal to an arrow function, brackets, arrow, and curly brackets. And inside, we'll return 2 plus 3. So when an arrow function only has one line like this, we can actually put it on the same line as the arrow. And now that everything's on the same line, the curly brackets are actually optional. So we can remove them, and we can also remove the return statement. So this is a one-line arrow function. If we just have an arrow, it will automatically return the result on the right. So at the bottom, we can console.log and call the one line function with brackets. If we save, this function will return 2 plus 3, and it will display 5 in the console. So that's arrow functions. It's a shorter way of writing a regular function, and it has a few shortcuts. For now, let's get some practice using arrow functions. So let's scroll up in this code to the for each method. So let's use an arrow function here instead. We just have to remove the word function, and after the round brackets, add an arrow. equals greater than. If we save, the loop still works. So when we're passing a function into another function, like for each, it's recommended to use arrow functions because it makes our code easier to read. So now let's use arrow functions in some of our previous projects. We'll start with the rock, paper, scissors game. Let's open our files by clicking here, and we'll find the 12 rockpaperscissors.js file. And then inside this file, we're going to scroll down to the autoplay function. So here, we're passing a function into another function. So it's recommended to use an arrow function. Let's remove the word function and add an arrow. So now this code is a little easier to read. Now, what about this function up here? Function autoplay. Should we also switch this to an arrow function? So this situation is more personal preference. So above this, let's actually create an arrow function version of this. Const autoplay equals brackets and arrow and curly brackets. So even though we could create an arrow function version of this, I actually prefer the regular function syntax here for two reasons. Number one, I think this is easier to read than this. And number two, this function syntax enables hoisting, which means we can call this function before we create it, and we don't have to worry about which order we write the code. So for these reasons, I actually prefer this situation to use a regular function syntax and not an arrow function. So we'll comment out the arrow function using // and //. Now let's save, and let's open the tab for this project, and we'll give it a try. So click autoplay, and this still works after replacing with an arrow function. Next, let's go to the to-do list project and switch to arrow functions. So we'll go to our code editor and find the to-do list project, which is here. And let's scroll down. So inside render to-do list, we're using for each, and we're passing this function into another function. So it's recommended to use an arrow function here. So we'll remove the word function, and after the brackets, we'll add an arrow. And again, I'll leave this function syntax as a regular function because it's easier to read and enables hoisting. So let's save and go back to our to-do list, and everything still works. Next, let's go back to 12 advanced functions.html, and we'll scroll to the bottom, and we'll open the tab for this file, and we'll review another place we could use arrow functions, which is inside an object. So at the bottom here, let's create a new object, const object2 equals object. And then inside, let's type the property method, colon, and an arrow function, brackets, arrow, and curly brackets. So even though we could save an arrow function inside an object like this, objects already have a shortcut for functions. So at the bottom, we could just type method, brackets, and curly brackets. So this syntax is called the shorthand method syntax. So this shorthand method syntax is actually easier to read than an arrow function. So when saving a function in an object, it's actually recommended to use this syntax instead. There's also another difference between regular functions and arrow functions, but we'll learn about it later in this course because it's a more advanced feature. Now let's move on, and we're going to learn another improvement we can make to our projects. So let's comment out this code. We'll scroll up and type /star, and at the bottom, // and save. And next, we're actually going to scroll up to the very top of this file. And we're going to create a button on the page. So inside the body, we'll type less than button greater than. And inside the button, we'll have the text click. Now let's say that we want to run some JavaScript code when we click this button. So here we can type on click equals double quotes and write some JavaScript inside this double quotes. Now we're going to learn a better way of doing this called add event listener. To use add event listener, first we're going to get this button and put it into our JavaScript using document.querySelector. So let's add a class to this button so we can select it, and we'll set it to JS-button. And now inside the script element, we're going to use document.querySelector brackets and the string dot JS-button. So now let's save this button in a variable so we can use it later. At the front, we'll type const button element equals this result. Now every HTML element has a method called add event listener. Add event listener lets us run some code when we interact with the element. So it sort of does the same thing as on click. So at the bottom, let's type button element dot add capital E event capital L listener and brackets. So add event listener has two parameters. The first parameter is the event, or what type of interaction we want to listen for. So between these brackets, let's type the string click. So this will run some code when we click the button. The way to find these event names is to look at this attribute. The word after on is the event. Next, the second parameter is a function that we want to run when we click this element. So we'll type a comma, and because we're passing a function into another function, we're going to use an arrow function. So we'll type brackets, arrow, and curly brackets. So inside here, let's just do console.log string click and save. And now when we click this button, it will run this function and display click. So this code does the same thing as the onClick attribute. However, add event listener has some advantages over using an attribute. First, it lets us add multiple event listeners for an event. For example, let's add another click event listener. We can select this code and right-click, copy, and then down here, right-click and paste. And let's change this to log click to. If we save and click the button, it will run both of these functions. So add event listener lets us add multiple listeners to one event. Another advantage of doing this is that we can remove an event listener using a method called remove event listener. So under this code, we can type button element dot remove capital E event capital L listener and brackets. And remove event listener also has two parameters. The first parameter is the event. So in this case, it is the string click. And we'll type a comma. And the second parameter is the function that we want to remove, so that when we click this button, it will no longer run that function. Now, we can't just type a copy of this function. We need to use this exact function inside remove event listener. To do that, we'll save this in a variable first. So above this, let's create a variable const event listener equals, and we'll select this code, right click, copy, and in here, right click and paste. And now we'll replace this with the variable event listener. And down here, we'll remove this same variable, event listener. If we save and click the button again, it will only display click to because we added this event listener and then we removed it. So it will no longer run this function when we click the button. So as you can see, add event listener gives us more control over event listeners. We can add multiple listeners to an event, and we can also remove a listener from an event. So because of these advantages, the best practice is to use add event listener instead of an onClick attribute. So let's go back into our projects and switch to using add event listener. We'll start with the rock, paper, scissors project. So we'll open our files and we'll open 12 rock, paper, scissors and click here and save. And we'll scroll up to 12 rock, paper, scissors.js. And for the video, I'll drag this down to the bottom. And I'll hide the files for now. And then rearrange the windows. And finally, open the tab for this file. Now let's go to the HTML. We'll scroll up to these move buttons, which is up here. So here, we're using the onClick attribute, and we're going to switch it to add event listener. So first, let's get this button into our JavaScript. We'll add a class so we can select it, js-rock-button, and save. And then down here, let's go below the autoplay function right here. And we'll use add event listener. So we'll get this button into our JavaScript using document.query selector brackets and a string dot js-rock-button, and we're going to use dot add event listener brackets. So we're going to listen for a click and a comma, and we'll give it a function that we want to run. So a common mistake here is to actually run the function. For example, play game brackets and the string rock. So we're supposed to give a function to add event listener. However, this doesn't result in a function. This will actually run play game and give us the return value, which is undefined. So this code will actually result in undefined. And then we're giving undefined to add event listener. So it won't work. So in order to give add event listener a function, we need to create a function here. So let's remove this code and we'll create a function using brackets, arrow, and curly brackets. And then inside this function, we're going to call play game. So we'll type play game, brackets, and rock. So now when we click the rock button, it will run this function and play the game. So let's remove the onClick attribute and save the HTML and also save the JavaScript, and then go to our project and click the rock button. You can see that it works, except this time we're using add event listener. So let's do the same thing for the paper and the scissors button. Feel free to pause the video if you want to try it yourself. So we'll scroll down here and let's add a class to the paper button so we can select it, js-paper-button, and then in our JavaScript, we'll make a copy of this code. So right click, copy, and then down here, right click and paste. And now we're going to replace the rock button with paper. And when we click this button, we're going to play the game with paper. Now let's save, and we'll remove the onClick attribute and save the HTML. If we click the paper button, it works as before. Finally, let's do the scissors button. So we'll add a class js-scissors-button, and then inside our JavaScript, we'll make a copy of this, right click, copy, and then down here, create some new lines, right click, and paste. And now switch to the scissors button and play game with scissors. Let's save and remove the onClick attribute, save the HTML, and try the scissors button. So everything still works. And I'll leave switching the reset score button and the auto play button as exercises. So now let's try add event listener with a different event. We'll use it with key down. So let's say that in our project, we want to make it so we can play the game with our keyboard. If we type R, it will play rock. If we type P, it will play paper. And if we type S, it will play scissors. Let's go into our JavaScript and we'll scroll down. And we're going to add an event listener to the body this time, so that if we type anywhere on the page, we can run some code. So we're going to get the body element using document.body and then .add event listener and brackets. This time, the first parameter or the event will be the string key down. And let's type comma and give it a function that we want to run. brackets, arrow, and curly brackets. Inside here, let's just type console.log key down for now and save. So now if we go to the project and we open the console, right click and click inspect, click the console, and then click on the page. If we type a key on our keyboard, it will run this function and display key down. So now we have to check what key was pressed and play the game. So how do we know which key that we pressed? Earlier in this course, we used the attribute onKeyDown, and we learned that it gets a special object called event, and the event object contains which key was pressed. addEventListener also provides this event object, but it provides it as a parameter to this function. So inside the round brackets, let's add a parameter event. Now every time we type on our keyboard, addEventListener will save the event object in here and run the function. And this event object contains the key that we pressed. So in the console.log, let's display event.key this time and save. Now if we click on the page and type R, event.key will contain R. If we press P, event.key will contain P. So that's how we know which key we pressed. So now let's close this. And instead of console.log, we'll create an if statement to check which key we pressed. So if brackets and curly brackets. And here we'll check if event.key is equal to the string R. If it is, we're going to play the game with rock. So inside here, we can just run this play game function. Play game and brackets, and inside we'll type the string rock. Now let's check if we pressed P. So we'll add another branch, else if brackets and curly brackets. And in this second condition, we'll check if event.key is equal to the string P. If it is, we'll play the game with paper. So inside here, we'll run play game brackets and the string paper. And finally, we'll check if we pressed S. So at the end, we'll add another else if brackets, curly brackets, and inside here, we'll check if event.key is equal to the string S. If it is, we'll play the game with the string scissors. Now let's save, click our page, and type R, and it plays a game with rock. If we type P, it will play the game with paper. And if we type S, it will play the game with scissors. So that's an example of using addEventListener with a different type of event, with a key down. If we need the event object, we can get it using a parameter up here. So those are all the features we're going to create for our rock, paper, scissors project. Now let's move on to the to-do list project and switch to addEventListener. We'll go into our code editor, click up here, and find 12todolist.html. We'll also scroll up to the scripts folder, find 12todolist.js, and open this file. And I'm going to put it at the bottom here. so I can see it side by side. I'll close this for now and close rock, paper, scissors, and then open the tab for this project. Okay, so let's start by switching the Add button to use Add Event Listener. We'll go into our HTML and find the Add button, which is here, and we're going to add a class so we can select it in JavaScript. JS-add-to-do-button. Now let's go to our JavaScript and scroll down. Above the Add to Do function, we'll get this button into our JavaScript using document.query selector brackets and then a string dot and the class we want to get, js-add-to-do-button, and then after this we'll use dot add event listener brackets. Inside these brackets, we'll give it the event, the string click, comma, and then a function to run when this event happens. So brackets, arrow, and curly brackets. And in here, we just want to do the same thing as the onClick attribute, which is add to do and call this function. Let's save. And then in the HTML, let's remove the onClick attribute and save. And let's try it out. So we'll type a to do, watch YouTube, select a due date, and then click add. And the add button still works as before, but we're just using add event listener. Next, let's switch all the delete buttons. Let's scroll up to where we create these delete buttons, which is here. And first, we'll add a class to all the delete buttons so we can select them in JavaScript. js-delete-to-do-button. And now we're going to use document.query selector and add an event listener to all of these buttons. However, there's two problems here. First is that at this point in the code, this is just a string. We haven't actually put this button on the page yet. We do that down here in this line of code. We put the HTML that we generated onto the page. So in order to add an event listener, we need to put the HTML on the page first. So we have to do it after this code. So down here, we're going to type document.query selector brackets and the string dot, and we'll select this class, js-delete-to-do-button. However, there's also a second problem here, which is we're going to have multiple delete buttons, and query selector only gives us the first one. So how do we select all the buttons on the page that match this criteria instead of just the first one? To do that, the document object has another method called query selector all. So query selector all will give us all the elements on the page that have the class js-delete-to-do-button. So down here, let's console.log this result to see what it looks like. Console.log brackets and close bracket and save. And then here, right click, inspect, and the console, and expand this. you'll see that document.querySelectorAll gives us a list of elements. And this list works just like an array. This is index 0, or the first button, and this is index 1, which is the second button. So now let's remove console.log and add event listeners to all of these buttons. To do that, we're going to loop through this list of delete buttons. So again, this list works like an array, so we can use a for each method to loop through it. So at the end, let's type enter and tab, and then dot for each and brackets. As usual, we'll give for each a function that we want to run for each of these values. So we'll type brackets, arrow, and curly brackets. And now every time we loop through the list, for each will give us two parameters. The first one is a value in the list, which is a delete button element. So let's name it delete button. And we'll type comma, and the second parameter is the index. So index. So now we want to add an event listener to each delete button. So inside here, we'll type delete button dot add event listener and brackets. Inside these brackets, we'll tell it what event we want to listen to, which is the string click and comma, and then a function that we want to run when this event happens. So brackets, arrow, and curly brackets. So now when we click a delete button, we want to do the same thing as this onClick attribute above. So let's select this code. We'll right click, copy, and then down here, right click and paste. And now we can remove these characters because we're not in a string anymore. And that's all we need to do. So to summarize, we used querySelectorAll to get a list of all the delete buttons on the page, and then we looped through the list using for each. And for each delete button, we added a click event listener and ran the same code that we did before. So now we can scroll up and remove this onClick attribute and save, go back to the page, close the console, and try out the delete button. And you can see that it still works. So that's how we switch the to-do list project to use add event listener. So now we're finished improving all of our projects. In the rest of this lesson, we're going to learn more features that use functions as values. So let's close this for now, and we'll go back to 12 advanced functions.html. And we'll open the tab for this file. And let's also comment out this JavaScript code using /* and */. Let's save. And now let's scroll to the bottom of this code and create some new lines. So in this lesson, we learned the array method for each, which lets us loop through an array. Now we're going to learn two more array methods called filter and map. So let's start with filter. Let's say we have an array of numbers and we want to create a copy of this array with all the negative numbers removed. So let's go up here and create an array of the number 1, -3, comma 5, and type the method dot filter and brackets. So filter works the same way as for each. We give it a function, so bracket, arrow, and curly bracket. And this function has two parameters, the value and the index. So filter will take the first value, save it in here, and run the function. Then it will take the second value, save it in here, run the function, and the third value, save it, and run the function. Now the only difference is that this time, this inner function will return a value. So we'll type return. And we're going to return a Boolean, like true. So now the return value matters. So what filter does is it creates a new array. If the inner function returns true, it will put this value in the new array. If the inner function returns false, it will not put this value in the new array. For example, at the front, let's console.log the result of this. So we'll type console.log, open bracket, and down here, close bracket, and save. So in this example, the inner function always returns true, so all three values will be in the new array. If we change the return value to false every time and save, all three values will not be added to the new array. So now let's use this to solve our problem. We want to remove the negative numbers from this array. So inside this inner function, we're going to return true if the number is positive and return false if the number is negative. So we'll check if value is greater than or equal to 0, curly brackets, we'll return true and include it in the new array. Else, we'll return false and not include it in the new array. So let's remove this and save. So now only values that are greater than 0 will be in the new copy. So using this, we can sort of filter out values based on a criteria. That's why this method is called filter. Now we can shorten this logic by using this code. Return value greater than or equal to 0. So this comparison will return true if it's greater than or equal to 0, and it will return false otherwise. So this line does the same thing as this code up here. So we can comment this out with /* and // and save. And as always, we can return a truthy or falsy value instead of just true or false. The last array method we're going to learn is called map. So let's create some new lines and scroll down. And let's say we have an array of numbers again, like the array 1, 1, 3. And we want to make a copy of this array with each number doubled. So at the end, we'll type dot map brackets, and map works just like for each and filter. Between the brackets, we'll give it a function, bracket, arrow, and curly brackets. And this function will get two parameters. The first parameter is each value in the array, and the second parameter, comma, is the index. So map will take the first value, save it in this parameter, and run the function. Take the second value, save it in this parameter, run the function. Third value, save it, and run the function. And inside this function, we're going to return a value. So what map does is it creates a new array, and then whatever we return will be added to the new array. So if we return 10, and then we console.log this result, console.log, and close bracket, and save, it will create an array where each value becomes 10. Now, the interesting thing is that we can actually use the value itself in the return. So here, if we did value plus 10 and save, it will take each value in the original array, add 10, and put it in the new array. So map will transform an array into another array based on the return value. So if we want to return an array where each number is doubled, we just have to multiply each value by 2 and save. And this will give us 2, 2, 6. Next, we're going to review some shortcuts of arrow functions to make this code more compact. First, let's make a copy of this code. Right-click, copy, and down here, right-click and paste. So notice in the inner function, we're not using index. So let's just remove it for now. And now that this arrow function only has one parameter, these round brackets are optional. So we can also remove these to make the code more compact. Another shortcut is if we only have one line of code in an arrow function, we can put the code on one line like this. And now the curly brackets and the return are optional. So we can actually just remove all of this code. So if we have just an arrow, it will automatically return this result on the right, and we don't have to type return ourselves. So this code does the same thing as the code above. But as you can see, these shortcuts make our code very compact and clean. So let's save, and this will give us the same result. The last thing we're going to learn in this lesson is a feature of functions called a closure. A closure means if a function has access to a value, it will always have access to that value. So let's take a look at an example. We're going to go back to the to-do list project. So we'll click up here and then scroll up to 12todolist.js and close this, and then open the tab for the to-do list, which is here. And let's scroll down to the query selector all. So we're going to focus on this inner function here. So notice that this function uses index from above. Now the interesting thing about index is that as soon as this for each ends, index gets deleted. For example, if we add some new lines and we try to console.log index and save, and then go into our project, right-click, inspect, and the console, it'll tell us that the index is not defined. So as soon as we end the for each loop, index doesn't exist anymore. However, if we move this into the inner function, so inside here, and we console.log index and save, and we click a delete button, it will tell us that the index is 0. So even though index gets deleted right away down here, if we click one of these buttons later on, it still has access to index. This feature is called a closure. If a function has access to a value, it will always have access to that value. The value, like index, gets packaged together or enclosed with the function. That's why we call it a closure. So even if the value index gets deleted after the loop, we can click the delete button 5 seconds later or even 5 minutes later, and this function will always have access to index. So closures are something that naturally happens as we write JavaScript code, and it's nice to know how this feature works. There are some advanced techniques that we can do with closures, but they're not used that often, so I won't be covering them in this course, but maybe in a different video. Now let's remove console.log and save. And that's the end of this lesson. In this lesson, we learned that functions are values. We learned set timeout and set interval, which lets us run a function in the future. We learned an array method called forEach, which is a cleaner way of looping through an array. We used forEach, arrow functions, and add event listener to improve our projects. We learned 2 more array methods, filter and map, and we learned a feature of functions called closures. Here are some exercises to help you practice what we learned in this lesson. Here are some projects you can try on your own to practice combining everything we learned in this course. These projects are open-ended, meaning it's up to you how they look and work. You can find example solutions for these projects in the video description. So that's the end of part 1 of this course. Great job in making it this far. In this part of the course, we learned all the major features of JavaScript, and now we know everything we need to build projects. In the second part of this course, we're going to focus on building bigger and more complex projects, and we're going to start and finish the final Amazon project. Along the way, we're going to learn advanced techniques like the ones listed here that are useful for bigger projects. Also, from now on, I'll be posting one lesson at a time as soon as I finish them, and then combine them all together at the end. If you want to be notified of future lessons, you can click the subscribe button below the video. If you want to learn HTML and CSS in more detail, you can check out my HTML and CSS full course here. If you want to support this channel, you can like this video and recommend this course to anyone you know who is interested in learning JavaScript. Thanks again, and I'll see you in the next one.